Hello everyone. In this video, we'll be implementing one amazing project with the help of HuggingFace called Text Summarization. So as of now, I showed you the HuggingFace demo, like how we can use this HuggingFace platform, how we can access different model, even how we can also fine tune those are the model on top of our custom data. So in this video, we'll be using the same technique and we'll be implementing one project called Text Summarization. Okay. So here is the notebook, guys. I already prepared. So the first thing what you have to do, first thing, just connect the notebook and make sure you change the runtime to the GPU, because here you need the GPU if you want to, let's say, implement this project, because here we'll be fine tuning one transformer based model. Okay, we'll be fine tuning one LM model here on top of our custom data. I'll tell you which model we're gonna fine tune, even on top of which dataset actually we're going to fine tune. But first of all, let me tell you what is text summarization. Text summarization means, let's say you are having a bigger paragraph and you are summarizing that particular paragraph. I think you know, okay, what is the summary, right? What is the text summarization project? So in internet, actually, you will be getting different summarization actually application. Let's say if I write text summarization online. So there are so many application you will see. This is another application from Quillbot actually. So here actually you can also give any kinds of text and it will give you the summary. So let me show you. If I search for English story, so what I can do, I can copy this text as of now as it is, and here let me paste it. Now if I click on summarize button, you will see that it will give me the summary of the entire text. Now you can also control like how much summary you need. So let's say I need a little bit bigger summary. Now if I again re-summarize, now see this result I'm getting, this is the actually a little bit long than our previous summary. Okay, so that's how actually we're having different application over the internet. So we'll be implementing this kinds of project, but here I'm not going to implement a user interface. User interface wise we'll be implementing later on. So as of now, we'll be only doing the experiment on the collab notebook. Okay, we'll be using transformer based model, we'll be using LM model, and we'll be doing this kinds of project. Okay, this is the main objective here. So let me get back to my collab notebook, and first of all let me execute this command. So this command will show you which GPU actually you are using. So here I'm using Tesla T4 GPU because here I'm using free Google Colab. Now the first thing what you have to do, you have to install transformer library. Okay, why? Because here we'll be using HuggingFace actually platform, and to use HuggingFace platform I already showed you, you have to install transformer library. Apart from that, you need some additional package like sentence pieces. Okay, then you need Scareblue, then row score, okay, and Pi7Zer and datasets. Why dataset? Because with the help of datasets we'll be downloading the dataset from the HuggingFace itself. Okay, that is why. And these are the dependency packages you also need to install here. Fine, so let me install all the packages one by one. So my installation is completed. So the next thing what you have to do, you have to update some of the packages. The first package you have to update called Accelerate. Then you have to uninstall your older version of Transformer and Accelerate, and you have to install the latest one, because what happens actually in Google Colab, sometimes they're using older version of the Transformer package and Accelerate package. Okay, so that's why I'm updating it again. Okay, that's the things you have to do. And what is Accelerate? See, Accelerate will help you actually to access your GPU. That means here you are using the GPU, you are using something called CUDA. Okay, so to use your CUDA actually instance, this Accelerate will help you. So whenever it will do the fine tune operation, that time actually it will access your GPU, right? So that's why actually this package is required. Now let me update all of them. So as you can see, update is successful. There is no error. That means everything is working fine. Now the next thing, you have to import some of the necessary library to test whether everything is working fine or not. So here you can see I'm importing pipeline. Then I'm also importing load dataset from the dataset. Okay. And apart from that, I'm also importing some additional library. Okay, some extra library also I'm importing here. It is not required, but what the library actually I'm going to use like later on I'll tell you, okay, why I'm using that one. So as of now, let me import all of them. See, this execution is fine. That means there is no error. We have successfully installed all the packages. Now I think I already imported Torch, so I don't need to import this line. I can delete. Now the first thing what I have to do, I have to check the device, okay, whether it is utilizing my CUDA or whether it is utilizing my CPU. So as I already showed you, I have changed my runtime to the GPU, right? And here you can see it is connected with my T4 GPU. That means it should use my CUDA. So let me check. See, it is utilizing my CUDA. So here I'm using Torch, PyTorch library to check it, whether CUDA is available or not. If yes, print CUDA, otherwise print CPU. So you don't need to manually set your machine type. So if you have the GPU installed in your system, and if all the tools and let's say services are already installed, so it will utilize that particular GPU, that means your CUDA. Otherwise, it will automatically utilize your CPU. Okay. So if you see any kinds of PyTorch implementation, PyTorch use this particular code snippet, okay, to map with your CUDA or with your CPU. I hope it is clear. Now, the first thing what I have to do, I have to load my Tokenizer. Okay, Tokenizer. And what is Tokenizer? I already explained. With the help of Tokenizer, we'll be pre-processing our data, and I will be converting my text to vector representation. So for this, I'm going to import auto tokenizer from transformer library. And another class I have imported auto model for sequence to sequence LM, because here we'll be loading one LM model. That means we'll be loading one transformer based model. And to load the transformer based model, actually you have to use this particular class. Fine. Now let me import this package. Now here is the model checkpoint, guys. So here we'll be using one model called Google Pegasus CNN Daily Mail. Okay, so this is the transformer based pre-trained model, and this is the model, guys. This is from Google. So Google has trained this model, and this model can perform text summarization. Okay, now if you want to test it, here is the inference API. Now here you can see it will give you the summary. Okay, summary of the entire text. Now you can see what kinds of data set they use to train this model. Every information they have given, okay, about the model. So if you're interested to deep dive, you can check this documentation. You can check this model kit. You will see each and every details. Now, if you want to see the model, just click on files and version. You will see the GB of the model. It is around 2.28 GB, and there is another file. It is around 3 GB. Okay, so total I think 5 to 6 GB this particular model. So whenever I will download this model, you will see that. Okay, what is the model size as of now? Let's get back. So now let's load the tokenizer, and I already told you the model actually will be using the same model you have to use for the tokenization as well. Fine, this is the idea. Now let me load the tokenizer. So for this, I'm using auto tokenizer from pre-train, and here I'm giving the model checkpoint. It will automatically download from the HuggingFace itself. So fine, I have already downloaded the tokenizer. Now we'll be downloading the model. Okay, so to download the model, I'll be using this class auto model for sequence to sequence LM, this class, and there is a function called from pre-train. You have to give the model checkpoint and to device, in which device you want to load the model. I want to load the model inside my GPU. Okay, that's why I'm giving GPU to device is equal to my device. Now let me load it. Okay, my model has also loaded. Now we'll be loading the dataset, and dataset wise we'll be using one dataset named Samsung dataset. So this is the dataset, guys. So this dataset is from Samsung actually. So they have published this data. And the Samsung data is nothing but it's a dataset containing about 16K messenger like conversation with summaries. That means it is having actually different conversation. Okay, and in the another column actually it is having the summaries, okay, of that particular, let's say, conversation. So if I show you, let's say this is the conversation. Okay, this side you are having the conversation, and this side you are having the summary. So let's say this is the conversation, and this is the summary. Okay, again this is the conversation, this is the summary. So that's how they have collected the entire data, and it is having 16K actually messenger like conversation data. Fine, and the dataset name is Samsung data. And if you want to see the dataset is split, so it is having around 14,732 example for the training, validation that many example, and testing that many example. Fine. So again, you can see this documentation if you want to learn more about this data. Now let's download the data. So for this, I'll be using load dataset from my dataset package. Now let me download the data as well. Now I'll give yes, and I'll press enter. It should download the data. Okay, now if I show you the dataset metadata. So this is the metadata, guys. So as I already told you, it is having a dialogue and summary, and that many of example you are having for the training, testing, and validation. Fine. Now if you want to see any kinds of, let's say, dialogue, that means your entire, let's say, conversation, you can also visualize. So let me visualize one of the example. So this is the dialogue, guys. You can see Olivia is telling, who are you voting for this election? Then Olivia is saying liberal as well, and Olivia, me too. Olivia, great. Okay, so this kinds of conversation it is having, and based on that it is having one summary. So let me also show you the summary. So I'm printing the summary here. You can see, so Olivia and Oliver are voting for the liberals in the in this selection. Okay, so this kinds of actually data set they have prepared. Now this particular code snippet will print the number of example you are having in this data set, as well as the split length and the, let's say, entire dialog and entire summary. Now let me show you. See, this is the split length, this is the training, validation and testing, and these are the features it is having, like ID, dialog and summary, and this is the entire dialog you can see. Okay, and this is the summary of the dialog. So this is the preview of the data, that's why I just printed. I just wanted to show you, okay, what kinds of data they collected. Now let's say you are having some different kinds of data. So what you can do, you can give your, let's say, entire, let's say, paragraph as a dialog and the summary as a summary. Okay, and you can follow the same approach. Okay, it doesn't matter. Now the next thing what I have to do, guys, I think remember, I have to pre-process my data and convert to the vector representation. So for this, what I have to use my tokenizer. Okay, I think you know. And on top of which actually, let's say, column I have to apply my tokenizer on that dialog, because dialog is my actually paragraph. And again, if you see the summary is also a text. Okay, so I also need to apply the tokenizer on top of the summary as well. So here I've written a function convert example to features. So it will take the example batches, that means your dialog and summary, and it will perform the tokenization operation. You can see. So first of all, I'm applying tokenization on top of my dialog. Then I'm applying tokenization on top of my summary. Then whatever results actually I'm getting, I'm just returning. That means you will get input IDs, attention mask, as well as the labels. I think I showed you. Okay, from that example. Now let me execute. And now let me map this function on top of my entire data set. Okay, so see here I'm doing the map operation. Now first of all, let me convert to vectorization, then I will show you, okay, how it will look like. So see, execution is done. Now if I show you my data set right now, see it is having different features: ID, dialog, summary, input IDs, attention mask and labels. Okay, because I converted to the vector representation right now. Now if you want to see the input IDs, so this is nothing but your input IDs. That means this is the vector representation of the first dialog. Okay, and if you want to see the attention mask, you can also print the attention mask. So this is the attention mask. That means it is giving all the word as the same attention. I already explained this part. Fine. And if you want to print the label as well, that means the summary, you can also print it. Let me show you. So here I will print the labels. So this is the labels. Okay, that means this is the summary of this dialog. Fine. I hope it is clear. Now we'll start the training, but before that, what I have to do, I have to set some training arguments. I think you remember, right? But before that, one thing you have to do, if you're using a large amount of data, so you have to initiate this data collator. Okay, so what data collator will do? Data collator will help you to load your data as a batches in the memory. See, here you are having so many examples I showed you in the training, validation and testing. So I don't need to load the entire data in my memory, because here if you see my memory size, I got actually 12 GB RAM. So if you're having huge amount of data, so 12 GB RAM is not enough. So for this, what you can do, you can load your data as a batches. That means some amount of data will be loading. You will be training again. You'll be taking another batches again. You will be training. That's how you can perform the operation. So this data collator will help you to load your data as a batches. And if you want to define the data collator, you have to use this class from transformer, data collator for sequence to sequence. So here you can see I'm passing my tokenizer and model inside the data collator. Fine. Then you have to initialize this data collator object. So let me initialize it right now. Now the same thing, you have to set the training arguments. So as I already told you, just keep all the arguments as same. No need to change anything. Only you can change the number of epoch. Okay, you will be training. So as of now, I'll be showing you only one epoch training because again, it will take time. We are using free Google Colab. Okay, and the output directory I want to create Pegasus Samsung. Okay, so it will create our output directory Pegasus Samsung. Inside that, it will save all the artifacts. Fine. So let me initialize the argument as well. Then I will initialize my trainer object. So it will take the model, your training argument, tokenizer, data collator, and you have to pass the training data. Now see here, one small hack actually I'm doing. See, if you see the training data size, it's very huge. So as I already showed you here. So that many training example, it is having almost 15,000. So if I'm taking 15,000 data for the training, it will take lots of time. And this is my validation and testing. So what I'm doing actually, instead of taking the training data, I used actually test data as my training data, because inside test data, I'm having very less example. So that I want to show you the quick training. But if you are training actually, okay, if you are doing the actual training, that time you just use train data. Okay, not the test data. So this is the hack, guys, small hack I'm doing, because if you want to experiment something and you don't have that much of time, so what you can take a small amount of data and you can perform the let's experiment. Okay, so that is what actually you can perform. And here you can see evaluation data. I'm giving my validation data. It's completely fine. Okay, now let me initialize my trainer. Now if you want to start the training, you have to call trainer.train. Now it will start the training of the model. So it will take some time, so I will pause the video, and once training is completed, I'll come back. Okay, so my training is completed. Now here you can see my training losses and different metrics that it is giving, but you have to check the training losses. So this loss should be close to 0, guys. Okay, if it is close to 0, that means your model is performing well. Now if you want to evaluate this model on top of the test data, you have to use this function, calculate metrics on test DS. Okay, so here you will be calculating something called row score. Okay, what is row score? See, row score is a metrics for the summarization model, text summarization model. You can search on Google, you will find the row score actual equation. But as of now, I won't suggest, don't deep dive into the equation. Just try to consider it just a evaluation metrics. Like for the classification, actually what evaluation metrics we used to use, like accuracy score, then we used to use confusion metrics, AUC curve, right? And here we are performing something called text summarization, and text summarization uses one metric called row score if you want to evaluate that model. So similar wise, for language translation, we use another kinds of metrics. For let's say name entity recognition, we use another kinds of metrics. For let's say conversational agents, we use another kinds of metrics. Okay, all kinds of tasks is having their different evaluation metrics. Okay, this is the main idea here. Now before that, let me show you the models actually it has trained. Now inside Pegasus Samsung folder, this is the checkpoints. Inside that you can see this is the model actually it has trained. Now we'll be saving this model as well. So just let me first of all show you the evaluation metrics, then I will say tell you how we can save the model. And now you can ask me where I got this function. See, if you just go to the HuggingFace that documentation, go to the text summarization task, you will see that they are suggesting this function. Okay, so they're suggesting if you want to perform the evaluation on top of the let's say your text summarization model, you can use this row score function. Okay, this is the idea. Now here we'll be calculating our row score. So here you are having actually 4 kinds of row, like row 1, row 2, row large, and row L sum. Okay, now let me calculate the row score. First of all, I will be loading all the row matrices. I have to give yes. Then I will be calculating the score on top of my testing data. Okay, now let me execute. And again, I'm only taking 10 example, guys, because it is having actually lots of data and it will take time. That's why I have taken only 10 example. But if you are performing actually, so but you can remove this line. That means you are performing on top of the entire data right now. Fine. This is the small hack you can follow if you're doing the experiment only. Now see, guys, this is my row score I got. Now guys, you can see I got the row score, and this row score should be close to 1. Okay, if it is close to 1, that means your model is performing better. So as of now, we used our test data for the training and we only trained one epoch. That's why this row score is not good. Okay, but if you're using actual training data and if you train multiple epochs, you will see that you will get a good row score here. Fine. Now let's save the model, my Pegasus model. So I'm using save pretrain function, and here I'm giving the name, so it will save my model. So now if I refresh, you can see my model has saved. So this is my model, Pegasus model, my trained Pegasus model. Then I also need to save my tokenizer, because later on I will be giving my let's say testing data, and if I want to do the let's say summarization task, that time it will also convert that data to the vector representation. Now see, this is my tokenizer. I also save. Fine. Now if you want to load any kinds of pretrain tokenizer, what you can do, you can use auto tokenizer from pretrain. Now you can give your tokenizer location. Okay, now see, here I'm giving my tokenizer location, not the tokenizer we downloaded from the HuggingFace. Okay, now let me load my tokenizer. So this is my custom tokenizer right now. Now this is the prediction code. Okay, now to perform the prediction, first of all you have to generate some arguments. Now you have to set the length penalty, then number of beams, then max length. So you don't need to change this parameter, just keep it as it is. Only you can change this length penalty. What is length penalty? I think you remember. So here we had one, let's say, interface, like we can generate short output, we can generate long output. Now if this parameter is close to 1, that means it will generate actually long output. If it is close to let's say 0, it will generate short output. Okay, this is the idea. Now here you can see I'm taking a sample text from my test data. I'm taking actually dialog 1, the first dialog. Okay, you can see from the testing data I'm picking up the first dialog. Let me show you. So if I execute it here, so this is the first dialog I'm taking from my test data, and I'm also taking the reference, that means the actual summary of it, because I want to match this summary with my actual prediction of my model. This is the actual summary, right? Then what I'm doing, I'm creating a pipeline. I think you know what is pipeline in Hugging Face. And here I'm telling I want to perform summarization right now. And I want to use my model, the model I trained. So this is the model I trained. I'm giving the name of the model. You can see, okay, Pegasus Samsung model. And here I am passing my tokenizer. The tokenizer actually I loaded here. Fine. Then I'm creating the pipeline. Now here I'm printing my sample text. That means the text actually we have loaded this first dialog as well as the reference. That means my actual summary. Then I'm predicting my model. You can see I'm passing this sample text to my pipe object, okay, my pipeline. And here I'm giving all the parameter I set here, okay. Then whatever output I'm getting, I'm only printing the summary text of it. Now let me show you. If I execute this code, see, this is my actual dialog. This is my actual summary. Now my model is predicting, okay, the prediction summary. Let's wait and let's try to match, okay, how much accurate it is. Now see guys, I got the prediction. Now just try to see. Now you can see this is the model summary. That means my model has given me the summary. Now see, it's not very accurate, but still it is close to, because again I told you we only trained one epoch and we used our testing data for the training. Okay, that is why it is actually not, it is not giving actually good performance. Okay, and if you want to increase the performance, what you can do, you can increase the epoch size and you can test. And you have to train on top of the training data, okay, not on top of the test data. Okay, this is the small modification you can apply. So I hope guys it makes sense right now how we can actually implement different projects with the help of Hugging Face platform now. Okay, that means I showed you how we can use different model, whether it can be LM model, whether it can be LLM model, how we can use different data sets, okay, and how we can use the Hugging Face pipeline, okay, to create your application. So this was my main objective, the proper use of Hugging Face, okay. Because going forward, we'll be utilizing this particular, let's say, technique only to perform all of the, let's say, project. Okay, whatever project we'll be doing, we'll be following this particular approach only. And going forward, I will be also showing you how we can use large language models. So see, now we are using LM model only, okay, language model only. But going forward, we'll be using large language model. That means we'll be using Llama model. Okay, we'll be using Llama model from Meta. We'll be using, let's say, Mistral model. Okay, we'll be using Falcon model. Different like large language model will be exploring. Okay, so I hope guys this is clear now how we can perform this text summarization project. Now one task I want to give you, see, I already told you now we are having different data sets in the Hugging Face. So you can select based on the task. Let's say if I go to the task, let's say I want to perform summarization, I'll click the summarization. Now see, these are the data related summarization. Now what you can do, you can pick up any kinds of data set from here, okay, and you can perform that text summarization on top of the data. See, here I used Samsung data, but I want you to use some any other data. Okay, so please try to attempt this task, because unless and until you are not doing like a practical from your side, it would be a little bit difficult for you. So, hello everyone. In this video, we'll be doing another experiment with the help of Hugging Face. So here we'll be doing actually text to image generation with the help of Hugging Face. So if you want to actually generate image from the text, so you have to use something called diffusion model. Okay, diffusion model. And what is diffusion model? Diffusion model is kinds of actually large language model. It is available in the Hugging Face. Okay, and if you want to use diffusion model, you have to use one library called Diffusion. Okay, Diffusion. So this Diffusion will help you to actually load these kinds of diffusion model, and you can perform these kinds of text to image generation. So again, it is available inside Hugging Face only. So you don't need to go to the any other platform. Okay. So additionally, we just need to install another library called Diffusion, and with the help of that, we can easily access that diffusion model. As of now, I don't need the Gradio here. I can remove it. So these are the library actually I have to install here. So as you can see, Diffusion is the Hugging Face page for using the diffusion model from the Hugging Face hub. So here you can see, let me show you the page. Actually, I have already given the link. So see, this Diffusion is available inside Hugging Face only. So they have already written like how we can install it, okay, and how we can load the diffusion model and all. Every example they have already given here. Fine. So I have followed this documentation, guys, and I prepared one notebook for you. And let me show you how we can perform this text to image generation with the help of different large language model. And here the model actually will be using, guys, this is actually multi-model. That means this model uses both kinds of architecture, your NLP architecture as well as the computer vision architecture, because here you have to give the prompt. That means text is nothing but your prompt, okay? And it will generate the image. That means first of all it will process the text, then it will process that particular image, okay, image output. So that's why it is using something called hybrid architecture, okay? So it is called actually multi-model. I hope you clear. Now let me install all required packages I need here. Now let me import this stable diffusion pipeline for diffusers. The same way actually we used to load our pipeline. I think you remember from the transformer. So here also we have to load the pipeline for the diffusers. Okay. Now I also need the matplotlib because I want to visualize the image. Then I also need the torch library. Now if you want to see the version of any package, you can execute this command pip show the package name. It will show you the version. Okay. Now here I kept actually two kinds of diffusion model. This is the model ID 1 and this is the model ID 2. You can see the first model. This is the first model. So the model name is Dreamlike Diffusion 1.0. So this is the model, guys, and it is available in the HuggingFace hub. Okay. See, whatever models actually you can see in the model section, this is called actually HuggingFace hub. That means in the hub also you can upload your own model. It is possible. Let's say if I click on the model now. So inside this model, you can upload your own model. Let's say you fine-tuned one model and you want to share with the community. You can also push your model here. Okay, so the other people can download your model and they can use it. Okay, I'll also tell you how you can push your model to the HuggingFace hub. Everything I'll try to show you. Even you can also upload your own data set. Okay, it is also possible here. Now this is the model, guys. You can read about the model and this is the a few results actually. You can see they have given different prompts and these are the results they have generated. Okay. This is one of the amazing model. Even they have also given the code snippet, how we can use it and all, everything they have given. Now another model actually, this one, the model name is Stable Diffusions Excel Base 1.0. This is the model. So this is the model architecture, high level architecture. That means first of all, you have to give the prompt and with the help of actually transformer model, what they will do, they will just try to understand this prompt and they'll try to perform the tokenization, convert to the vector representation. Okay, that means converting to the embedding. Then they'll be creating one latent dimension 120x cross 120x, and this latent dimension will pass to the unit model. If you don't know, inside stable diffusion actually unit model is used. So unit model will try to generate the image, okay, with respect to the prompt user has given. Okay, you can see last I'm getting the image output. Again, they have already given the paper link and all. If you're interested, you can open it up and you can learn. Okay, see, they have also given the code example. Now let me show you how we can use this model. So what I've done, guys, I'm loading the first model. You can see stable diffusion pipeline from pre-train. I'm loading the first model and here you have to give some parameter. Okay, that means torch data type torch.float 64 and use safe tensor is equal to 2. Okay, you have to pass this to parameter. Now I'm loading this model inside my CUDA. That means inside my GPU, because if you load inside your CPU, it will take lots of time, right? So that's why I'm loading everything inside my GPU. Now let me show you. See, it is downloading the model. Now here I have prepared one prompt, guys. You can see this prompt. Dreamlike art, a grungry woman with rainbow hair, traveling between dimensions, dynamic poses, happy soft eyes and narrow chin, extreme bouquet, tiny figure, long hair straight down and tone, quali, shirt and baggy jeans. Okay, so this is my prompt actually I have prepared. Now you can give any kinds of prompt. If you feel like, okay, you have to use this prompt, you can give it here. Now this prompt actually I have to give my pipeline object. That means inside my model, and model will give me the image matrix. Okay, so let me show you. See, it is generating this image right now. I think currently in the ChatGPT also, it is having one model called GPT 4.0. Okay, so this model also can generate actually different image. So see, create an image for my presentation. Now if I click here, now see, it is utilizing something called GPT 4.0. See, if I click here, see, GPT 4.0 they are using. Now it is asking, just try to give any kinds of prompt. Let's say if I give same prompt here, let's see what happens. See, it is generating the image right now. So they are also using this kinds of diffusion model in the backend, multi-model. That means they are understanding the prompt, then they're generating the image. Okay. See, okay, this is the output I got. Now let's see from my model, actually the model actually I'm referring from the Hugging Face. See, if I plot this image right now, you can see this is the results I got. Now see the ChatGPT and see my results. Both are pretty good. Now you can also plot with the help of matplotlib. It is also possible. First of all, I'm printing the prompt, then I'm printing the image. Okay. Now let me give another prompt. A girl is sitting on a chair and she is accompanied by her tiger. Make sure to keep it cinematic and color to be golden IDs. Okay, now let me see the output. The same prompt you can give to the ChatGPT as well. Let's see. So here I think I got the results. Now let me plot the image. See, this is the image I got, and see, this is the image I got from my ChatGPT. So both are good, guys. Now I think you got it, how we can use these kinds of actually multi-model as well. Okay, if I want to, let's say, generate text to image or image to text, okay, everything is possible. Now if I show you, so if you just go to the Hugging Face model section, here, if you click on the model, now see, here you are having different tasks. Let's say you want to perform text to image generation. So here is the task, guys. Inside computer vision, you can select it. Now see, you are having different model. So here I was using diffusion model. You can also use any other model. Okay, see, that many of models are available, around 34,000 model. You can use any of the model. Okay, any of the model, and you can try. So this should be your task, guys. I will leave it to you. You can explore any kinds of model from the hub itself. Okay, only select this task, text to image. Okay, now let's see if you want to perform image to text. That time select this one, and you can see the different model. Even if you want to see the example, open it up. They have also given the lots of example here. Okay, code snippet, everything they have given, you can learn from here. So this is the best platform, guys, if you want to deep dive inside Hugging Face. Fine. Now we'll be learning some parameters of the diffusion model. Like you can set some of the parameter. Okay, let's say you want actually different dimensional image. You want to, let's say, add some more parameter in that image. You can also do it. For this, I created a function generate image. So it will take the pipeline object prompt as well as the parameter, and whatever things actually you will be assigning the parameter, it will set inside pipeline, and it will render the image with the help of matplotlib. So let me execute. See, that many of actually parameter you can play with, negative prompting, and now num inference step, height, weight. Okay, number of image per prompt. Okay, now let's say this is another prompt I have prepared. As of now, parameter I'm not giving anything, it's empty. Now if I pass these are the thing inside my generate function, see, it will give me the image. So this is the prompt. Dreamlike beautiful girl playing the festival of color, wrapped in traditional Indian attire, throwing colors. Okay, this is my prompt. Now you can see, based on the prompt, it has given me one beautiful image. Okay, see, beautiful image it has generated. Now I can give any kinds of prompt. Let's say number of inference step, I have given 100. Now let's see what kinds of input I get. You can see the documentation of the, like this one, diffusers. You will see different actually parameter we're having there. See, this is another example. Now you can see both images are same. I can't see any difference. Now let's see with any other actually parameter. Let's say height. I want to change actually different height, height and weight. So for this, you can pass this height and weight parameter here. Now let me see. So now you can see, guys, I got the results and in a different height and width right now. So that's how you can play with different parameter. Now let's see another parameter, number per image prompt. That means if I want to, let's say, generate multiple images, that time I can give image, number of images per prompt 2. That means it will give me 2 images right now. So here is the results. Now I'm getting 2 output from my image. Now let's say you want to get 3, you can give 3 here. Now let's also see the negative prompting. So here I have added negative prompt, ugly, destroyed, and low quality. Let's say this is my negative prompt. Now let's see whether it is able to generate or not. So right now you can see these results and these results. I think you can see the difference. This is a little bit low quality, and the prompt I have given ugly, destroyed, and low quality. So it is almost matching, I think. Fine. So yes, that's how we can use this kinds of like multi-model, and I can do the text to image generation. Fine. Now I already showed you we are having so many model, guys. Just try to explore from your end some of the model and try to like implement any kinds of projects. Fine. So guys, so far what we have learned, so we saw like how we can use the existing model from the HuggingFace. That means, let's say if you want to use any pre-trained model, you can directly use it. So you have to use something called pipeline. Okay, pipeline. For this, inside pipeline you have to mention the task you want to perform. Okay, let's say you want to perform sentiment analysis, you want to perform, let's say, translation, you want to perform, let's say, summarization, you can mention. Or else what you can do, you can also do the fine-tuning operation. Okay, fine-tuning of a pre-trained model. Okay, and I already showed you one fine-tuning example, like I did the text summarization. Okay, text summarization. So there I trained on top of my custom data. Now you can ask me when we have to use pre-trained model and when we have to do the fine-tuning operation. So let's say whenever you are having a problem statement, let's say you want to do text summarization only, Okay, text summarization only. First of all, try to use the existing model. That means the pre-trained model. Okay, pre-trained model. Let's say I showed you one model, Google Pegasus, that CNN Daily Mail model. Try to use that model and try to see whether your model is able to give the correct, let's say, summary or not. Correct summary or not. If it is able to give the correct summary, then why you need to do the fine-tuning? Definitely not. You can use this model as it is, right? But let's say if your data is a little bit different, let's say you are using something called, let's say, banking data. Okay, banking data, banking related, let's say, conversation you are having. And this conversation is not working with that pre-trained model. That time what you can do, you can collect your own data. That means your custom data. Okay, custom data. And based on that, you can fine-tune one. Okay, fine-tune one pre-trained model. That means you are using one pre-trained model. On top of that, you are adding some more knowledge. Then this model will be able to also work with the banking data as well. This is the idea only. Okay, now I think you got it, when you have to use the pre-trained model and when you have to do the fine-tuning operation. It can be for all kinds of, let's say, model. It can be for the multi-model. It can be for the let's say, LLM model. It can be for the LM model. Any kinds of model actually it can be applied. Okay, so the model I showed you right now, this diffusion model, this text image generation model. Let's say if it is not able to generate the image the way actually you are giving the prompt, that time what you can do, you can fine-tune this model. It is also possible you can also fine-tune the diffusion model. And how to fine-tune? Again, they have given all the, let's say, article here. Fine-tuning, everything they have given. If you just go to their documentation, you will easily learn. Even I will also show you in future, okay, how we can do the fine-tuning of the large language model. For this, we'll be using another technique called PEFT. Okay, that means parameter efficient fine-tuning. What is PEFT? I will tell you. Parameter efficient fine-tuning, because what happens, these kinds of large language model is very huge. And I can't train this kinds of model actually on my this kinds of machine, the Google Colab actually I'm taking, because it's a huge model, huge parameter. For this, we have to follow this parameter efficient fine-tuning process. Okay, that time I'll discuss what is the use of that and how we can fine-tune those example and all. Okay, everything I'll try to clarify. As of now, I'm only the exploring like the service actually it is having, so that you can get familiar with, okay, that are the things actually we can perform with this particular platform. Hi guys, in this video I will show you another example of the HuggingFace, like how we can do text-to-speech generation with the LLM, okay, with the help of this HuggingFace platform. So again, I have to install this transformer library, because inside that only I am having all the, let's say, if I search for HuggingFace, so if I go to the model section, so now let's say we'll be working with the audios, that means text-to-speech. Now if I click on text-to-speech, see, it is having actually different model. Okay, different model actually it is having, but the model actually I'm going to use this model called Suno Bark small model. So this is one of the transformer based text to audio model created by Suno. Okay, now if you want to read about this, you can go ahead and try to read about this particular model. Even they were also given the example, even though they have also given the Colab notebook, how we can use it. See, this is the Colab notebook they have given. But so many things they have written. So what I have done, I just simplified this notebook, and this notebook I created. Okay, now let me show you how we can perform the text to speech generation. Now for this, first of all, I have to import that pipeline from the transformer, and here is the text, guys. So this text actually I'll be converting to the audio. Now see, Python is a high level general purpose programming language. This is my text. Now in the pipeline, I want to perform text to speech. I have to give, and I have to give the model. So here I'm giving my model ID. This is my model ID, Bark small model. Then device is equal to CUDA, because I want to load my model inside my GPU. Now it will give you the output. An output would be a NumPy array. So let me show you. If I just execute this program, see, now if I print the output would be a NumPy array. Okay. Now I have to convert this NumPy array to audio, that is audio frequency. For this, I'll be using one library, IPython display audio. This library will be using, and I have to give this array as well as the sampling rate. Okay. So here you can see I'm passing my audio, that means this array, as well as the sampling rate. Now if I execute, it will automatically convert this array to the audio. Now see, if I play.
Python is a high-level general purpose programming language.
See, I think you heard of, okay, it is speaking that particular text. Now you can give any kinds of text, it will generate the speech for that. Fine. Now you can play with different model, guys. I already showed you, it is having different model. You can try with different model. Okay. See, I was using this model, small model. You can also use any other model. Okay, it's up to you. So that's how, guys, you can explore this HuggingFace. It's an amazing platform, and it's like very powerful platform, guys, in the field of generative AI or in the field of natural language processing. Hi everyone, welcome back. So guys, so far we have seen the demo of OpenAI platform. Even I already showed you what is chat completion model, what is completion model, even what is OpenAI function calling. So all the fundamentals we have already discussed. Now it's time to implement one projects with the help of OpenAI. So in this video, I'll show you how we can implement one Telegram chatbot with the help of OpenAI. That means here we'll be using one chat completion model. That means one large language model we'll be using called GPT 3.5. And with the help of that, actually we'll be implementing one chatbot, and we'll be integrating this chatbot with the Telegram platform. Okay, so make sure you have the Telegram, guys. It can be a smartphone Telegram application, or it can be your desktop application as well. Anything you can keep, both will work. Okay, so here I'm going to use my desktop Telegram. You can also use your smartphone Telegram, it will also work fine. So before starting the implementation, guys, first of all, let me show you the architecture diagram, like how we'll be implementing the entire projects. Then after that, we'll be doing the setup and we'll be starting the implementation. So guys, let's say this is the user, that means you. So you will be asking one query. Okay, you'll be asking one query, and this query will go to the front end. Okay, front end of our application. So here front end wise, we'll be using something called Telegram. Fine. Then what will happen? This query will go to the backend. Backend means our OpenAI. OpenAI API. Okay, OpenAI API. Then this API will access the large language model. That means here we'll be using GPT 3.5. Okay, you can also use any other model like GPT 4. You can also use GPT 4o. It's up to you. Okay, I think I showed you how to like select different model. There is a model list. So if you click there, you will see the model ID. So that particular ID you have to write there. Okay. And this model is, I think you already know, this is a chat completion model. Okay, why chat completion model? Because it can take the instruction. That means multiple instruction you can give, multiple prompt you can give. Okay, you can also create with the help of completion model, like the Babbage one. Okay, I already showed you, which will also work. But what I feel like this chat completion model will be more powerful. Okay, this is the idea here. Now what will happen? This large language model will give the response. So where it will give the response, it will give the response to the backend API, that is your OpenAI API, and OpenAI API will send the let's say response to the front end. Okay, front end means our Telegram. Okay, and from Telegram actually user will again get the response. Okay, response. Let's say this is the response, and this is the question. Okay. So that's actually we'll be implementing the entire projects. Okay, this is our actually high level architecture of our project. Now what I will do, first of all, I just need to get my OpenAI API key, and I already told you how to get the OpenAI API key. So make sure you already created your OpenAI API key and you keep it with you. Now in my computer, I'll just create a folder here, and I'm going to name it as Telegram chatbot. Okay, Telegram chatbot. And inside that, I'm going to open up my Visual Code Studio. Then I'm also going to open up my terminal here. You can also open up your command prompt. Then you can also open up your Anaconda prompt. It's up to you. Now here, the first thing what I have to do, I have to create one virtual environment. So to create the virtual environment, just write conda create -n. Give the name of the environment. Let's say this is my Telegram. So I'll just write telebot. Specify the Python version. Let's say Python is equal to 3. Let's say 8. Okay, I'll use 3.8. You can also use 3.9, but let's use 3.8. Then -y. Yeah. Now let's create the environment. So my environment is created. Now let me activate. Just write conda activate telebot. Now let me clear. Now what I will do, I'll just create a requirement.txt file. Requirements.txt. So inside that, I need to mention all the, let's say, library I need to implement this project. So here you can see front-end wise, actually, I'll be using Telegram. Okay. And to integrate my chatbot with my Telegram, I need a Python package. That means this package will communicate with my Telegram. So inside Telegram, we'll be generating one, let's say, API token. So with the help of API token, we'll be communicating with our Telegram app, right? So for this, actually, we need one Python package. So let me show you this package, actually. The package, actually, I'm going to use. So guys, as you can see, this is the package, actually, we'll be using. The package name is AIogram. So as you can see, AIogram is a modern and fully asynchronous framework for Telegram bot API. And this is the complete documentation of this AIogram. Even they have also given the sample code, like how we can connect with the AIogram and all. Okay, they have discussed each and everything. But you can see they have written actually too much line of code, but that many line of code actually is not required. So what I've done, I just made it like simple. And I created one basics template for you if you want to connect with your Telegram. Okay, so how you can connect for this, what kinds of code you have to use, I already prepared one code snippet. Okay, I'll share with you. So first of all, let me mention this package name inside my requirement. So the first package I'm going to add called AIogram. Fine. Now the second package I need OpenAI, and I'm going to use the same version of the OpenAI I already used in my OpenAI demo. Then I need another package called Python .env. Why Python.env? Because I already showed you, if you want to manage the secret key, so you can use this Python.env to load that secret key from the environment. That means .env file. Okay, this is the idea. Now let me save. Now what I will do, simply I'll install everything in my environment. So for this, just write this command. So pip install -add requirement.txt. So guys, as you can see, my installation is completed. Now let me clear my terminal. And now, first of all, we'll be testing our this one Telegram, whether we are able to make the connection without Telegram or not. So for this, I'm going to create a folder here called research. Inside that, I'm going to create a file. I'm going to name it as eco_bot. So here we'll be creating one eco functionality. That means if you're sending any message, okay, to the, let's say, chatbot, that means to your Telegram chatbot, it will give you the same message. Okay, this is called actually EcoBot. That means whatever message actually will be giving as an input, that message actually will be getting as an output. Okay, so that means I just wanted to experiment whether I'm able to successfully connect with my Telegram or not. Okay, this is the idea here. But before that, I just need to create this .env file. Now inside that, first of all, you have to write your OpenAI API key. So let me just write my OpenAI API key. So this is my OpenAI API key. I think you remember I already created this API key. Okay, now let me save. Now just open up your Telegram app. So here I'm using my desktop Telegram. So you can see this is my desktop Telegram. To search for bot father. So after searching bot further, you will see different bot further, but you have to take the verified one. You can see this is the verified one. Now just try to open it up. See, I've already opened. Now see, previously I already created some of the bot with the help of bot further. That's why it's coming. That's why here you can see some of the like older messages. But if you are opening for the first time, you won't be seeing any kinds of messages. Okay, you will see a start button. You just click on the start button. Okay, then it will give you the suggestion. Okay, what do you want to do here? So here I want to create a, okay, I think my screen is visible. Okay, so here I want to let's say create a new actually Telegram bot. So for this, what you can do, you can write this command new/new, okay, new bot. You can see new bot. Just select this one. Now see, now it will ask you, all right, a new bot, how are we going to call? Okay, please choose a name for your bot. Now you can give any kinds of name here. So let's say I will give my live, okay, my live bot, let's say 24. Let's say this is my bot name I want to give. Now if I hit enter, see, it's telling good. Now let's choose a username for your bot. It must end with bot, like this is example, Terry's bot or Terry's underscore bot. Okay, so you have to give a username, and that username should contain underscore bot, okay, at the last. So I'll give the same name, let's say my live bot, okay, 24 underscore bot. Now if I hit enter, now see, my bot is created. Now it is telling congratulations on your new bot. You will find your bot here. But before that, what you have to do, you have to collect this user, you can see use token. So let me collect this user token. I'll copy. Okay, and I'll open up my Visual Code Studio inside environment. What I will do, so here I'm going to paste it as of now, and you need to also give the key name. That means this is my Telegram bot token. Okay, now I'll be mentioning inside my string. So here we have collected two secret key. One is my OpenAI API key, another one is your Telegram bot token. So with the help of Telegram bot token, we'll be authenticating with our bot actually we have created here. You can see this is my bot. If I click on the URL right now, see, this is my bot. Now if I click on the start, now see, there you won't be seeing anything because this is not connected yet. Now see, if I send any message here, so you won't be getting any kinds of response because as of now we haven't made the connection. So here first of all we have to make the connection, and how to make the connection with the help of this Telegram bot token. Okay, and this OpenAI API key we need to access our GPT model, because this is my main large language model, right? With the help of that actually we'll be getting the actual response. This is the idea here. Fine. Now in the EcoBot, I'll be writing some of the code to connect with my Telegram. Okay, so as I already showed you, so this is the AIogram documentation, and they have given the code snippet you can use to connect with the Telegram, right? But I already told you this that much of actually code is not required. So I just created a basics template. Let me show you. So here, first of all, let me import some required library. So you can see I have imported some required library, but here it is coming this YOLO mark because I haven't selected my current environment. So right hand side below, you can see there is one option. So my base environment is selected. Now I have to select my own environment, which is nothing but Telegram bot. Okay, now see, this error will be disappeared. Now see, these are the packages you have to import, like login, AIogram. From AIogram, you have to import bot, dispatcher, executor, and types. Okay, if you see the documentation also, they are importing the same thing. See, they're importing the same thing as well. Fine. But as I have told you, they have written so many line of code. I just simplified the code. Okay, that's why my code might be a little bit different. Okay, from the documentation. This is the idea. Now .env I'm loading because with the help of .env I'm going to load by .env. Okay, that means my secret. Okay, inside my environment. Now operating system I need, because with the help of operating system I'll be loading. Now os.get.env, I think you remember previously we also did the same thing. And why logging is required? Because if you see the AIogram, they are also using login. Okay, so you have to write the login. Okay, login here. See, basic config logging. So by default it will take the log because it will, let's say, log all the information in the backend. Okay, because see, this is their implementation. They are suggesting to use, these are the, let's say, code snippet. Okay, that's why I'm using. It's not my implementation. So whenever you are using any kinds of, let's say, framework or library, first of all, try to check their documentation, whatever things they are suggesting. Based on that, you have to write the code. Okay, no need to do any modification at the very first. If you understand their implementation, then you can do the modification. But the core implementation you have to always keep as same. Okay, this is the idea here. Now the first thing what I have to do, guys, I have to load my API key, right? So for this I can use this load env. Now simply os dot get env. Inside that I can pass my key name. Let's say I want to load my Telegram bot token. I'll pass the key name here. Fine. So it will return me my Telegram bot token. Now, if I print this one, my Telegram bot token. Now see, if I execute the file right now, it will print the bot token. So let me show you. So Python, let's say it is inside my resource folder, resource. I want to execute this echo bot. Okay. Sorry. Echo bot.py. So guys, you can see it is throwing me one error. It is telling from AIogram import bot dispatcher executor types. Import error, cannot import the executor from AIogram. Okay. So it is throwing me one error. So to solve this error, what you have to do? So you have to create actually Python, let's say interpreter 3.7. That means Python environment you need 3.7. So let's create another environment. So I'll just write conda create -n. Let's give the name. Let's say my bot Python is equal to 3.7. Actually, I want to use -y. Okay, now let me activate conda activate my bot. Now let me clear and let me install the requirements right now. So pip install -r requirement.txt. See, it has installed all the packages in my environment. Okay, so I already installed. That's why it's telling requirement is already satisfied. But for you, it will take some time. Okay, so once it is done, now let's clear my terminal. And now if you execute the command, this command python research/ecobot.py, that means if you execute this ecobot right now see, it should work. Now see, it is printing my API token. Okay, it is printing my API token right now, Telegram bot token. Fine. That means it is working now. Now let me comment this line. It's not required. Now what you have to do, you have to first of all initialize the login. So that's how actually you can initialize the login. So you just need to write logging.basic-config label is equal to logging.info. Okay, because if you check the documentation, they are suggesting like that. Okay, you have to configure the logging like that. Okay, after that you have to initialize the bot and dispatcher. So this is the bot and dispatcher. So inside that you have to pass the API token. Okay, now see what will happen. You can see from AIogram I imported bot, right? Because I want to connect with my Telegram bot. The bot actually I have created. Now if I want to connect, what I need the API token, Telegram bot API token, yes or no, right? So here you can see I'm passing this bot token inside a token actually attribute. So what will happen? This bot will be initialized. That means it will authenticate with my credential. If the authentication is correct, that means this statement would be true. Okay, if it is true, that means my dispatcher would be connected. Okay, dispatcher means, let's say the synchronization. That means whatever message I want to pass. Okay, so it will go to my Telegram bot. Okay, this is called actually synchronization. So it will be connected. Okay, it will be connected. That means this is the authentication code. Okay, with your Telegram. I hope it is clear now. Fine. Then after that, I think you saw they have written different function with the help of async and await keyword. Okay, async and await keyword. So what is the use of async and await? This is the concept of Python. If you don't know about Python, so what you can do, you can check out our YouTube channel. Okay, so there actually I already let me show you. So guys, you can see this is our YouTube channel. So there I already created like a Python playlist. So there I already covered each and every topic. Okay, you need to master inside Python. So there I already explained what is async and await. Okay, so you can check those video. So let me tell you as a high level what is async and await. See what this async and await will do. It will keep on syncing. Okay, it will keep on syncing your update. That means if you update anything, okay, if you update anything in the code base, it will automatically get that update. Okay, that means what happens actually, let's say whenever you update anything in your code, so you don't need to send the request. Okay, you don't need to save and send the request. It will automatically sync that. It will automatically sync that and it will send the update. Okay, so this is the work of async and await. And if you want to use AIogram, you have to use this particular keyword. Okay, async and await with a function. So I already created two functions. Let me show you. So I'll tell you what this function will do. So this is the first function, guys. So the function name I have given command start handler. Okay, I think you saw whenever I started my Telegram bot. Okay, whenever I started my Telegram bot, so there was a start button. See, I given /start. whenever I will give the slash start, my bot will start. Okay, my bot will start. See, if I show you the bot further, if I give slash start, see, bot further started and it has given me all the suggestion actually I can perform here. So these kinds of functionality I want to implement. And if I want to implement, so for this I have to create a function, and with the help of async and await keyword I have to give here inside the function. Now you have to create a decorator, your dispatcher decorator. Now inside that there is a function called message handler. Inside that you have to pass the command, like what kinds of command you want to pass. Let's see if I give slash help as well in my bot further slash help. So it will give me the menu. Okay, what are the things I can perform with the help of bot further? That means if anyone using my bot for the first time, they can get the information with the help of start and help. Okay, slash help. So I want to give two commands, slash start and slash help. If you are passing this one, so what your bot will do? So what your bot will do? Your bot will reply, "Hi, I'm a echo bot powered by Aogram." So this message actually it will give. Now here you can give any kinds of messages. Okay, you can give any kinds of messages. I have given this message. Now let me show you how it will work. So for this, what I have to do, I have to start my bot. So for this is the syntax you have to write. So inside this keyword, you have to write executor start pulling. Then you have to give the dispatcher object, and as well as you have to give one parameter called keep updates is equal to true. What is keep update is equal to true? I'll tell you later on. As of now, just try to remember this parameter you have to give. Okay, if you check the documentation, they are also giving the same thing. Now let me save, and now see if I execute my program, my echo bot. See, so it has connected. Now see, it has started pulling. Now if I go to my bot, let's say this is my bot. Now see, if I give, let's say slash start here. So it has given me, "Hi, I'm echo bot powered by Aogram." Now if I give, let's say slash help, it will give you the same thing, because you have mentioned two command there. I think, remember, you have mentioned two command. Now apart from that, if you give any command, let's say slash hello, it's not working. If you give any other message also, it's not working. Okay, that means it will only work whenever it will get these two command. And here you can pass any kinds of messages. Okay, I have given powered by Aogram or anything you can. Let's say powered by Buppy. Here you can give my name. So once you changed anything, just try to re-execute the code. So I'll just stop the execution with the help of Ctrl C. Now if I re-execute, now again I will go to my Telegram, and now if I give, let's say slash help, now see, it will give me, "Hi, I'm EcoBot powered by Buppy." Okay, I hope it is clear now. But see, it is not able to handle my casual response. Okay, let's say if I'm giving any other message, let's say hi, hello, okay, hi, hello, whatever, it's not giving me the response because I have to create another function for this. Let me show you. So here I will create a function called echo. That means it will give me the same message again and again. Okay, so this is the echo function, and see, I'm using the same syntax only, message handler. Now see, here I'm not providing any kinds of command. I'm not providing any kinds of command, because see, whenever I'm giving my casual message, this is not a command. Okay, so that's why you don't need to mention the command. That means whatever message user will give, that message actually it will send. Okay, it will show you as an output. You can see with the help of await. Now let me save, and again I have to re-execute. Let me stop the execution. Now re-execute my code. Now if I go to my Telegram, now let's say if I just write hi, it will give me hi. If I write hello, it will give me hello. If I write, let's say I am Buppy, it will also give me I am Buppy, because it's an echo bot we have created. That means I'm successfully able to connect with my bot. The bot actually I have created in my Telegram. That means Telegram connection is completed. Okay, Telegram connection is completed. There is no issue. That means we are able to communicate with the front end. Now we have to make another functionality, that means backend API. That means we will be using OpenAI API to let's say process the response, process the question whatever user is asking. We'll be taking the help from the LLM will give the response, and this response I will be sending to the front end again. Okay, so now let's create our actual application. So what I will do, outside of research, I'll create a file. I'll name it as, let's say, main.py. Okay, main.py. Inside that I'll be writing all the code. So what I can do, I can import all the necessary library. Again, you can see I have imported all the library. Even I also imported here as well. Okay, apart from that, I'm also importing OpenAI as well as the system package. Okay, this is the idea. Now see, this application I'll be creating a little bit advanced, because if I show you my ChatGPT now, so let's say this is my ChatGPT. Let's say if I give any message to the ChatGPT, let's say I need a Python code to add two numbers. Sorry, I think my prompt is incorrect. It should be add. Again, I can give the prompt. I need a Python code to add two numbers. Okay, now I think it is perfect. Now see, it is giving me the code. Okay, but see, it is giving me with the function, but I don't need the function. What I can give without functions. Okay, now see, I just given without function, it will automatically remember I'm asking this particular response. Okay, it has remembered. Okay, it has remembered my previous input. So this is actually using one memory. Okay, temporary memory. So I also want to implement this kinds of temporary memory inside my chatbot. So for this, what I will do, I'll just write a class here. I'll just name it as reference. Okay, reference. So inside that, what I will do, I'll just write a constructor, and this will, and it will return actually none. Okay, so inside that, I'll just write self dot response, and it should be empty initially. Okay, that means as of now, let's consider this is my empty memory. Okay, this is my empty memory. That means whatever question I'll be asking as a as a temporary memory, that question actually I'll be saving here, so that if I want to ask any new question, my previous question my model will try to understand. Okay, it will try to remember. Now here you can also pass the doc string. So let's say this is my class I have written to store previously response from the ChatGPT API. Okay, you can also give OpenAI API. OpenAI API. Okay, this is the idea. Now let me load my OpenAI API key as well as my Telegram bot token. So first of all, I will load my OpenAI API key, and I'm setting my OpenAI API key. Then I will also load the Telegram bot token. Okay, this is my Telegram bot token. Fine. Then let's initialize this reference class. So here I can initialize. I'll just write reference is equal to my reference. Then I'm going to define my model name. Let's say which model I want to use. So model underscore name is equal to, let's say I want to use GPT 3.5 Turbo model. If you go to the OpenAI platform, okay, if you go to the OpenAI models, see, here is the different model, and I want to use this 3.5 series actually, C Turbo model. Okay, this model actually I'm using right now. Fine. Now, same way, I have to initialize my dispatcher as well as the bot, because it will authenticate with my Telegram. The same code, guys, from my previous, let's say, file I'm copy pasting. Okay, I think you remember. So we are initializing our bot and dispatcher. So here the first thing, I want to create a function. So this function actually will do the welcome. Okay, so if you give, let's say, start command, it will welcome you. So this is the function I've written, guys. You can see simple function using the same concept. Okay, same concept. So this is the function dispatcher message handler, and here is the command only start. Okay, if you give start command, it will give you, hi, I am a telebot created by Bappy, how I can assist you. Okay, this is the message actually it will show you. That's it. Now if you want to execute, you can simply copy this line, and here you can paste it. That's it. Okay, now it's a dispatcher object, DP. Previously I written as a short form, but now what I did, I just written full name. Okay, this is the idea. Now let me execute and let me show you. So I'll open up my terminal. Let me stop the execution. Now let's say if I execute the file right now, I need to execute my main.py file. So clear Python main.py. Now see, if I open up my bot and if I give /start right now, so it is giving, hi, I'm a telebot created by Bappy, how I can assist you. That means it is working fine. Now let me stop the execution. Great. Now I also want to create a helper function. That means I showed you now, if I go to my bot further and if I give /help, so it will give me all the menu actually I want to perform here. So I also want to give one menu function in my bot. So for this, I have created a function and I named it as a helper. See, this is the function. So it will take the help command. After that, it will show you this message. Hi there, I'm a ChatGPT Telegram, or I can write I'm a Telegram bot. Okay, created by Bapi. Please follow this command. Start to start the conversation, clear to clear the past conversation, and help to get the help menu. Okay, I hope this helps. Now it will give you this this actually menu. Okay, now see here I've written clear / clear to clear the previous conversation. Now let's say if you're saving any conversation and if you want to clear it, so you can use the clear function for this. So what I will do, I'll just write a function named clear. So here I can write. So it will just do the clear operation on the previous conversation. See, I think you remember we initialized our reference here. So inside reference, we're having one variable, class variable called reference. So here I'm doing the clear operation. See, reference.reference I'm making as empty. That means whenever I will save something, okay, inside the variable, and if I call the clear past function, it will clear that particular response. Okay, this is the idea. If you go to the ChatGPT as well, and if you write forget my past prompt, it will forget that. Okay, it will remove that memory. So same way, I'm creating the same functionality here. And to execute this clear past, so I will pass one command. So I'll just write clear, this command clear. So it will automatically do the clear operation. So for this, I will be writing another function here. So function name is clear, and it will take the clear command and it will call this particular function. You can see clear past. Okay, then it will give you a message, I have cleared the past conversation as the context. Okay, this is the idea. Now I have to write my main code. That means my main brain functionality of my application. So for this, I already prepared the OpenAI code. See, this is the OpenAI code, and this is nothing new, guys. This is nothing new. Just try to see. Here I'm using chat completion API. Okay, now let me check everything is fine or not. Now you can see, guys, everything is fine. So I'm creating the chat completion API, and role assistant content I'm giving, because you can see reference.response. First of all, it will check this response. Okay, this response, if there is any response or not. Okay, if not, that means it will act like a you are using for the first time. That means there is no previous context. But if you are starting for the second time, let's say, I think you remember here in the ChatGPT, I have given a prompt. I need a Python code to add 2 numbers. That means one response it will remember. And whenever I'm asking the second question, it will refer my previous, let's say, question I have asked. Okay, the same thing actually happening here. That means it will first of all check whether you are having previous response or not. If not, that means it's a completely new role. Otherwise, it will refer my previous, let's say, response. Okay, now if this is the user message, then it will give you the response. This response actually I'm only getting the content, and I'm printing in the terminal, and I'm also printing in my user interface. That means in my Telegram, and it is also updating the response. Okay, you can see this reference response is also getting updated. Okay, now if you will call this clear past, it will also do the clear operation. It's a simple code I have written. Now let me show you how it will work. So I'll open up my terminal. Now let me execute my app. Now if I open my bot, let's say if I just write /start, I think this command I already showed you, na? /start /help. It is working fine. Sorry, /start. Okay, now see if I give any casual message, let's say hi. See, it is giving me hello, how I can assist you. Let's say if I give hello, how are you doing today? Let's say I'll ask what is Python. It is telling Python is a high level programming language. Okay, now I can also give the same prompt. Let's say give me a Python code to add, code to add 2 numbers. See, this is the code I got. Now I'll ask give me as a function. Now see, that means it is remembering my previous context. Now if I give /clear, I have cleared all the past conversation. Okay, now if I give the same message, give me as a function. Now see here, it is giving me the function. Okay, it is giving me the function, but not these kinds of function. That means my previous, let's say, question function. Okay, that's why I've created this clear. Okay, clear functionality as well. Okay, now you can ask any kinds of question. Okay, whatever question you can ask in your ChatGPT, the same question you can also ask here. Okay, there is no issue. So that means we have created one beautiful application. Now one thing I want to show you, this is keep update is equal to true. Let's say if it is true, what will happen? Let's say if my application is offline right now, Let's say I'll stop the execution. Let's say it is offline. Now if I give any message, let's say hello. Now see, it is offline. Okay, it's not giving you any response. But if it is online, let's say if I execute the program right now, let's say my application is online. Okay, now see, still it is not giving me the response. Still it is not giving me the response, because let's say sometimes it's possible your application will go offline, and if user is giving any question, when it is online again, it should return the answer, right? But it's not giving. So for this, what I can do, I can stop the execution, and this parameter I can make it as false. Okay, now let's say if my application is offline, let's say hello. Now if I re-execute my program, see, it will automatically take the hello. Okay, hello message, whatever you asked during offline. Now see, it is giving you the response. Okay, so this is one of the amazing parameter you can play with if you want to, let's say, keep your application offline. But if you want to reply it, okay, when you are online, you can update this particular parameter. Fine. So yes, guys, this is the like chatbot we have implemented. You can also share this bot with your friends and family. So what you need to do, you just only need to give the username. Let's say this is your username of your bot. Now if they search with this username, they will be able to access your bot. Okay, and if they're asking any question, they will also get the response. Okay, that's how. Just try to ask your friend to use your chatbot. Okay, you have developed with the help of OpenAI. So yes, guys, this is all about from this video. I hope you liked it. Thank you so much for watching this video, and I will see you next time. Hello everyone, welcome back. So in this video, actually, I will show you like how you can fine tune your GPT-3 model, okay, with your custom data. So basically what I'm gonna do here, so basically here we'll be fine tuning ADA classifier, okay, to distinguish between two sports like baseball and hockey. So basically we are gonna perform one classification task here, okay. So here I will like take one sports data, and with the sport data, okay, I will train my GPT-3 model, which is nothing but ADA, okay, ADA classifier. I think you already know it has various model, okay. If you click on the model, so ADA is one of them, okay. So let's install first of all OpenAI. And here you don't have to worry about your system configuration, because here you are using OpenAI API, okay. So all the training and all the, you can say, computation, everything will be performed on their website itself, okay, on their you can say engine itself, okay. So you don't have to worry about. So you just need the API key and just try to open up your Google Colab, okay, and try to start the training. That's it. So because see, it has like millions of parameters, so it's not possible to train in our system, okay. So that's why they have proposed a API, okay, GPT-3 API, instead of giving the raw model to us, okay. Then this command, actually you can actually upgrade your OpenAI. So let's upgrade it also. And here I will import my data. So this data actually is already available inside scikit-learn dataset, okay, like 20 news group dataset. The name of the dataset is, okay. So here you have two categories. One is like baseball and hockey. Now if you want to see the example, the first example, so this is the data. Basically it kinds of email, okay, and here you have the news sports data, okay. Now if you want to see the label target, so you have sports, baseball and hockey, okay. Now if you want to see the first one, see the first example I shown here, first data set, with respect to that I'm showing my first target, okay, which is nothing but it's a baseball, okay. Now if you want to also see the count, so you have total example 1197, baseball has 597, okay, example, and hockey has 600. So basically this data is not imbalanced, okay, it's fine. Now inside data preparation, first of all we need to prepare the data. So what kinds of preparation we need to do here, if you see, if I show you the target, so it has actually reg.sport.baseball, okay. So this is the additional information I don't need, okay, so I need to suppress that. So if you just run this code, so basically what it will do, it will take all the data, okay, and it will create two columns. One is like prompt and completion, okay. So why I'm creating prompt and completion, because if you go to the documentation of OpenAI, so here is a section called fine tunes, okay. Just click on fine tunes. So they have given like how you can fine tunes, okay, GPT-3 model. So here one thing they have mentioned, data preparation. I think here fine tune guide, and if you just go below, prepare your data set. Okay, so if you just read it, okay, if you just read this okay, entirely, so you will get to know you need prompt and completion. Okay, so that's why I have given this name prompt and completion. So prompt is nothing but your data, okay, your input data, and completion is nothing but your level. Okay, so that's actually you need to prepare the data. So once it is done, now you need to convert them a file format called JSON-L. Okay, so this is the command, just run it. Okay, now let me show you what is JSON-L. Okay, so if you just refresh here and let me download it. Now if I open it, okay, so this is the same data format. Okay, like this is your prompt, and at the last you have the completion. See, this is the completion. Okay, and if you see, this is the same format. If I come here, this is the same format. Okay, so that is why you need to you can say convert your entire data frame to JSON-L format. Okay, is done. Now OpenAI has a data preparation tool. So if you just call OpenAI, and from tool itself you just call prepared data. Okay, so it will actually prepare your data. First of all, it will take this JSON-L. Okay, see, I'm just passing sports to JSON-L -q. It will take this one and will do some analyzing. Okay, if something is okay wrong with your data set, it will throw error. Otherwise it will actually fix it. Okay, so see, I have run this command, so it has generated two file, which is nothing but supposed to prepare train JSON, validation JSON. Okay, so it will also do like train test split. Okay, you don't have to do it separately. Okay, so this thing actually you need to run, and here also they have written, okay, they have their own data preparation tool you need to execute. So whenever it is done, now this is the section actually you can execute, okay, to fine tune your you can say model. Okay, this is the training command actually. So here you need to change this API key, because this is my older API key. So I will change it with the newer one. You can also read it from secret. Okay, but I will give it here just for simplicity. Now here API fine tunes great. Okay, now here actually you need to give your data path. Okay, so this is my train data path and this is my validation data path. But here one issue actually I was having. So I was trying to actually execute this command, because here if you see, if I show you my model, okay, so fine tunes, here I have like already trained two models, okay, with the same data. So here actually you can't give the same ID again and again. Okay, if you give this same name, so it will create the same ID again and again. Okay, and it will give you error like just give a new ID. Okay, so that's why if you have done training one time, okay, you just change the data name, otherwise it's fine. Okay, if you're doing it for first time, it's fine, just keep it as it is. Otherwise what you can do, just rename this name with a unique name. So I'll just rename, so I'll just give sports 222. Okay, because this name is already present in my model, so I'll that's why I'm changing the name sports 222. Okay, similar wise, just change it also here, sports 22. This is your validation. Okay, and computation and metrics, okay, everything you're providing, and at the last you're selecting the ADA model. Okay, epochs is not required, so it will basically okay, automatically observe whenever your loss is not decreasing or accuracy is not increasing, it will stop the execution. Okay, so now everything is prepared. Now just click on this one, so it will take the data and it will start, you can say, training your, okay, it's telling, okay, it's telling this data is missing. So let me do ls. Okay, so here one mistake I have done. Here I have given one. Okay, one won't be there. So just remove the one. And now I think everything is fine. Now let me execute again. So guys, actually training takes a lots of time. So what I'm gonna do, I'm gonna show you my previous notebook. Okay, I did the training. So basically whenever you will click on the command, so actually it will start the training and it will start the epochs. Okay, see, this is the epochs, actually it will be running. Okay, and once your training is completed, it will save your model. Okay, it will save your model. So where you will get the model, just come here. Okay, come here, and here you need to refresh this page. Okay, so if you just refresh this page now, if you just click on the model, and at the last there would be a section called fine tunes. Okay, inside fine tunes actually you will get your model. Okay, see, I trained add a model. Okay, and this is the id. Okay, it is the id, and basically this is the date actually when I trained this model. Okay, so this model actually you have to use, okay, whenever you will be doing the inferencing. So now how you can do the inferencing? So this is the code. So basically you can also see the evaluation metrics. Okay, performance metrics actually you can see. Okay, you can also save it as a result.csv. Okay, and here you can also plot this accuracy score. Okay, this is the accuracy score, and this is my data. Okay, this data set actually I'm like taking one prompt. Okay, and here actually I'm doing the generation. Okay, basically I'm loading my model. So why do you need to give your model? So let me show you. Yeah, so here actually you need to provide your model name. Okay, the model name actually you will be training. Okay, here see I have took this model. Okay, so this name actually you need to copy and you need to paste it here. Okay, and it will load the model from the OpenAI itself. Okay, and it will do the inferencing. See, this is the score of your hockey and baseball, and after that if you want to see, okay, this is the baseball and hockey. So that's actually you can see the example. Okay, do the inferencing. So yes guys, I think you got it, like how you can fine tune your OpenAI like GPT-3 model, okay, with your custom dataset. And if you want to learn more about fine tuning, I will suggest just try to explore this documentation. It is pretty good documentation. Just try to read everything, not only like classification, you can also do it from summarization and other tasks. Okay, for that actually you need to prepare the data, like you need to learn how to prepare the data. Okay, so yes guys, I think you got it. This was all about from this video. And yeah, that's it. Actually you need to learn about OpenAI and like GPT-3. Okay, so once you are comfortable with this API, I think you can do anything. Okay, hi everyone, my name is Bappi Hamed and welcome to my video. So guys, in this video we'll be doing another project with the help of OpenAI. So the project name is audio transcript translation with Whisper. So as I already showed you the OpenAI platform, even I already used different model. Even in our previous video, we also implemented one project called Telegram Chatbot. So here we'll be exporting another actually variant of the model. So the model name is Whisper. So I think I showed you the Whisper, let's say introduction. What is this Whisper model? So let me show you again. So if I go back to my, let's say OpenAI platform. So here, if you go to the model section and if you just go below, this is the Whisper model guys. So let me open it up. So you can see Whisper is a general purpose speech recognition model. It is trained on a large data set of diverse audio, and it is also multitask model that can perform multilingual speech recognition as well as the speech translation and language identification. Okay, so this is actually a speech based model. That means you can give any kinds of speech or audio, so it will give you the transcript of that particular audio. So here what we'll be doing, let me show you the entire diagram. See, here we'll be implementing one audio transcript translation. Let's say here I will pass one audio file. Okay, it can be MP3 or any other format you can pass. I will pass to the Whisper model. Okay, and Whisper model will return a transcript of this audio. Okay, transcript, that means it is a text. The entire audio text actually it will return. Then what I will do, I will use one actually chat completion model. That means here I can use any kinds of model. Let's say here you will be using GPT. Okay, GPT-3. So I'll pass this transcript to the GPT-3, and here I will provide a prompt, translate. Okay, translate. So here as an input you will pass one language. Okay, you will pass one language and it will give you that like translated text. Okay, translated text. Okay, so this is the entire actually high level diagram. So for this, I'll open up my local folder, and here I'm going to open up my Visual Code Studio. So this is my Visual Code Studio. Then I'm also going to open up my terminal here. Okay. I think you remember previously we created one environment like OpenAI demo. So let me activate the environment instead of creating again and again. So what I can do, I can just write conda activate OpenAI demo. Okay. So this environment I'm going to use because inside that OpenAI is already installed there, right? Fine. Now here I'm going to create a requirement file. So here the first requirement you need the OpenAI. I think OpenAI is already installed, but here I'm adding because I want to share this material with you. So later on, whenever you want to install it, you can check the requirement.txt file. Then I also need python.env. I think you know why python.env, because we'll be managing the credential, right? That means we'll be creating a .env file, and inside that I'm going to mention my OpenAI API key. I think you remember we already created one OpenAI API key. So this is my OpenAI API key. Okay. Let me save it here. Fine. Now see here, I'm going to create a user interface. That means see this audio file, user can upload this audio file. For this, I need a web interface. Okay. Web application. So to create the web application, I'm going to use one framework called Flask. So Flask is a framework inside Python. With the help of that, you can create a web application. Okay. So let me also install the Flask here. Okay, Flask. Now simply what you have to do, open up your terminal and write this command pip install -r requirement.txt. For me it is already satisfied, but for you it will take some time to install all the packages. Fine. Now the first thing, I'll show you the demo, like how we can use the Whisper model. So first of all, let me import OpenAI, and it is showing this warning because I have to select my environment. I have created OpenAI demo. Then I also need to import operating system because I want to load my env. Then .env as well. So from .env import load env. Fine. First of all, I'll load my env. So here is my OpenAI API key. os.getEnv. Then I need to add this API key inside my OpenAI API key. So OpenAI.API key is equal to my OpenAI API key. Fine. I think my authentication is completed. Now what I will do, I'll just open up one audio file. So let me show you. I have one audio file with me. So this is the audio file, guys. Let me play. So this audio actually I have recorded. Python is a high-level interpreted general-purpose programming language. It is very easy to learn, and you can use Python programming in data science. Fine. So this is the audio file actually I have recorded. So I just need to open this file. So to open this file, I think you can use this open, and inside that you can pass this name. So recording .mp3. Okay, mp3, and again it's a binary file, so you have to give the mode rb, read binary. Fine. So it will give you one object, let's say audio underscore file. Okay, so I have successfully loaded this file. Now if you want to get the transcripts, what you can do, you can use this OpenAI Whisper model. So I'll just write OpenAI dot audio. This is audio model, I think I told you. So you have to call one function called translate. Okay, translate, and inside that, first of all, you have to mention the model name. So I want to use Whisper 1 model. So it is having different model. I want to use Whisper 1 model. Then you have to pass the audio file. So audio file. Now here it will give me the output. Now let me print the output. Now let me show you. So guys, here is the text I am getting. Python is a high-level interpreted general-purpose programming language. It is very easy to learn, and you can use Python programming in data science. That means whatever things you can actually hear in the audio, the same thing you can see as a text. So it is like very powerful model. It will give you the accurate result always. Okay, you can try with different audio. I think you will get it. Now what I have to do, I have to translate. Okay, I have to translate this transcript in a different language. Okay, for this I'll be using GPT-3 or GPT-4 model, whatever you can use here. Okay, and we'll be creating one user application so that user can upload this audio there. Okay, this is what actually we'll be implementing. So for this, what I can do, I can create another file here. I'll just name it as app.py. Now I'll copy paste the same code. This code actually I'll just try to copy paste here, because here we are authenticating with our OpenAI only. Fine. Now apart from that, I also need to import another package called Flask. Okay, because with the help of Flask, we'll be creating this user application. Okay, that is why I'm importing Flask. So you can see from Flask, I'm importing Flask request. So redirect URL, this is not required as of now. Just unify render template. Okay, so with the help of that, actually we'll be rendering our web page. For this, you need a basic HTML file. I'll tell you how we can create a HTML file. You can also get different template. You can also use that one. Fine. Now this next thing, I'll be initializing my Flask. To initialize the Flask, just write this code. This is the code, guys. Flask. In the parenthesis, you have to give __ name. Now you can ask me how to initialize the Flask. Go to the Flask documentation. You can see that. Okay, we can see the code snippet, the basic template they have already given. So first of all, here I'll just add one configuration. So app.config. That means whatever audio actually user will upload. So this will save. So this will save actually. First of all, let me just write upload _ folder. This will save inside a folder name static. Okay, now let's create this folder. Left hand side, I'll create a folder name static. Okay, inside that this audio will be saved. Fine, this is the idea. Now let me create a route. So I'll just give @app.route. So as you can see, this is my route. So it will look for actually two kinds of, let's say, request. One is the get request and there is like post request. Okay, if it is matching, what will happen? This will execute this function. So here I'm going to create a function called main. Okay, so this will execute this main function. So inside main function, the first thing I have to check whether it's a post request or not. So if request, okay, if request.method is equal to if it is post. Okay, if it is a post request, that means if you upload one audio file and if you click on the button, that means it would be a post request. Okay, that is the idea. If it is a post request, so what I will do, first of all, I will get the language. Okay, I'll get the language. That means user will also pass the language, like in which language he or she wants to translate this, let's say, transcript. Okay, that's why I also need to take the language input. So here I will take the input. I'll just write request.form. So from the form itself, I'll take the language. Now how I'll get the language, because for this I'm going to create a HTML file. So let me create a folder here. First of all, if you're using Flask, you need to create this folder, guys, called templates. Okay, templates. Inside that I will be creating a, sorry, it should be templates, not, spelling is not correct. Now it is fine. Now inside that I'm going to create a HTML file called index.html. Okay. Now here I have written one very simple HTML code. It will only accept the audio file. See, here I've given the title, and this is like very basic CSS code I have added here, just to like show my front end a little bit actually beautiful. That's why. Now see, it will user can upload one audio file. Okay, you can see user can upload one audio file. Input type is file, and user will also able to give the language input. That means in which language he or she wants to translate that transcript. Okay, then there would be a button called upload. So whenever they will upload, so what will happen? It will hit the post request. Okay, it will hit the post request, and that time you can see method is equal to post. That time it will hit this route. Okay, it will hit this route, and I will be able to get the language, and whatever audio actually he is submitting, everything I will get. Okay, from the backend. This is the idea only. Fine. So this is a simple HTML code. And now you can ask me why to get this kinds of HTML code. There is a one beautiful website you can follow called Bootstrap. Okay, Bootstrap. So here you will get all kinds of free HTML CSS template. You can go to the example section and see different actually template you are having. You can get their HTML and CSS code. Even you can also search. Let's say you need a file uploader button. Okay, file upload. See, different code snippet they have already given. Okay, that's how actually you can also get the code. You can also get the code. Okay, so I just referred this website, and I actually, let's say, collected this HTML and CSS code, and I modified, okay, with respect to my requirement. This is the idea. Now I think everything is fine. Now what I will do, I'll go back to my app.py, and I'm getting the language. Then I also need the file. Okay, so to get the file, I'll store inside a file, and I'll write request.form, request dot not form dot files, actually, because it's a file type input, right? So it should be a file. You can see here I have mentioned it should be a file. Okay, it should be a file type, should be a file. Now once I get the file, first of all, I will check whether this file is available or not. If file is equal to true, okay, if this is not false, that means user has uploaded the file. That time what I will do, I'll just simply save this file. Where I will save, I'll save inside my static folder. So this is the code. I think you remember we set the configuration, okay, static, okay, upload file static. So it will save the inside static folder. And to save this file, I need a file name. So let's create a file name here. I'll just write file name is equal to file.file name. Okay, it will give you the file name. Now after that, you can easily save this file inside the static folder. Then I will load my audio. So to load the audio, I think you remembered I was using this code snippet. So I can use the same code here. Now see, this recording.mp3 would be available inside the static folder. So I need to also give the path of the static. Okay, static / recording.mp3. Now the same code I'll be writing here. I'll copy, and here I'm going to paste it. So this will give me the output. That means the transcript. Here I can mention it as transcript. Okay, transcript. Now what I have to do, I have to translate this transcript to the another language. For this, I already told you here we'll be using something called GPT 3 or 4 model. Okay, so let me initialize my GPT model. So I think remember how we can initialize it. We can use chat completion API. So here is the code snippet, guys. So here I'm using chat completion API. Inside that, I'm mentioning I want to use GPT-4 model. Okay, GPT-4 model. And this is the message I have given, role. You can see role, system, content. You will be provided with a sentence in English, and your task is to translate it to language. That means whatever language user is giving that in that particular language, then the role. So let me bring it here. I can see role, user, content, transcript.text. That means whatever text actually I'm getting after doing the, let's say, audio to text, I'm just passing it here. And here is my prompt. Okay, here is my prompt I have given to my large language model. And this is the temperature parameter, and this is the max tokens. Okay, I already explained this parameter. Okay, why it is required. Now simply what I will do, I'll just try to return this response, but I will just try to return with the JSONify. Why JSONify? Because whatever, let's say, response you want to render in the HTML page, it should be JSON format. Okay, that's why I have to do the JSONify. So inside that, I will be passing my response. Okay, and JSONify I already imported, I think you remember from here. Then if it is not a post request, okay, if it is not a post request, that means if it is a get request, what will happen? It will only render, okay, it will only render my index.html. Okay, this index.html, that means my web app. Okay, my web app menu, it will open in front of the user. This is the idea. And to render it, I'm using render template function. You can see I've already imported it here. Now if I want to execute my application, so you can execute it here. For this, you have to give the app host and app port. See, app.run host 000, that means I want to run in my local host, and debug is equal to true. That means if you change anything, it will automatically update the changes. And this is the port number 8080. Now let me execute and show you this application. So I'll open up my terminal. And now if I execute, let's say Python app.py. Now see, it is running on my local host. Now let's go to the Google and search for localhost port number 8080. Now see, if I search, so guys, you can see this is my interface. Okay, interface of my application. Now here you can upload any kinds of audio file. Now let's upload. So let's say I want to upload this audio. Now language, let's say I want to translate in a Hindi. Okay, Hindi. Now let's upload it. Now see guys, this is the response I got. And this is my response. You can see this is the Hindi translation. Okay, this is the Hindi translation. Whatever actually I had in my audio. Now you can also give any other language. Let's say again I will pass my audio. Let's say I want to translate let's say I want to translate in Bangla. Okay, Bengali. Now I'll upload. See, this is the Bengali translation I'm getting. Okay. Now you can also extract the content only. instead of like, let's say, getting all the response, but I have printed all the response. I just wanted to show you each and everything, whatever things it is returning. Okay, I already showed you how we can extract out this content, okay, from my previous, I think, session, I think, remember. Fine. So yes guys, that's how actually we can implement this project, and we can use the Whisper model. Okay, now what you can do, you can improve this project, you can add some more functionality. Let's say you want to again convert this text to audio, you can also do it. For this, just go to the Whisper documentation and try to check there. Okay, hello everyone, welcome back. So guys, in this video we'll be implementing another amazing project with the help of OpenAI called image generation with DALL-E model. So I already showed you OpenAI is having different actually large language model, like different kinds of large language model, like language model, multi-model, okay, image model, like different model actually it is having. So we'll be using another model. This is called actually DALL-E. So DALL-E is having different like version, like DALL-E 2 is there, DALL-E 3 is there. So we can use OpenAI API to access this model. Okay, so let me show you this DALL-E model. So guys, if you go to the OpenAI documentation, so here you will see this DALL-E model. Let me show you. So this is the DALL-E model. So as you can see, DALL-E is having different kinds of, let's say, version, like DALL-E 3, then DALL-E 2. Okay, so different version it is having. And DALL-E is one of the model actually, it can create actually realistic image from a prompt. Let's say here you will be passing one like text prompt, and with the help of this prompt actually it will generate the image. Okay, the prompt you will be asking the same kinds of image actually it will try to generate, and this would be realistic image. Okay, now let's see how we can use OpenAI API to access this DALL-E model, and let's build one image generator application. So what I will do guys, I have used the same template as I already used in my previous project implementation. I think you remember we are using Flask there. So I used the same template and I just did little bit modification here. So the modification I have done, the entire HTML code. Okay, I've done the modification. So let me show you the application, like how it will look like. Let me clear. Now if I open up my app.py again, so let me go to Google and localhost port number 8080. So guys, you can see this is the interface of my application. So to build this interface, I have actually collected this HTML and CSS code from the Bootstrap website. I think I showed you that Bootstrap website, right? So you don't need to do anything, only you can change the title and all. Okay, everything you can keep it as default, because you can use this HTML and CSS code as a template. Okay, let's say you want to build any other application with the same template, you can use this code as it is. Okay, if you're not familiar with HTML and CSS code, it's completely fine. You can copy paste from different website. Okay, now the second changes I have done, I've created two route. One is my default route. That means if user is hitting my let's say default route, that means port number 8080, so he will get this kinds of landing page. Okay, and to render the landing page, actually I'm using render template index.html. Okay, and whenever user is giving any kinds of prompt and they're submitting, okay, submitting button, so it will hit this route and it will generate and it will execute this function, and this function will take the prompt, whatever prompt actually user is giving here, I think you can see. Okay, and this prompt will go to the OpenAI DALL-E model. You can see to use the OpenAI DALL-E model, you have to use this code snippet OpenAI.image.create. Okay, now inside that, just try to mention the prompt, number of images you want to generate, just give the number of images and the size of the image. Okay, everything you can set here. Now I'm printing the response as well as the, and here you can see I'm also rendering on my user interface. Okay, and again I'm running on localhost and port number 8080, and debug is equal to true, means if you are changing anything, this will reflect automatically. Fine. So this is the simple modification I have done guys. Otherwise everything I kept default. Okay, everything I kept default, whatever things we have implemented in our previous project. So yes guys, I think you got it. Using OpenAI is like very easy. Only you just need to know how we can access different model. Rest of the things you can take care. Okay, let's say if you want to create any kinds of application, you have to design how you'll be creating. Okay, otherwise the fundamental will remain same. Now let me show you the demo guys. So what I can do, I can give a prompt here. Let's say I'll give a dog is flying and smoking. Let's say this is my prompt I have given. Let's see whether it is able to generate the image or not. You can give the same prompt in the ChatGPT also. Let me show you. ChatGPT is also using this kinds of image model. Recently they have published one model called GPT-4o. Okay, GPT-4o. So this model is able to actually create this kinds of image. Okay, from your prompt. Now let me pass this prompt. A dog is flying and smoking. See, it is generating two response. And let me see this one. Actually, it has generated. Okay, this is a cartoon version. Even you can also generate the realistic one. Let me show you another prompt. So guys, this is the prompt I have prepared. You can see dream like a beautiful girl playing the festival of color. draped in the traditional Indian, throwing the colors. Okay, now let me send and let me see the response. And if I go to the ChatGPT, see, this is the ChatGPT response. Fine. See, this is the output actually we got. Okay, it's amazing. You can see. So you can give different prompt like that, and you can generate image, and you can also control like how many images you need. So here I mentioned, I think you saw only 5 images. That's why it's giving 5 images. Okay, and you can also mention the size, everything you can mention. So yes, guys, this is the application we have developed. I hope you liked it. And now what you can do, you can improve this application, you can add some more functionality. See, I think the previous application we created, that Whisper model, what you can do, you can integrate like both application in one place. Okay, and you can create a complete platform. Okay, that thing I think you can perform. Okay, this would be a good project for you. So yes, guys, this is all about from my side. Please subscribe to the channel and share this video with your friends and family, and please support the channel, guys. If you support the channel, so definitely we'll be bringing up these kinds of content, okay, for you, and you can let us know what kinds of content you want. Okay, from my end, I'll try to provide. Hi everyone, welcome to the course of Generative AI. My name is Bapi Hamid. So guys, as of now, we have seen the LangChain, like how we can use the LangChain and all. So in this video, I'll show you one project actually. The project name is Interview Question Creator. So this project will be implementing with the help of whatever things we have learned so far, let's say LangChain, large language model, vector database. Okay, even we'll be also implementing one front-end application of this project. That means user will get one user interface, and their user will upload the data and they will get the results. Okay, so these kinds of things actually will be also implementing. That means I'm going to show you the complete project structure here. That means we'll be doing modular coding here. But before that, I'll show you the notebook experiment, like how we can implement this project through the Jupyter notebook. Then I'll try to convert this Jupyter notebook to the end-to-end manner. Okay. So I think you saw the name Interview Question Creator. I think you are already getting what is the project about. Interview Question Creator means, let's say you are having one PDF documents, or let's say any kinds of documents, whether it's a docs documents, PDF documents, TXT documents, or whether it's a books. Okay. So what you have to do, you just need to upload that, let's say PDF to this application, and this application will automatically generate the questions. Okay, question as well as the answer. Okay, of the topic actually will be giving. Let's say you have uploaded one Python PDF here. So this application will generate some Python questions, interview questions, as well as the answer. Okay, and that question and answer you can use, let's say for your candidate, or let's say you are a teacher, and you want to generate interview questions, or let's say exam questions. What you can do, you can use this application to generate this kinds of question and answer. So it would be very easy for you to generate this kinds of question. Otherwise you have to manually find the questions, manually, let's say, prepare the answer. So it will take time. But if you are creating this kinds of application, it will help you a lot, okay, to automate your process. Again, it seems like a simple project, but whenever you will be implementing, you will get the complexity. And this is like very interesting project, because this is the first project I should be implementing after learning LangChain. Going forward, we'll be also implementing some advanced projects, like we'll be implementing medical chatbot, source code analysis. Okay, so these are the things we'll be also implementing. So instead of talking too much, guys, let's start the implementation. But before that, I will show you the, let's say, the requirements actually I need to implement this project, and I will also show you the project architecture. So guys, to implement this project, I need some requirements. Okay, I need some requirements. So here we'll be using LangChain to implement the entire, let's say, project. And why LangChain, I think you know, because LangChain having all the functionality, right? Let's say you want to integrate vector database, you want to integrate large language model. Okay, everything is available here. So that's why we'll be using the complete LangChain here. And large language model wise, we'll be using OpenAI model. OpenAI will be using GPT 3.5. Okay, this model actually will be using. Going forward, we'll be also learning how we can use open source large language model. With the help of that, I will also show you how we can create the application. Now, third, I need vector database, vector DB. So here we'll be using FIAS. Okay, so FIAS is another actually vector database. I think I haven't covered in my vector database series. So that's why I thought let's also show you this FIAS in this video, so that you will be also learning about FIAS. So FIAS has implemented by Facebook AI, and this is one of the vector database. This is the local vector database actually, local vector database. So you have to set up everything in local machine. Going forward, we'll be also using Pinecone Web 8. Okay, no need to worry. Then to implement the entire, let's say, front-end part of our application, that means we'll be creating the user interface with the help of FastAPI. FastAPI. I think you know what is FastAPI. FastAPI is a Python framework. With the help of FastAPI, we can create a user interface web application. Apart from FastAPI, we're having, let's say, Streamlit, Flask, Django, okay, Pinecone. So these are the things you can also use. We'll be exploring one by one all of them. I think we saw the Flask previously. I think remember Flask. I think I showed you. We created some of the application with the help of OpenAI. We'll be also using Streamlit. Streamlit is very easy. If you're using Streamlit, you don't need to write any kinds of HTML and CSS code. So guys, yes, as of now, these are the requirements are needed. If I need it later on, I'll tell you. Okay, now let me show you the project diagram. Okay, the project, let's say, structure. That means the high level architecture. So here, first of all, user will, let me just draw it here. First of all, user will upload one PDF documents. Okay, let's say this is the PDF documents. So what I have to do, I have to extract the data. Extract docs. So why I have written docs? Because I think you already know, if I am using LangChain and if I'm, let's say, extracting any kinds of data from any kinds of PDF or any kinds of, let's say, file format, it would be considered as a documents. I think I already covered multiple times, like LangChain data loader. Even I also showed you inside vector database session. So guys, vector database session is very much required here, because inside vector database session I have explained each and everything you need to know to implement any kinds of project. Okay, how to connect LLM, what is documents, what is chunk overlap, everything I have discussed there. So please go ahead and try to watch that let's say session first of all, then you'll be able to understand, okay, what is happening here. Because here I'm not going to explain in detail everything. We are implementing the project only, and we're using our previous concept. Okay, this is the idea. So make sure you complete that vector database series first of all. Fine. So we'll be extracting the documents from the PDF. Then we have to create a chunks. And what is chunks? I think I already told you why chunking is required, because LLM is having one kinds of input limit. Okay, but, so that's why actually we have to create a chunks. Okay, chunks. Then what we'll be doing, we'll be using one embedding model. What is embedding model? I think you already know. I already explained inside my vector database session. Embedding model will help you to generate the vector embedding. Okay, because I have to convert these chunks to the vector embedding. So this will give me something called vector embedding. Okay, vector embedding. Okay, embedding. And with this vector embedding, we'll be creating one semantic search. I already explained what is semantic search. Semantic search, because I think you know the power of vector DB. It will give you one semantic search kinds of functionality. Now what I have to do, I have to store this vector to a vector database. Vector database, because if I want to perform the semantic search operation, I have to use the vector database. Okay, I think you already know. Now guys, you can see my knowledge base has been created. So this is called actually knowledge base right now. Okay, knowledge base, because it is having the entire information about my data. Now I'll be connecting my large language model here. So let's say this is my large language model. LLM, that means that GPT 3.5. Okay, so this large language model I'll be connecting here with my vector database. Okay, and here I'll set a prompt. I'll just set a prompt here. So inside this prompt, actually I'll be writing what kinds of, let's say, task it has to perform. So here I'll be writing, you are a expert interview question creator. So what you have to do, whatever, let's say, data user will give you, you have to create a interview questions. Okay, or let's say 10 questions, 20 questions, you have to create it. Okay, this is the idea. So this kinds of prompt actually I'll pass to the large language model. So I think you already know prompt is everything if I'm using any kinds of LLM, right? So with the help of prompt we can achieve our task. This is the main idea. So this LLM will go to the vector database that time, and because vector database is having all the information about the PDF, and it will create, okay, it will create what? It will create you interview questions. So it will return interview questions. Interview questions. Okay, fine. Now what I told you, I'm not going to take only the interview question. I will also going to take the interview question answer as well from the large language model. So again, what I will do, whatever questions actually I'm getting, again I'll pass. Okay, again I'll pass to my large language model. Again I'll pass to my large language model, and I will tell my large language model also provide the answer, the questions you have generated. So it will give me the answer that time. So it will give me questions answer, okay, as well. So this is going to be my complete project architecture. Okay, so based on this architecture, we'll be developing the entire projects. Fine. So first of all, let's do everything in my Jupyter notebook. Then once Jupyter notebook is working fine, then I'll show you the let's say modular coding implementation as well. So for this guys, what I will do, I will open up my local folder, and here I already created one folder here, empty folder. Inside that, I'm going to open up my terminal. Okay, so in case if you're using Anaconda, Git Bash, whatever terminal you are using, you can open it up. Now here I'm also going to open up my Visual Code Studio. So let me open up my Visual Code Studio. Now here the first thing what I have to do, I have to create one virtual environment. I think I already told you. You just need to create a virtual environment every time whenever you are creating different projects. So to create the virtual environment, you have to execute some of the commands. So let me share the command with you as well. So here I'm going to create a file called readme.md. So this is the markdown file. Inside that I can mention all the command, and this file will help you to render actually these kinds of masses in the GitHub. So let's say whenever you will be uploading this code to the GitHub, that time you'll see that in the GitHub description, that means your project description, all the details has been written. Okay, let me show you one example. So guys, this is my GitHub profile. You can follow me here also, because here I have created lots of repository that might help you a lot. So let me show you my repository guys, one of the project actually I implemented previously. So let's say this project, okay, MLOps production ready machine learning project. So this is the project actually I created. Now if you open this project and if you go to the readme section, you will see that the complete details about my project. Okay, see the complete details about my projects, like how we can set up, what is the workflow, what are the command you have to execute. Okay, everything I have set here. So how it is rendering, it is rendering because of this readme file. You can see a readme.md file. Okay, so that's why we are getting this readme file here, because whatever things you will be writing here, it will render in the GitHub later on. Fine, this is the idea. So here some of the common command you have to execute every time. Let me show you all the command. So see guys, these are the command you have to execute. First of all, you have to create the environment. After that, you have to activate it. After that, you have to install the requirements. To install the requirements, you have to execute this command. Okay, pip install -r requirement.txt. So let's create a file here. I'll name it as requirement.txt. I'll copy and let me create the file as well. Okay, now first of all, create the environment. So copy this command and open up your terminal and execute it here. Okay, execute it here. For me, I already created the environment. What I'll do, I'll just try to activate it, but for you, you just need to create the environment. So for me, let me activate. So this is the environment I created already. Interview, you can see. Fine. Now inside interview, I have to install some of the required package. The package actually I need, I think I showed you the LangChain, OpenAI, then vector database, FastAPI. Okay, everything I have to install here. So I already listed down all the required package you need. So these are the package guys you need. Okay, you need to install. So you can see LangChain community, LangChain code. So these are the actually dependency package if you want to use LangChain. So you have to install it. And again, we are doing local setup guys. That's why some additional package you can see. Otherwise, what will happen? Actually, you might get installation issue. That's why I've added everything. Now, OpenAI, PyPDF. Why PyPDF? Because user will upload PDF documents here. As of now, we are considering PDF documents. Fine. And TikToken is the dependency of OpenAI. Then you can see AI files, FastAPI, UVCon. So these are the dependency of FastAPI. I'll tell you whenever we'll be using these at the package, that time I'll explain. Okay, as of now, just consider these are the packages actually I need to implement the entire projects. Okay, now you can see we'll be using Files, and to install the Files, you have to execute this command fast CPU, then python.env because I have to manage my secret credential. Okay, now let me save everything and you have to install it. To install it, this is the command guys I already shared. So copy the command and let's execute it here. For me, I already installed all the package, that's why it's telling requirement is already satisfied, but for you it will take some time. Okay, now let me clear. All right, now first thing, I'm going to create a folder here called research. Inside the research, I'm going to create a notebook. I'm going to as experiment. I'm going to name it as experiment.ipynb because this is the Jupyter notebook file I want to create. Okay, that's why it's ipynb file. Now let me select the kernel. So the environment I created, this interview. Okay, I'll select it up. Now here, first of all, let's import some library. I need the operating system. Then I also need .env. So from .env import load env. Now let me execute. See, it's working fine. So I think remember I have to create a .env file here. Inside that I have to mention my OpenAI API key. So let me do it. So guys, as you can see, I have created this .env file. Inside that I mentioned my OpenAI API key. Okay, so for you have to do the same thing. Now let's load this OpenAI API key. So to load it, I'll call this load env. After that, simply I'll call the key OpenAI API key. And I'm going to use os.getEnv. Inside that, I'm going to pass my key. Okay, so this will give you OpenAI API key. Let me show you. See, okay, it is printing the OpenAI API keys. Now let me comment as of now. I don't need to print it. Fine. And now what I have to do, I have to set this OpenAI API key as an environment variable. So for this, you have to execute this line of code. So it will set this OpenAI API key as an environment variable so that OpenAI package will load, okay, from the environment itself. I think I already explained previously this part, okay, how to do it and all. Now the first thing what I have to do guys, I have to load the data, but I don't have any data here. So let me show you some of the PDF actually I'm having. So guys, as you can see in the data folder, I'm having actually two PDF. One is like HGD PDF, one is like stats PDF. Let me show you. Let me open the PDF and let me show you. So if I go to the data folder, so this is the PDF guys I downloaded from the internet. So the PDF name is Sustainable Development Goals. Okay. So about this topic, actually, they have written this PDF. You can see what is sustainable, let's say, development and all. They have written this particular, let's say, PDF. So this is one PDF actually will be using to generate the interview questions. Let's say you want to generate interview question based on this topic. Okay, so you can use this PDF. Not only this PDF, guys, you can use any kinds of PDF, whether it's a Python book, any kinds of physics, chemistry, English, okay, anything you can use here. It's up to you. So this is the PDF, guys, actually I'm having. Now the next PDF, let me show you. So this is the statistics PDF. So this is the topic of importance and the use of correlation in statistics. And again, you can see correlation topic has been written. So we'll be also generating some interview questions based on the statistics. Okay, that means the correlation. So these two PDF actually I just downloaded from the internet. Okay, now let's load the data here. So I'm going to open up my notebook. So to load the data, you have to, I think remember, you have to import one, let's say, function from the LangChain. So let's import it from LangChain dot documents loader. Okay, documents loader, import PyPDF PyPDF loader. I think, yeah, this one, PyPDF loader, because it's a PDF document, right? Now let me import it. Now one thing I want to show you, so let's say if I show you my project working directory right now, so let's say pwd, this is the command to check my project working directory. Now you can see that I'm inside my research folder. Okay, you can see I'm inside my research folder. So because this experiment.ipynb is available inside my research folder, but where is my data located? Data located outside of the research folder, yes or no? Because outside of the research folder data is available. Okay, now if I want to go back, to my root project directory, that means LangChain project, what I have to do, I have to execute one command. This command is cd dot dot. Okay, cd dot dot is the command. So this will actually go back one folder back. Let me show you. So now see if I execute the command. Now if I again check the project working directory, now you can see that I'm inside my root directory, that means this directory. Okay, LangChain project. Now I can easily access my data right now. Okay, this is the idea. So make sure you always check the path, project working directory. Okay, if you're working with, let's say, Jupyter notebook in a specific folder. Okay, this is the requirement. Now let me define the file path. File underscore path is equal to, so my file is present inside my data folder. Okay, data. And let's say as of now I want to load this hgd.pdf. So it should be DG. Okay, sustainable development goal. This PDF I want to load. PDF. Okay. And to load it, I'll be using PyPDF loader. Inside that, I'm going to pass my file path. Okay, and it will give you loader object. Now I'm going to load the data. So I'll just write data is equal to loader dot load. That's it. Now see, if I execute, it should load the data. Now if I show you the data, see, so the complete documents, so guys, you can see it has extracted all the data from the PDF itself, and it is having around 24 pages. You can see it has started from 0 till 23. That means 24 pages actually it is having this PDF. If I open this PDF, you'll see that 24 pages it is having, and all the page content it has extracted. And some of the places you can see page content is equal to empty, because in this page actually there is no content, that's why it's empty. And whatever actually documents I'm having, it has extracted. Okay, one by one everything. Now if I want to show you the length, you can see 24 pages are available, okay, in the PDF. Now what I have to do, see, it's a separate page content now I'm having. Now I want to, let's say, store all the data in just one variable. So for this, what I will do, I'll just take a variable here. So let's say variable name is question underscore gen. You can give any variable name, it's up to you. It should be initially empty string. Now I'll just write a for loop. So for page in, let's say, data, let's say the complete data I'm having. So it will give me all the page one by one, and I just need to extract the content. So question gen plus and equal. I'll be just adding, okay, in this variable. Okay, this is the idea. I'll just write page dot page underscore content. Okay, so it will give me all the content one by one, and it will save inside this question gen variable. Now let me show you. Now if I print my question gen, now see, all the data I have extracted. Okay, see, now it is in one place only. This is the idea. Now see, this part actually have completed. That means whatever PDF I uploaded, I extracted the entire documents. Okay, now what I have to do, I have to do the chunking operation. That means I have to create a chunks for my large language model, because if I want to, let's say, generate the embeddings, before that I have to do the chunking operation. I already explained this part, I think you remember. So to perform the chunking, we'll be using one package. So it is available inside LangChain. So for LangChain.text splitter, so we'll be using one text splitter here called token text splitter. Okay, so previously I think we used something called character text splitter, then recursive text splitter. I think you remember we use character, okay, character text splitter, okay, splitter. So with the help of that, we can perform the chunking operation, I think you remember. Then we also have something called recursive okay, text splitter. So again, this is another method to perform the chunking operation. And now we'll be using something called token text splitter. Token text splitter. Now what is the difference between token text splitter and character and recursive? See, let's say this is my entire documents. So I think you remember we used to perform something called chunk size. Okay, chunk size. Let's say 500, and there is another parameter called chunk underscore overlap. Let's say it's 100. Okay, now how it will create the chunks, I think remember, first of all it will start from the first and it will count 500 words. Let's say 500 words ends here. So this is our first chunks. Okay, and to start the second chunk, first of all it will apply the chunk overlap. Let's say 100 word back actually it will go. So it will count 100 word. Let's say this is the 100 word start from here. So it will start the second chunks from here, and again it will count till 500 word. Let's say 500 word ends here. Okay, so this is my second chunk. Okay, so that's actually it will perform the chunking operation. Now you can see there is a chunk overlap you got. So this is called actually overlap. Okay, this is called overlap, and with this overlap actually my model will understand after this first chunks, this chunks is coming, because you can see it is getting overlap now. This is the actually manual approach actually we can consider. This is the manual approach we can consider to get the context of my first chunks and second chunks. Okay, and so on, like whatever chunks actually we are defining here. But this is actually what we do in the character text splitter or recursive text splitter. But what about token text splitter? See, token text splitter, what it will do, instead of using, okay, instead of using actually this manual approach, it will use one large language model. In case actually we'll be using something called GPT 3.5. okay, so this GPT 3.5 will decide, okay, how to create the chunk, how to perform the overlapping, and it will automatically remember, let's say after this first chunks, this second chunks is coming, after second chunks this third chunks is coming, after third chunks this fourth chunks is coming. Okay, your large language model will try to remember this part. Okay, and this is like more powerful method than your previous one, whatever, let's say, method you used previously, because now LLM is remembering everything, the context. Okay, that's the idea here. So let's try to export this this token text splitter. So for this I'm going to open up my notebook. So I already imported. Now let me execute. Now see, this is the syntax to use the token text splitter. So I think you remember previously we didn't use any kinds of model name whenever we used to perform the, let's say, chunking operation. Now you can see I'm using the model name. I'm using GPT 3.5 Turbo. That means my model will try to decide, okay, how to remember the context. Now you can see this is the chunk size. Chunk size I'm expecting 10,000. Okay, 10,000 actually word would be considered as one chunks, and chunks overlap should be 200. Okay, as of now, let's say this is the things I'm just showing you, just to show you, okay, how it will work. It's just an experiment. Okay, I'm just showing you how it will try to create the chunk. Now let's define the splitter. Okay, this is my splitter. Now inside that I'm going to pass my entire documents. So you can see the entire questions and documents actually I'm passing to my splitter. Okay, splitter objects. You can see split text. Now it will give me chunk questions, and that means the chunking. Okay, it will give you the chunking result. Let me show you. So here is the chunk I got. See, this is the chunk I got. Now how many chunk it has written? For this you can use the length function. You can check. See, it has only given me one chunk. Because why? The PDF, you can see this PDF is DG. So if you count all the words, it won't be actually 10,000 words. Okay, it won't be 10,000 words. It is less than 10,000 words. That's why here I've given chunk size is equal to 10,000. It is only considering one chunk the entire documents, because I told you if you count the all the, let's say, word, okay, in this let's say PDF, it won't be 10,000. Okay, because it's a like huge size I have given here, just to show you, okay, how chunking will happen. Now let's perform our actual chunking. For this, what I have to do, I have to first of all convert this actually data to the document format, because you can see now it's a list format. Okay, if I show you the type, okay, if I show you the type of this one chunk question, it's a list. Inside that, if I just extract the first element, it would be a string. See, it's a string, but I have to convert to the document representation. So for this, what I will do, I'll import one class from LangChain called docstore documents import documents. Okay, with the help of documents we can easily convert any kinds of string to document representation. Okay, now let me show you. See, now whatever, let's say, data you got, that means your this one chunk question gen. So I'm applying on for loop. That means it will give me all the, let's say, data one by one, and I'm converting to the documents, you can see. Okay, and I'm storing in this particular variable. Now if I execute, now see, I got the documents and it is format of documents right now. Okay, now if I show you the type of document question gen, it should be a LangChain code document base document documents. Okay, it's a now document format, because if I want to apply the splitter, so first of all you have to convert everything to a document. This is the recommended way. Okay, if you're also giving the, let's say, string directly, it's completely fine, but this is the recommended way. First of all, convert everything to the document format, then try to use the splitter, that means the chunking operation. Now I'll do the chunking again. See, again token text splitter. Again, I'm using GPT 3.5 Turbo model. Now I've given the chunk size is equal to 1000. That means 1000 word I want to consider as one chunks, and chunks overlap is equal to 100. Okay, now let me execute. Now let me give my documents. Now you can see document question gen. Okay, I'm passing it to my splitter. Okay, splitter object right now. Now it will give me the chunk. Now let me show you. Now see, I'll get multiple chunk here. So I got here 4 chunks. Okay, 4 chunks actually I got from the entire PDF. Now if I show you the length, see, 4 chunks I got. Fine, I think it is clear now. So guys, as you can see, we successfully created the chunks. Now the next thing what I have to do, first of all I will generate the questions. like whatever, let's say, chunk I have created, I will pass to my large language model and I will generate the questions. Okay, interview questions based on the prompt actually I'll be providing. I think you remember, we'll be passing one prompt to the large language model. Okay, so with the help of this prompt, actually, I'll tell my large language model, I need a interview questions. Okay, let's say the documents I have given, based on that, it should provide me some interview questions. That's what actually I need to perform. So for this, I don't need to convert these documents to the embedding representation, because as of now, we are only passing the, let's say, documents to my large language model. Large language model will give me the questions, but later on, whenever, let's say, I'll be doing the answer generation, okay, the complete answer generation, that time actually I need to pass the entire documents. Okay, and it will create the vector embeddings and it will store to the vector database. Okay, and vector database, I'll connect my large language model, and large language model will refer this entire information to give me the answer as well. Okay, this is the idea. So let's define my large language model right now. So here I already told you I'm going to use something called OpenAI large language model, that means GPT 3.5. okay, this model. And to use it, I can use this class actually, chat OpenAI. You can also directly import OpenAI. It is completely fine. But we can also import like that. Okay, both way you can import. And if I am importing like that, so here I can also give my model name. That means which specific model I want to use, whether I want to use, let's say, GPT-4 model, 3.5 model, you can use. So let me show you. So this is the code snippet. So chat OpenAI, inside that you can give the model name. Let's say I want to use GPT 3.5 turbo model. And this is the temperature parameter. You can also give max length parameter and so on. So temperature parameter is a creativity parameter. I already explained. Okay, what is the temperature parameter? Now let me define my LLM. Now here I already created one prompt, guys, prompt template. Let me show you. So this is the prompt I have created, guys. You can see you are an expert at creating question based on the coding material and documentation. See, whenever I designed this prompt, actually I was like generating coding related questions. And now I'm using any other documents. You can see that means the this one, sustainable development goal and statistics one. So if you're using statistics one, that time you need to give statistics material. If you're doing sustainable development goal, you have to give sustainable development goal here. That means whatever subject you are referring, you have to give the prompt with respect to that, because it's a changeable prompt is changeable. Okay, you have to change every time based on your requirement. Now your goal is to prepare a coder for a programmer for their exams and their coding test. You do this by asking the questions about the text below. That means whatever, let's say, data user will provide, that means these chunks. Okay, based on that, it will create interview questions that will prepare for the coder, a programmer for their exam test. Okay, make sure not lose any important information. Okay, this is the prompt actually I have created, and I already taught you like how we can design a efficient prompt. What is the art of, let's say, design a prompt? I already took on session on the prompt engineering. That session you can refer. Okay, so that's how always you have to prepare a good prompt. Whenever you are preparing good prompt, that means you will get a good response from the large language model. This is the idea. Now let me define the prompt. Now to use this prompt, I think I already taught you one concept called prompt template. You have to use something called prompt template from the LangChain. So let me show you. So this is the code snippet, prompt template. Okay, so here I'm passing the prompt template I've created, and this is the input variable is text. That means user will give this data. Okay, this is the input variable. I think it is clear. Now let me execute the prompt. Okay, now this is my template right now. We can do another actually very important, let's say, technique here. See, if you're not doing it, it's completely fine, it will work. But I was going through some of the research article, and I got to know people are using something called second layer verification. That means they are doing refined prompt template. So what is refined prompt template? Let me show you. I created one prompt template. See, this is the prompt template I again created. That means whatever questions actually your model will generate from the first prompt, you have to give those questions to the second prompt. That means it will refine that particular question. Let's say if there are some issue with the question, if let's say this question is irrelevant based on the topic you are asking, again this refined prompt template will try to refine, and again it will give you some new questions, okay, on top of it. So here you can see I've written the same prompt again, but one more additional information I have added. We have received some practical questions to certain context. That means it will give me some question. Okay, this question actually I have to give to my second prompt, and second prompt will try to check. We have the option to refine the existing questions or add new one only if necessary with some more context below. That means if some issue is there, if let's say it is irrelevant, that time what it will do, it will try to rectify that question. Okay, this is the idea. Give the new context, refine original questions in English. If context is not helpful, please provide the original questions. This is the idea. So this will actually refine prompt template. You are refining the questions here. That is the idea only. And this is like very powerful method, guys. If you are using, you will see that your result would be pretty good. If you're not using it, it's completely fine, no need to worry. But I'm showing you because see, we are creating it an advanced application, and in advanced application we have to take care, these are the part. Okay, this is super important. Let's also define this refine prompt template. Again, I'm going to use prompt template. Inside that, I'm going to pass the input variable. Now input variable is two. One is this existing answer, the existing answer I will get, and the text. That means again you have to give the entire text, that means the chunks. Okay, so these two input now you have to give. You can see text and existing answer, and it will give me the refine prompt template. Fine. Now I'll generate the questions. For this I need to integrate my large language model as well as the prompt template. For this I'm going to use one function from LangChain called load summarize chain. Okay, previously I think I showed you we can use chain. Okay, only chain we can use. Now there is another chain actually called load summarize chain, because inside LangChain you are getting different chains. Okay, we are using this particular chain, actually load summarize chain. Now we'll be creating my entire chain. See, this is the entire chain. First of all, you have to give the large language model. Okay, the LLM we have defined GPT 3.5. Then chain type is equal to refine, because we have prepared one refine prompt template. Okay, that's why it's a refine. Verbose true, that means it will show you the execution, all the, let's say, logs. Then here I'm giving the question prompt. First of all, the prompt I have defined at the very first. Okay, this is the question prompt. Okay, because it's a chain, it will execute after one after another. Okay, first of all it will execute, and whatever question actually I'll be getting, I'll pass to the refine prompt template. Okay, you can see refine prompt template. Okay, now this is going to be my chain right now. And now simply I'm going to pass the document question. That means this one I have to pass, this one. That means the entire document. Okay, this document I have to pass right now to my large language model, and it will give me the questions. Okay, it will give me the questions, and these questions I'm printing. Let me show you. See, it is generating and it is giving all the information because you have defined verbose is equal to true. Now see, these are the questions I got. I got 10 questions. Now if you want to get 100 questions, you can define here. You can define inside the prompt, I need 100 questions. Okay, you have to generate 100 questions. It will generate 100 questions. By default, it's generating 10 questions. Now if I want to show you, I will open in a text editor, see all the 10 questions I got here. But apart from that, I'm getting some more additional information. I don't need them. I only need the questions. You can see 1 to 10 questions it is giving me. What is the main goal of the sustainable development goals method? What are the some key achievements in the, see, that means if you read these questions, it's pretty good. Nah, as a human, if I tell you just prepare the question for me, I think you'll be thinking in that way. Okay, this is the idea. That means my answer is pretty good, guys. And why I got the pretty good answer? Because I used the refined prompt template. Okay, so this is another powerful concept you can use. Okay, so now we'll be creating the next part. That means we'll be using the embedding model. We'll be generating the vector embedding, and we'll be storing to the vector database. Okay, because I also need to generate the answer right now. Fine. So this is what I have to perform. So let's do it. So for this, first of all, I have to define one embedding model. So here I'll be using OpenAI embedding model. So for this, you can import from the LangChain embeddings OpenAI. I need OpenAI embedding model. Okay, so let me initialize. So here I'm going to use OpenAI embedding model. So if you go to the OpenAI website and if you go to the model section, you'll see that OpenAI also provides lots of embedding model. Okay, so you can use any of them. Now I also need to initialize my vector database. So here I'm going to use FAIS vector database. I already told you. So it is available inside LangChain vector store FAIS. You can also use ChromaDB, Pinecone, Webit. It's up to you. But I'm going to use the FAIS because I need to show you the FAIS as well. Okay, and FAIS is very like fast. I mean than your ChromaDB. Okay, you'll see that it's like very fast, quite fast. Now let's initialize my vector store. See, that's how you have to initialize the vector store FAIS from documents, and you have to give the documents here, like which document you want to create the embedding. I think remember we created the chunks. These chunks, I think remember. Document answer gen. These chunks I have to pass, and I have to create the embedding. Okay, and I have to give the embedding model. This is the embedding model I'm passing. So this will give you the vector store, and it will save locally, guys. Okay, it will save locally. You won't be able to see that. Okay, it will save in memory actually. And if you want to see that, you can store in the cloud based, I mean, you can use the cloud vector DB that time in the cloud you can save. I think I showed you the Pinecone there. You can see the visualization of your vector. Okay, it's possible. Now let me again initialize my large language model. You can see again I'm using GPT 3.5 turbo large language model to generate my answer, because you can see I told you na, the question I'm getting, I'll again pass to my large language model. Large language model will give me the answer. Okay, that's why I'm initializing my LLM again. Now previously I got some questions, I think remember. So this is the questions I got. Okay, these are the questions I got. If I show you beautifully, so what I can do, I can split with the help of /n. So it will give me line by line everything. Now this is the question list. See, so this 10 question I got. Now I have to generate the answer of this 10 question, okay, with the help of large language model. Now for this, let's create a retrieval QA, okay, question answer, let's say chain, because inside chain we are having different chains. I think I told you. Now I'm using retrieval QA chain. This chain I already used in my vector DB. I think you remember. Let's create it. Now let's initialize my QA chain. So here you have to give the large language model first of all. Now you have to give the chain type is equal to stub because it's a QA chain, okay. Now you have to give the retriever object, that means your vector store. That means you are connecting with your large language model right now. See, LLM, you are connecting with the vector store. Okay, for this you have to write this code, vector store as retriever. That's it. Now this is going to give you one chain. Now you can give the, let's say, question and you can get the answer. For this I written a for loop here. See what I'm doing, whatever question list actually I'm having, I'm looping through it. That means I'm taking all the question one by one. Okay, you can see. Then I'm printing it. Then I'm generating the answer. You can see I'm calling this chain run question. That means I'm giving the question, it will give me the answer. This answer actually I'm also printing. After that I'm opening a txt file. Inside that I'm just saving it. Okay, inside that I'm just saving it. That's it. As of now, inside a txt file I'm saving it. Going forward, inside a csv file I have to save it. Okay, this is the idea. Now let me execute. See, first of all, this is the first question. It is generating the answer. See, this is the answer. Okay, second question, it is generating the answer. Third question, answer. Fourth question, answer. So that's how it will generate for all the questions. Let me show you. See, beautifully it is generating. So we have created one amazing application, guys. Now we have to convert it the modular coding. There's the idea. Now see all the answer I got. And if you read the answer, guys, if you open in a text editor and if you read the answer, it's pretty good. It's pretty good. If you see that question and answer, it's pretty good. Now you can use as it is. As it is for any kinds of exam, any kinds of interview, you can prepare. It's amazing, right? Okay, so this is the entire actually, let's say, notebook experiment of our project. Now let's try to convert everything in a modular coding. Modular coding is I just need to write everything in a function. That is the idea only. Okay, I'll refer the same notebook only. I'll copy paste the same code, but I'll write everything in a function. Okay, there is nothing new I'll be doing. So let's start the modular coding. So guys, now let's start the modular coding. But before that, let me show you this answer.txt. Now see, inside answer.txt, it has saved everything, all the question and answer. But again, it's not readable. So next time what I will do, I'll save everything in a CSV file. In one column, I will add the question. In another column, I'll add the answer. Okay, that would be more readable. So what I'll do, guys, so now let me close everything. So left hand side, I'm going to create a folder and I'm going to name it src. Okay, src, because this is going to be my source folder. Inside that, I'm going to write some helper related function. That means if you open up any kinds of, let's say, real-time implementation of any kinds of package or any kinds of project inside Python, let's say if I open this one, Keras, GitHub, you will see that they have also created this kinds of folder structure. See, this is the Keras. Now Keras is also using this. See, it is having one root folder Keras. Inside that, they are also having the source src, and inside src they have created all the, let's say, utility related functionality. That means whatever functionality they need, let's say activation function, application, backend, callbacks, they're writing everything here and they're integrating in the endpoint. Okay, it is also having some endpoint. See, API gen, this is the endpoint, and they're importing it here. If you open it, any kinds of endpoint, they're importing it here. Okay, this is called actually modular approach. That means instead of writing everything in just one file, we have to create a separate file, separate function, and whenever I need it, I'll just call it. Okay, from that particular, let's say, a helper function. This is the idea. So inside src, I'm going to create a file called __init __.py. Okay, this is the constructor file because this folder would be considered as my local package right now. See, this is the modular concept, guys. This modular concept I already explained in my Python session. Okay, so I think you know. So guys, this is our YouTube channel. So here, if you go to the playlist section, I already created complete Python course. So here I already explained about modular coding, everything. What is this constructor file? What is modular coding? How we can write any function in any other file, how we can import it in the endpoint, everything I have explained. Just try to go ahead and watch that one because modular concept is required here. Okay, I'm expecting you are already familiar with this kinds of Python concept. Fine. So you can also see the master OP actually playlist. So there also I have covered lots of advanced topic related Python. So that's why I'm creating this constructor file because this folder would be considered as my local package right now. Okay, and inside that I'm going to create a file called helper. prompt.py, and I'm going to create another file called prompt.py. Okay, prompt.py. So inside prompt.py, I'm going to mention my prompt. So let me show you. So the prompt actually I showed you in my Jupyter notebook. So here I'm going to just define. See, this is my prompt template, first prompt template, and this is my define prompt template. Nothing new, guys. I'm just copy pasting from my notebook only. See, the same prompt I just copy pasted, because prompt is a changeable. Okay, it's a changeable, it's a static one, people can change anytime. So that's why I've written inside prompt let's say file. So user will open the prompt file, and there actually they will change, so that they don't need to open the actual code implementation, and inside that they don't need to change. Okay, I don't need to hard code these are the value. That's why I kept this separate entity. I hope it is clear now. Now let me close it. Now inside helper.py, see, whatever code I have written so far, that means I loaded my documents, I performed the chunking operation, then I created the questions. Okay, these are the thing I'll be writing inside a function only. So inside helper, I created two function. First of all, you have to import all the required package you need. I think you remember these are the packages actually I need. I loaded in my notebook. Then I need to load my I need to load my OpenAI API key, and I have to set as environment variable. I think you know, got it right. Now the first function I have written called file processing. Same thing, guys. If I show you the same thing I'm performing here. First of all, I'm loading my documents. I'm adding all the, let's say, content inside one variable. I was performing this one. Chunking operation. First of all, I was doing with the help of 1000 token. Then next time I was doing with the help of, first of all, I was doing the 10,000. Okay, 10,000 chunk. That means one chunk I want to consider as 10,000. Then I was doing for the 1000. That means the same experiment I did here. Remember, same experiment. See, same experiment. I just written inside a function only. That's it. That is the difference only. This is called actually modular approach. You can also create a Python class, but as of now, it's a very, let's say, a small implementation. That's why Python class is not required. But if you see the actually very big implementation, any ML project or deep learning project, you will see that there I've written like lots of class. Let me show you. So inside US Visa, if I open the components, that let's say data ingestion, you can see I've written a class that time. Okay, so class is required because you can see lots of function I have to handle, and whenever you are having lots of function, lots of method, that time you can write a class. But here I don't have actually lots of method. I only have 1 to 2 method. Okay, that's why I've just written directly a function, not a class. Okay, this is the idea. So that's how you have to design your own project, whether your project size is very huge or not. If it is huge, try to maintain the class, otherwise try to maintain the function. This is the difference only. So if you see any kinds of GenAI project, so most of the time actually we create, let's say, inference on top of large language model, we create a RAG application on top of large language model. Okay, that's why the code implementation is not big that much of. But whenever actually I'm creating any ML project, DL project, there actually we are training our custom model. That time actually lots of method we have to handle, very big code base we have to handle. Okay, that's how we need class concept. This is the idea. Now you can see, guys, I will get my object. Okay, object related my chunking. You can see it will give me document question gen. That means after performing the chunking, and document answer gen. Okay, both actually it will provide. So question gen is nothing but you can see I'm converting to the documents this question, whatever questions actually I was getting. So this is the document question gens. That means after converting to the documents, whatever documents I'm getting, this is my document question gen. And after doing the chunking, this is my document answer gen. So this question generation and this document I need for the answer generation. Okay, the same thing I perform in my notebook. I think remember. See, first of all I was using document question gen just to generate the question. Okay, then I was using document answer gen just to generate my answer. Okay, I hope it is clear. So this function I have created, guys. Now the next function I have created my LLM pipeline. That means I will be using my large language model. I'll be creating the vector embeddings. Okay, so everything will happen inside this function right now. LLM pipeline. First of all, I'm calling the file processing. That means this function, inside that whatever file user is giving, this file would be processed and it will give me document question gen and document answer gen. I'm creating my large language model, creating the prompt, both prompt actually. That means my prompt question as well as the refined prompt. Okay, both I'm creating. Then I'm first of all creating load summarization. I think remember load summarization I was creating. Okay, this one. So it will give me the question. It will give you the question, and I was creating the vector embedding after that. Vector embedding. Then I was creating the vector index. You can see vector index. Then I was creating the retrieval keyword that time. Okay, it will generate you the answer. That means question answer. That means here you will get answer question generation chain and filtered question list. Okay, both actually will get. So these two function I prepared here. Now let me save. Now let me create the endpoint. So here what I will do, I'll create a file. I'll name it as app.py. Okay. Now this is going to be my endpoint. So inside that I'm going to call this function, actually this LLM pipeline, because inside LLM pipeline I'm calling my file preprocessing. That's why I don't need to call separately. So let me open it up. But before that, let me initialize my FastAPI related code. So if you go to the FastAPI documentation, guys, you will see this is the starter code. That means this is the demo code they will also give you. So these are the library you have to import one by one. Okay, then you have to initialize the FastAPI. So how to initialize the FastAPI, guys? So that's how you can initialize the FastAPI. Okay, see, this is the code to initialize the FastAPI. Now here you have to create two folders, static and templates. Inside that you have to create the index.html file. So inside template folder, you have to create a index.html file, because index.html file would be your home page. Okay, that means the user interface. So you need some HTML code. Let me show you. I already created. So guys, as you can see, I already created one template folder. Inside that I created a HTML file. Okay, now see, inside that I have written already HTML code. Okay, that means my front end part of my application. And how I created, again, I referred that Bootstrap website. I think you remember. I also used the Bootstrap website. If you don't know about HTML code, it's completely fine. You can skip this part. You can use, let's say, any other framework, let's say Streamlit on. And see, this HTML creation would be done by the front-end developer. As of now, just to beautify this project, I created the HTML, okay, from my end. That's the idea. And there is another folder I created called static. Inside in static, I created two folders called docs and output. See, whatever documents user will upload, that PDF, it will save inside documents folder. And whatever output you will get from the, let's say, application, that means the question and answer in a CSV format, because you can see I've imported the CSV, it will save inside output folder. And from output folder, actually, I will get that particular, let's say, CSV output. Okay. And inside documents, it will store the PDF. That's the idea. Now, this is the FastAPI code, guys. FastAPI will handle each and everything. Now, I also need to import this one. That means my LLM pipeline. Let's import. So it is available inside, I'll call it from, let's say, src dot, let's say, helper import LLM pipeline. So it is inside helper. I need to import LLM pipeline, because inside helper I have this LLM pipeline. Okay. Now see, if I am importing like that from src helper import LLM pipeline, that means src is now considering my local package. And if I want to use src as my local package, what I have to do, I have to create one file called setup.py. Okay, setup.py. So this is the modular coding concept, guys. Again, inside setup.py, you have to write some setup related code. Let me show you. So this is the code, guys. Setup tool. First of all, give the project name, version, author name, author email, package, and install requires. That means this find package will try to find, okay, wherever this constructor file is available, this folder would be considered as my local package. Now you can see constructor file is only present inside src. That means src would be considered as my local package. Now see, if I show you pip list inside my environment, see, src is not mentioned. Src is not a package. Okay, see, src is not a package. But whenever I will install it, whenever I will install this setup, you will see that this src would be considered as my local package. That means there would be a package name called generative AI project. You can give any name. I've given generative AI project. Now let me save. And to install it, in the requirements, you have to add one more line called -e space dot. Okay. So this -e space dot will look for the setup.py and it will install this package. Okay, let me show you. Now if I again run, let's say pip install -r requirement.txt. See, this would be installed as my local package right now. Done. Okay, now see, some egg info file would be created. Okay, whenever this egg info file is created, that means this setup is successful. Now if I again open up my environment, let's say pip list. Now see, there is a package it has created, generative AI project. Okay, now see, it is my local package right now. That means this src would be considered as my local package. Now I won't be getting any kinds of error right now if I'm importing like that. Okay, so this is called actually modular approach. I think you got it. So here, first of all, user will upload one PDF. For this, I have written a function with the help of FastAPI. See, this is the function. So there is a route called upload. User will upload one, let's say, file, and this file would be saved inside my documents, inside statics documents. Okay, it will save. Now there is another function I will create called getCSV. That means the complete results. Okay, I want to save as a CSV file. So this function will help me to do that. That means the file actually I'll be receiving here. This file I'll give where in the LLM pipeline. And LLM pipeline, what it will do, it will pre-process. It will create the, let's say, prompt and everything. Then it will give me the that means chain, entire chain. Okay, and that chain actually I will utilize. Here you can see. So you can see I'm getting the entire chain, and whatever question list actually I'm having, okay, question list, I'll pass the question inside my chain and it will give me all the answer. And this answer actually I'll save inside my CSV file. You can see write row. Okay, CSV writer write row, and with for this actually I'm using CSV package. You can see CSV package. Very simple code, guys. Only have written inside a function only. You just need to go through this code. You will able to understand. Okay. Then I need another function, guys, called chat. So this particular function, what it will do, it will load the output file. That means the CSV file. Okay, and it will show. It will return you. Okay, it will return you. That means you can also see the complete PDF. Okay, in the UI. Let me show you how this application will look like. So now let me execute my FastAPI code. See, this is the FastAPI code. If you can run app. Oh, this is the local host and this is the port number 8080. Okay, now let me save and now let me execute. So I'll open up my terminal. So Python app.py. Now see, it is running. Let me give the allow permission. Now I'll go to my Google Chrome and here I'll search for localhost 8080. See, this is the user interface, guys. Okay, now here you can upload a file. First of all, let's say I'll upload this file inside data. Let's say I will upload this SDG. First of all, this sustainable goal development, and here I'll generate the question and answer. Let's see. It is generating. This is the user interface we created, basic user interface. Now see, it's loading. And how this loading is happening, animation is happening, because I written everything inside HTML code. So guys, you can see I got the output. Now left hand side you can see it has rendered my entire PDF. Okay, the PDF I uploaded, and right hand side it has given me the CSV download. And now see, if I click here, it will download the CSV file. See, keyway CSV. Now let's open the CSV. How I can open? Let's open it here. So I'll open it. See, this is the CSV. I don't have Excel right now, guys, in my system. That's why I've opened in a VS Code. You can see this is the question, this side, and that side actually I have the answer. You can open in a Excel viewer. You will see that it's a beautiful format I have just stored. Okay, so that's how actually things are happening. Okay, now I think you got it. Why we have written these are the function. So this function will help you to render your PDF documents, as well as it will give you the download option. Okay, to download this particular PDF. Now let's upload another PDF. Let's say I will upload this statistics one right now. Now let's generate again. So guys, as you can see, I got the results, and this is my PDF I uploaded, and let's download the QSCSV as well. See, this is the correlation answer and question I got. Fine. So yes, guys, this is the project actually. I hope you liked it. And this is like very interesting project, guys. If you develop it, you will feel like it's like very interesting. Going forward, we'll be also implementing lots of projects. No need to worry. So in the next video, we'll be implementing another amazing project, very interesting project called Chatbot for any website. That means, let's say I think you saw website chatbot. If you go for any kinds of website nowadays, they're having their chatbot integration with that. Okay. So if you ask, let's say, some question related about the website, about their, let's say, product and service, it will able to give the answer. So that means they're replacing the human behind it. Previously, they used to, let's say, use one human. They used to receive the chat. They used to give the reply. But nowadays, they have added the chatbot there. Chatbot can handle all the answer. If you go to any of the website, you will see that. So we'll be implementing these kinds of application. That means the custom website chatbot. It will only work based on our website data, not any other, let's say, question and all. Fine. This is what actually we'll be implementing, and this is kinds of RAG based application we'll be creating. Okay, that means we are using our custom data. On top of that, we are adding our, let's say, like a large language model. Large language model will try to refer that data to provide you the answer. Fine. Hi everyone, welcome to the course of Generative AI. My name is Bappy Ahmed. So guys, in this video, we'll be implementing another amazing project called Custom Website Chatbot. In our previous video, we had created one project called Interview Question Creator. There I showed you how we can use large language model, how we can use vector database, even how we can use the LangChain. So in this implementation also, I'm going to use LangChain, large language model. Even we'll be also using something called vector database. Okay, with the help of that, actually, we'll be implementing this entire application. But see, this application would be a little bit advanced, because here we'll be creating something called RAG based system. Okay, like retrieval augmented generation. This is the basic RAG. So here we'll be using our custom data. So custom data wise, actually, we're going to use our website data. That means we'll be giving some website, okay, website URL. So my LangChain will automatically fetch the information from the website itself, and this data actually I'll give to my large language model. That means my LLM would be connected with this data, and if you're asking something related about this website, okay, it will give you the answer related that. Okay, so this is the application we'll be implementing. So first of all, let me show you the architecture, like how we are going to develop this project. Then I think this part will be clear. So before showing you the architecture diagram, guys, let me show you one thing. So let's say if I want to open any kinds of website, let's say I will open this openai.com. Okay, this one, openai.com. So this is the openai.com website. Now see, if I want to see the let's say XML page of this website, so what I can do, I can give this particular, let's say route here. So slash sitemap sitemap.xml. So if you open any website and if you give slash sitemap.xml, it will show you the entire structure of the website. Let me show you. So guys, here you can see this is the page actually I got. Now see, inside openai.com, okay, inside openai.com, whatever, let's say, content you are having, whatever content, whatever sub pages you are having, all the information is coming here. You can see, if you just see it carefully, so it is having different URL, okay, different URL for the different tab. Let's say research, for research actually it is having one URL. For GPT 4.40 it is having one URL. For safety, company, see company, I think I saw here. So see, this is the company one. Okay, this is the company one, you can see. Okay, company one. So I think I showed you the company. So see, this is the company URL. So that means it is having all the information, all the data, whatever content you can see in this website. Okay, everything is visible now in this XML page. Now what I have to do, I have to use this concept to extract the data. That means I'll be using LangChain data loader. So inside LangChain actually we are having website loader. With the help of that, we can easily load these at the content. So I'll tell you how we can extract the information. So this is the things actually we'll be doing. Now let me show you the architecture diagram, what we are gonna perform here. So let me open up my Blackboard. See here, first of all, I told you we'll be using website URL. Okay, website URL. So from website URL, what we'll do, we'll just get this sitemap, sitemap.xml. Okay, this page. And from this page, actually, we'll be getting different sub pages as well. Let's say page 1, then page 2, page 3, okay, and so on. That's a multiple page actually we'll get from here. Now what I have to do, from each and every page I have to extract the documents, that means the data. So it should be docs1, let's say docs2. Then after getting all the documents, we'll be using one embedding model. I think you know why embedding model, because I have to convert all the documents to the embedding representation. Okay, so I'll pass all the data to the embedding model. Okay, and embedding model will try to return embedding, vector embedding. So you will get different vector embedding, let's say 0.2, 0.3, 0.5, and so on. Let's say these are the vector representation as of now, just try to consider. Then with all the embeddings, what I have to do, I have to create one semantic index. Okay, semantic index, I think you know, build semantic index. Okay, build semantic index. Then this semantic index, that means this embedding, I will store where? I will store to the vector database. Let's say this is my vector database. So in this case, actually, I'm going to use FAS. You can use any other vector DB. Let's say this is vector database. Okay, I'll be using FAS. You can use anything. You can use, let's say, ChromaDB. You can use a Pinecone. I'll tell you how to use Pinecone ChromaDB later on. I will also tell you. Now what will happen? So user will ask question. Okay, user will ask some question about the website, and this vector DB will return some ranked results. Okay, I think you know what is ranked results. Ranked results. Okay, rank results I'll get. But what I have to do, I have to initialize my large language model, because with the help of LLM only, I'll able to get the correct response. So what I will do, I'll pass this rank results to my large language model as well as this query also. Okay, and this LLM will give you the actual response. Okay, actual response. So this is the complete idea. Okay, this is the complete architecture of our application. Okay, and this is called actually RAG. Okay, RAG. That means retrieval augmented generation, because here we are integrating our custom data. Okay, and we are integrating our large language model with that data. That means this is called actually knowledge base. Okay, knowledge base right now. Okay, entire knowledge base. So now let's open up our Collab notebook and try to install everything, and let's implement this project. So guys, as you can see, I opened up my Collab notebook. So first thing, just try to change the runtime. So here runtime, just keep it as CPU only, because here we'll be using OpenAI model. But if you want to use, let's say, any other open source model, that time you can use GPU, okay, that time. So as of now, let's keep it CPU only. So later on, I will also show you how we can use a new open source large language model. Okay, now let me connect this notebook. So here, first of all, you have to install some package. So you can see I'm installing LangChain community, PyPDF, then a sentence transformer, okay, OpenAI, TikTok, and these are the things. So these are my dependency package actually I need. So let me install all of them. So some of the package actually you don't need. I just written additionally, because later on this project I will show you how we can implement with the help of open source large language model. Okay, that time actually this sentence transformer is required, because if I want to use any, let's say, open source embedding model, that time this is required. So as of now, let's install everything. Then apart from that, I also need to install some more packages. So TikTok and FastAPI and unstructured. Let's say if I want to load the website now, website data, that time I need this package unstructured, because it's unstructured data. And again, I'm going to use Fast vector database. Okay, that's why FastAPI I'm installing. So let me install all of them. Then I also need to install NumPy and NLTK. Okay, so let me install, because these are some dependency packages. If I want to extract the information from the website, so LangChain needs, these are the dependency. Okay, so that is why actually we are installing everything. Now see, after installing this NumPy and LTK, it will tell you restart the session. So let me restart the session. So it will restart the session. Then after that, we'll be importing all the necessary library we need. You can see I'm loading unstructured URL loader from LangChain. So with the help of unstructured URL loader, we'll be loading this data. Okay, here we'll be giving the URL, website URL. It will automatically extract all the information. And we'll be performing the chunking. For this, we are using character text splitter. OpenAI embedding will be using just to convert my data to the embedding representation. We'll be using OpenAI large language model, GPT 3.5 Turbo. That's why we are using OpenAI. Fires, this is the vector DB, retrieval keyway with source chain. That means it will create the keyway object. That means the chain object. Okay. And HuggingFace embedding, as of now, I don't need. I'll just try to remove it. Okay. Later on, I'll tell you how we can use the HuggingFace as well. Now let me import all of the packages. So it's working fine. There is no error. Now let me download this two thing like PUNKT, and you have to download another thing, average perceptron tagger. Okay. So this one you have to download from the NLTK. So let me download. Then after that, I will set my OpenAI API key, because here I'm going to use OpenAI large language model. Definitely you need the key. Now I'm going to pass different website URL. So now you can see I have just collected different website URL. Let me open all of them. Let me show you. So these are the website actually I'm going to refer. So this is one blog website, Medium website you can see, and the content about paper review, Llama 2, Open Foundation, fine-tune chat model. Okay. Now if you just read it, you will see lots of content related Llama 2. Okay. Now there is another website, Databricks I'm using, introducing MPT7B, a new standard for the open source community usable LLM. So this is another large language model. Now you can see the information is written about this large language model. That means we'll be extracting these are the data, and we'll be creating one chatbot. It will provide, and that chatbot actually will be able to give the answer related. These are the topic. Okay, the topic actually you have feeded. Let's say Llama 2, then MPT7B, then stability.ai. Okay, so this is another website. Then you can see Vicuna. So this is another website. Okay, so these are the information actually I want to see. So I have given all the website link. So here you can pass any kinds of website link. You can pass any kinds of website link. Let's say you have one website, your own website. You can give the website link here. So this will automatically extract your website information, and you can create your website chatbot. Okay, on top of it. This is amazing. Now let me initialize the URL. So it supports actually multiple website URL. It's not like that it only supports one URL. No, multiple URL you can give here. Now let me extract the documents with the help of unstructured URL loader. Inside that you have to pass all the URL, and it will automatically extract all the information. Let me show you. Now if I print the data, all the information it has extracted from all the websites. See, okay, amazing. Now if I show you the length, you'll see that 4 documents it has written. Why 4 documents? Because I have given 4 website. 1, 2, 3, 4. That means 4 website information I'm having right now, and this is in the document format. Got it? Because I already told you if you're loading anything with the help of LangChain, that should be document format always. So now I think this part is clear. So we have extracted the content successfully. Now what I have to do, I have to create the chunks. Okay, I have to create the chunks, different chunks. You can see these are different chunks. So I think I forget to mention this chunking here. So it should create a chunk. Okay, chunk. Okay, all the chunks. That means it will create all the chunks. These chunks actually I'll give to the embedding model. Okay, now let me create the chunk here. So to create the chunks, actually I'll be using character text splitter. See, these are some repetitive code again I'm using. Previously I also already taught you what is character text splitter, what is chunk size, what is chunks overlap, everything I taught you, even in the vector database session. So this is very much important session, guys. Just try to complete that session first. So you can see character text splitter, separator is equal to /n, because you can see /n is there. Okay, sometimes. So slash would be the separator. So here /n would be the separator. It will separate by /n. Now chunk size 1000, chunks overlap 200. Okay, now let me create my text splitter. Now inside that I'm going to provide my data. Now it will give you chunks. Now let me see how many chunks I got. So here I got 86 chunks. If you want to see them, simply just print like that. Let's say I want to see the first chunks. This is the first chunks. Let's say I want to see the second chunks as well. I can also see that. See, second chunks as well. And you can see it is also giving me the source URL, like from which URL it is giving you the data. Okay. Now we'll be initializing the embedding model, because you can see the architecture. Now I have to download the embedding model, then I have to convert everything to the embedding representation. So let's use the OpenAI embedding. Now let's test whether it is able to convert to the embedding representation or not. So here I'm calling the embedding model and I'm passing one sentence, hello world. So it should give me the embedding results. Let me show you. And the vector dimension is 1536. Okay, this is the dimension. Now if I show you the numerical representation of this sentence, so this is the numerical representation. That means this is my vector embedding. Okay, so we'll be following the same concept. Now let me convert my text to the embeddings. But for this, actually, I'm going to use FIAS vector database, because whatever embeddings I'll be generating, I'll store in the FIAS. Okay, FIAS vector database, and FIAS is a local vector database. I think you know. So here I'm giving my text chunks and my embedding. Okay, embedding model. Now guys, see, this is my semantic index right now. Okay, this is my semantic index. That means my vector index right now. Okay, now what I have to do, I have to connect my large language model. So let's initialize my large language model. So here I'm going to use OpenAI large language model. By default, it will use GPT 3.5 Turbo. Now let's test our large language model, whether it is able to generate or not. So here I've given a prompt. Please provide a concise summary of Harry Potter book. Okay, now if I execute, it should give me the summary of Harry Potter book. See, this is the summary of Harry Potter book. Okay, it has given me. Great. That means it is working fine. Now with the help of LLM as well as my vector database, I have to create my chain. So for this, I'll be using retrieval keyway with source chain. Okay, I think I already imported from the LangChain, and inside that I'm passing my large language model as well as my vector database. Okay, and this will give me the chain. Now inside chain, actually I can ask any kinds of question right now. See, question is equal to how good is Vicuna. So here I'm asking related Vicuna. Okay, this particular Vicuna. So Vicuna data I have already given to my large language model. I think remember it is already available inside my knowledge base. Now it should give me the answer. Okay, let's see. Okay, now if I want to see the answer, so I'll just call result. Inside that I want to only extract the answer. Okay, now let me show you. See, Vicuna has shown competitive performance compared to the others model like Stanford Alpha. Okay, that means if you read it, okay, if you read this documentation, you will see that that is what actually they are telling. That means amazingly it is able to give me the answer right now. Great. Now let's ask any other question. Let's say the next question I'll be asking about Llama 2. Llama 2, how does Llama 2 outperforms other model? Okay, let's ask this question, and whatever answer I will get, I'll also print it here. Now see, Llama 2 model outperform other models in various categories, including MPT models and similar size and so on. Okay, now see, it is referring the Llama 2 right now. Yeah, Llama 2. Great. Now let me ask another question. So I'll be asking about MPT, this one, MPT 7B model, and whatever results actually I will get, I'll just showcase it here. See, again, I got the amazing response. Okay, now see, it is referring my website data. That means my custom data, not any other data. Okay, this is the main thing here we have developed. Now if you're asking any other question, let's say tell me about India, it won't be giving you the answer, because here we have created the custom chatbot. It will only refer my data, the custom data I have given. Now here I can create a while loop and I can continuously ask the question. Okay, so you can see I'm taking the prompt from the user, and if it is exit, I'll do the exit operation. Otherwise, I'll continue and I will keep on asking the question and it will generate the answer. Okay, let me show you. See, it is asking the question. So what I can give the same prompt again, copy, and here I can pass. And let me press enter. Now what you can do, guys, you can convert this project to the web interface. That means web application. I think I showed you how we can use different, let's say, Python package like Flask, then FastAPI. So this should be your task, guys. Try to create one web application, at least basic web application. Their user will give the prompt and it will provide the answer. Okay, that's it. Now see, it has given me the answer. Okay, now again it is asking another question. Now let's say if I give exit, it will exit the application. Sorry, it should be exit only, but I have given exit parenthesis. Now see, if I'm giving this prompt, it is telling that text provided does not seems to be relevant to the questions. Now see, this question actually doesn't have any context, whatever knowledge base it is referring. That's why I told you it won't be able to give you any other information. Now if I give exit right now, it should exit the application. See, okay, so that's how we can create any kinds of custom website with the help of our custom data. Now what you can do, you can open up any kinds of website and you can implement this project, guys. Okay, and later on I will also tell you how we can use the open source large language model. Okay, and with that, so guys, now let's build one generative AI projects, generative AI application with the help of large language model. So here I'm going to use Llama 2. And here I'm also going to use some of the additional tool. Let's say I'll be using vector database, then I will be using LangChain framework. Okay, then we'll be implementing this amazing application. So the application actually I'm going to implement called website bot. So what is website bot? I think you have probably seen like if you visit any kinds of website, so some of them are already created some bots. So if you ask some question in the website, like what this website and all about, like what are the services it provides, so everything it will give you the answer, right? Whenever we visit any website, let's say I will visit openai.com. So if I visit this website, so if you want to see this website structure, like how many pages actually it has, and like what is the layout of this website, what are the URL of that page, actually everything you can see. Okay, if you visit this link called sitemap.xml. okay, if you just write this one, sitemap.xml, and if you press enter, so it will give you all the detail about this website. Let's say this is the website and it has actually different pages. If you see, if I go to OpenAI, so if I, let's say, click on research and click on, let's say, overview, so it will open a different tab for me. Like let's say this is the different page for this website. So that's how actually you have different website, and with respect to that, it has the different links as well. As you can see, different links actually it will also provide. Okay, let's say this is another page. Okay, this is another page inside OpenAI. So let's say I will copy this URL, and if I paste it here, so it will open that particular see it is opening that particular page. Okay, so that's how actually you can export with any kinds of website. So I already collected some of the website URL. So what I will do, I will use that URL and I will build this application. So here, if you see, I've already prepared one notebook here, and here I already collected some of the website links. So if I open it, so see, this is one blog website link. So paper review, Llama 2 open foundation fine tune chat model. So it has some content. Okay, it has some content. So we'll be chatting through this content, like what are the things actually this content is providing. Okay, everything we can ask in our bot whenever we'll be completing this thing. Not only this thing, I have attached multiple URL. As you can see, this is another link. Okay, this is another link, this is another website. So again, some content is inside that. Again, it has different pages. As you can see, it has different pages. Different pages. If you just visit that site map.xml, you will see different pages link, you will see there. Then I also have another one. So this is the website of stability.ai, and again actually it has some content. So you can give any kinds of website link here. So I have collected, these are the website link, so you can use any of them. So here is another website. Okay, so we will be using this 4 website URL, and we'll be implementing one website bot on top of it. So let's say if you're asking anything, okay, if you're asking anything regarding these are the 4 website, like what are the content, everything, like what are the things actually it is providing. What is this, let's say if you want to ask something about llama 2 open foundation fine tune chat model, you can ask, so it will give you the answer with respect to the content actually it is giving. Let's say if you want to ask like pt7b, okay, this is another open source large language model. If you want to ask something, so here you can ask, so it will give you the answer with respect to this content. So any website you can refer. Let's say if you have created your custom website as well, so you want to create one bot on top of it. So let's say I'm the user, so I will come to your website. First of all, I will ask for your bot like what are the services actually provide, what are the things actually provide. I can get all the information from your bot. Then I don't need to visit your website, okay, again and again. So I can ask everything from the bot itself. So guys, this is going to be one amazing projects, and what you feel like, just try to comment in the chat, okay? So whether it's helpful or not, and make sure you are just watching this video entirely, don't skip any part, otherwise you might get some issue. So guys, now what I will do, I will first of all give you the project's idea. I'll be just giving you the project's architecture. I'll be just writing the project architecture, like what are the steps actually we're gonna do throughout this entire projects, like what are the component we'll be implementing. Okay, so we'll be seeing the project architecture at the very first. Then once you understand this architecture, we'll be moving to the coding part. So let's go to our whiteboard and try to understand the project architecture. So guys, I'm inside my whiteboard. So now, first of all, I will just write the project's name. So it is website bot using llama 2. Okay. So here, let me give you the project's architecture, like how we are going to do the project. So first of all, what I will do, I need to collect those website sitemap.xml. Basically, I need to collect all the content, okay, from the website actually I'm referring. So first of all, we'll be taking all the content with the help of this sitemap.xml, okay, xml. And you don't need to worry about manually, you don't need to write these are the thing. Actually, if you're using LangChain, so with the help of LangChain, actually you can easily extract the content from any unstructured website. Okay, I'll tell you like how to do it. So what it will return, it will return so it will return you page, okay, page, let's say 1, page 2, and page 3. So after getting the page, actually I need to get the documents, okay, present in the page. So it will return me the documents. Let's say docs, okay, docs 1, docs 2, docs 3, okay, docs 4, and so on. So docs 4, okay. Now it will return me that documentation, like all the page content. So once I get all the content, okay, basically here let me write out here, we are just extracting text, okay, extracting text. And after getting all the text, what I will do, I will use my embedding API, that means embedding model. So in this case, I'm going to use HuggingFace embedding model. I think you already know what is embedding model and all. I already discussed this thing in my vector database session. So if you haven't watched that session, you can go ahead and watch it. So everything would be clear there. So I'll be using embedding model. So with the help of embedding model, actually, I'll try to convert this text to vector, okay, vector representation. Now this will return me the vectors. So here I will get lots of vectors. Then once I get the vector, I will build semantic index. Okay, I think you know what is semantic index. Semantic index means you will be combining all the vector together. Okay, then we will be building the semantic index, and you will be storing this semantic index to the knowledge base. Okay, so what is knowledge base? Knowledge base is nothing but your vector database. So let's say this is my knowledge base. Okay, this is my knowledge base, or let's say vector db. So these are the vector will come here. These are vector will come here and it will store inside my vector DB. Okay. So once I'm able to store, these are the vectors, okay, in my vector DB. Now, what will happen? Let's say this is the user. Let's say this is the user. So user will hit some queries. So let's say this is the question from the user. So the first thing what I need to do, I need to convert these questions to the vectors, because again it's going to be the raw text. Okay. So again I will be applying something called embedding model. Embedding model. Okay, then I'll convert this text to vector. So here I will get something called query embedding or query vector. So this query vector, I will apply something called semantic search. I think you already know what is semantic search. Okay, so semantic search on top of my vector DB. Okay, so I'll do the semantic search. So once you do the semantic search, it will return you some ranked result. Okay, rank results. Now I will have my rank results. Now I will take the help from my LLM. I'll be using large language model, which is nothing but my Llama 2. Okay, here I'm going to use Llama 2. So with the help of this large language model, I will get my actual response. Okay, the query user has asked, so it will give me the actual response. Okay, so this is the complete idea, and this is nothing but this is my user. This is my user. Okay, so this is the complete you can say diagram of our projects. As you can see, first of all, we'll be using, these are the website. With the help of sitemap.xml, we'll be extracting all the pages available in the website. Then we'll be extracting the documents, that means extracting the text. After that, we are just converting, let me write here, converting text to vectors. Okay, here we'll be converting text to vectors. Then we'll get our vector embedding. That vector embedding will be building one semantic index and we'll be storing into the vector DB. So in this case, actually, I'm going to use something called Pinecone vector DB. Okay, you can use any vector DB. Web8, you can use Chroma DB. You can also use Face, okay, from Facebook. Anything you can use, but I will be using Pinecone. Then what will happen? User will ask some query. I will be applying again embedding model, and I'll be getting query embeddings. And with the help of this query embeddings, I'll be do semantic search on top of my vector DB. It will give me rank results, and with the help of LLM, I'll extract my correct output I was expecting. Okay, and it will give me the correct response to the user. So this is the complete idea of these projects. Now what I will do, and here I already prepared one notebook for this project. So I'll just explain like whatever things I have done. So first of all, I need to connect my notebook. Make sure you have selected runtime as GPU. So here just click change runtime type and select GPU. So for me, I have already selected. Now here I need to install some of the package. So here I'll be installing LangChain, then bytes accelerate transformers. Why we need it, I think you remember. I think previous experiment I was showing how to use Llama with the help of LangChain. Okay, and I was reading that Llama model from my HuggingFace, and for HuggingFace actually I need to install these are the libraries. Then these are the actually dependency you can install. Okay, then PyPDF should be another dependency, and also you need to install sentence transformer. Now let me install them. So installation is done. So here I'm not going to use OpenAI. So let me just delete this thing. Then I also need to install this library unstructured, because the website will be loading. So it has lots of unstructured format. So to overcome this thing, actually you need this package called unstructured. So let me install it. I'm not using Face. Face is again another vector database. So you can remove this thing. I'll be using something called Pinecone. So this is done. Then I also need to install tokenizers, then Xformers as well. Now I will be also installing Pinecone client, because here I'm going to use Pinecone vector database. And guys, if you haven't checked my vector database session, you can check it out. Okay, it is available. Otherwise, you might get some confusion. So it's better to try to understand this vector DB. Okay, then you will get the entire idea. Now, all the things I have installed. Now I'll be installing all the requirements libraries actually I'm going to use, and whatever libraries actually I'm going to use, I will tell you. Okay, which library actually I'm using for which purpose actually I will tell you at that time. So here you can see some additional library also I'm importing, but again I will discuss like what are the things actually I need here. Now I also need to install punctuation NLTK. So the first thing, I need to collect some of the website URL. The website URL actually I want to use for my bot. So here I already showed you I am using this 4 website. Okay, I'm using this 4 website. You can use any of the website and you can use it. So these are the 4 website link I have provided inside one variable called URLs. Okay, now let me execute. Yeah. Now I think you already saw we have imported one class called unstructured URL loader from LangChain. Here if you see unstructured URL loader. So this class will help you to extract all the data from this or the URL. Okay, I think I was explaining this project architecture, like it will be using something called sitemap.xml. Then it will extract the pages. Okay, from the pages it will extract the documentation. So everything can be done with the help of this function actually we have imported here. Okay, unstructured data loader, and here you just need to give the URL, and it is not only working with the single URL, it will also work with the multiple URL as well. Okay, so now if I execute and show you, so it will easily extract the data, and it will go through all the pages actually this website has, and it will extract all the data for me. See, it has extracted. Now if I print my data, see guys, all the data you can see here. It is amazing, right? So that is the power of LangChain. So that's why we use this LangChain framework to build these kinds of generative AI application. Okay, now if I show you my data length, so it should be 4 because I'm using 4 website, so it will give you 4 website data. Okay, here. Now this data should be in a document format. I think if you see the format of this data, it should be a document format. Okay, and now I need to apply something called text split on top of the entire corpus I have, because I need to convert my data to chunks. Okay, why I need to convert my data to chunks? Because see, I think I already discussed this thing in my vector database session. Why this chunks is important? Because whenever you open any kinds of model, okay, let's say if I open let's say OpenAI model here, OpenAI model, or let's say if I open my Llama 2 model. So here if you see, it has context length as 4096. Okay, like it can take like 4096 tokens, okay, at a time. But if it is more than that, actually at the time your model can't take this and it will give you error. Okay, but the data actually we have extracted, it has like more than 4096 you can say tokens. Okay, so that's why I can't directly pass this data. I can directly pass this corpus to my model. So that's why I need to convert to chunks. Chunks means I will be converting different chunks. Okay, different chunks means different paragraph. Okay, and that paragraph I will be converting to like embedding vector. Okay, then I will be giving that data to my model. Okay, I already discussed this thing in my vector database session. Just try to go ahead and check it out. This should be very much clear. Now here I'll be converting my entire corpus to the chunks. So this is the character splitter function I have imported from LangChain. Here if you see, character splitter from LangChain I am importing. Now with the help of this one, I will be creating the entire chunks. Now here you need to provide two things, the chunk size and the chunks overlap. Chunk size means like how many tokens you need in a chunks, and chunks overlap like how many tokens actually you want to consider from your previous chunks. Okay, so these two parameters you need to give here. Now let me execute. Now my chunks object is created. Now I'll give my data. I'll give my entire data I got from my URL, and it will convert it to chunks. Okay. Now if you want to see the chunk size, so it has created 90 chunks. So if I print my text chunks, okay. So now let me show you. See, this is another chunks. Then again, this is another chunks. Okay, then again this is another chunks. That's how it has created 90 chunks. Okay, and if you want to see individually, you can also see this is the chunks 0, chunks 1, And if you just read it carefully, you will see some of the tokens are coming, okay, from your previous chunks as well. Okay, so this is the chunks overlap. So basically it helps us to understand the context of the sentence actually you have. Okay, now we have successfully converted our entire corpus to chunks. Now I'll be downloading the Hugging Face embedding, because here I was discussing I got my all the documents, okay, and I have converted to chunks. Okay, if you see, we have converted to chunks, docs1, docs2, docs3, and docs so on. Now I need to use Hugging Face model, Hugging Face embedding model, to convert these chunks into embedding, okay, vector embedding. So that's why I will be downloading first of all Hugging Face embedding. So to download the Hugging Face embedding, I think I already imported this library here. Hugging Face embedding, I think somewhere, yeah. So from LangChain embeddings, Hugging Face embedding. So it is available inside LangChain. Now here I'm importing. Okay, now if I execute, it will automatically download the default model. So Hugging Face has lots of you can say embedding model. So this is the one of them. Okay, so this is the name I have already given. You can open it up. So this is the model for embedding. Okay, so you can read about this model. I have already downloaded this model, and now let me see the model, which model I got here. So here if you see, I got something called sentence transformer all MPNet base v2. This is the model I got. Okay, this is the embedding model. Now if I, let's say if I want to convert any text to embeddings, okay, and I want to see like what kinds of vector and what is the length of the vector, so I can test it. So let's say I have given hello world, and from the embedding I'm just doing query embedding. Now see guys, the length should be 768. Now this is the vector representation of this sentence. Okay, this is the vector representation of the sentence. So you can give any here. So let's say I'll give hello, or let's say how are you? How are you? And I have explained this thing detailedly in my vector database session. So that's why I'm again and again telling you, just go ahead and try to check it out, that video. This should be very much clear. See, again, I'm getting the same length, like 768. And this is the how are you vector representation. Okay. Now what I will do, I will initialize my Pinecone vector DB. So for this, actually, I need to collect two things. One is like Pinecone API key, and this is like Pinecone API environment. So for this, I need to visit first of all Pinecone. So just write pinecone.io, and here make sure you have the account. So I have already account, so I'll just log in with my account. So guys, if you log in with your accounts, you will able to see this kinds of interface. So first of all, you need to get the API key. Just click on the API key, and here is my API key I have already created. So what you can do, see, this is my previous API key. I will just copy this API key, and if you don't have API key, just create it here. Okay, just click on create API key, give the name, and create the API key. Will get your API key. Then I'll just paste this API key here. So this is my API key, and don't share this API key, guys. I'll remove this after this recording. That's why I'm showing. And I also need like a Pinecone API environment. So for this, actually, you need to create one index. Just click on the indexes and create an index. And you need to give the name of the index. So let's give Llama projects. Or you need, let's give Llama, only give Llama. Okay. And here you need to give the dimension of the vector. So this is the dimension actually. So here I'm using Hugging Face embedding. So Hugging Face embedding, this is the dimension 768. So this dimension I have to give it 768. And I will take this cosine metric. Okay, so you have any other metric as well. So I'll use this cosine metric, and because here I'm using free plan, then I will create the index. So it will take some time to ready your indexes. So let's wait. See, once it is done, it will give you this green icon. Now here, you will get this environment name called GCP starter. Okay, I will copy this name, and here I need to give it. Okay, done. Now let me execute. So I have set my environment. So API key and API environment. Now I'll initialize my Pinecone. So here, instead of giving inside your ways, you can give it directly. It is also fine. So let me just give it directly. So that's how I can provide. Now let me execute. And now I will give this credential, and I will just initialize my Pinecone. And here you need to give the index name you have created. So this is my index name, which is nothing but llama. I'll copy, and here I'll just give the name. Okay, and this particular line will convert your entire like chunks to the embedding, vector embedding, and will store inside the Pinecone. See, this is the code. Basically, I have my text chunks, and one by one I am just reading the content, and I'm using my embedding. Okay, and I'm converting to vectors, and index I'm giving also, like this is the index, like this is the index I have created. So in this index actually your vector will store. Now let me execute and show you. Done. Now if I go to my Pinecone and refresh the page, you will see like all the vectors actually. Okay, see, this is my text with respect to that. This is my vectors. Okay, this is the vector representation, and this is the index. Okay, and now see, we have successfully stored our data. We have successfully stored our vectors to the vector database. Okay, and you can see all the vectors here. Okay, you can also query out everything you can do, and this thing you can learn from my vector db tutorial. So there actually I have showed you like how to use this vector db and all. So here I'm not going to explain in depth, okay, because they are already explained this thing. Now see guys, I already stored my vectors inside my vector db. Now what I will do, I will first of all logging with my uh, uh, this one, my Hugging Face, because I want to use that Llama 2 model from Hugging Face. For this actually I need to log in. So let me log in. So if you want to log in, you need this access token. I think you remember I was collecting the access token. So this is my access token. I'll just copy. You can create your access token. Okay, I think I already showed you how to create it. Now here I just need to give the token and login. See, logging successful. Now here you need to specify the model name, which model you want to use. I already told you I'll be using this Llama 2 7B chat HF model. So this is the model name I have given here. And you can use that alternative also. Like let's say if you don't have the permission, you can use that model, that open source model. I think previous experiment I was showing, okay? Because I already have the access, so I'll be using this model. Now, first of all, I'll load my tokenizer and model. I already discussed like what is tokenizer and model. Okay, why I'm loading? Because I want to create the pipeline. Now let me load it. See, it is downloading the model. So it will take some time. Let's wait. So guys, we have already downloaded the model. Now we need to create the pipeline. I think I already showed you like what is pipeline and all. Okay, why we need it. So now let me initialize the pipeline. Okay, so here if I show you my diagram, so we have completed till this point. Actually, we have stored the data. Now we are initializing our LLM. Okay, then we'll be handling the user. Now pipeline has been initialized. Now I'll be calling this Hugging Face pipeline, and inside that I will give my pipeline objects, and I will also give this argument called temperature. I already told you what is temperature. Now let me initialize my large language model. Okay, now let's first of all test it whether it is initialized successfully or not. So here I'm giving one prompt. Please provide a concise summary of the book of Harry Potter. So it should give me the summary. So guys, as you can see, we are getting the output. That means my LLM has been initialized and it is working fine. Now let's do some question answer with my LLM. The data we have given, like the website we have given. Okay, so from the website we can ask any kinds of question. Now first of all, I need to import this retrieval QA. Okay, this function. Now here, this is my query. Like I'm just asking how good this Vicuna. Okay, so there is another website actually. I think you remember. This is all about Vicuna. So I want to ask something about Vicuna. Okay, from this website. So it will give me the response, okay, with respect to that. Now this is my question. Now this is my query. If I perform something called similarity search on top of my vector db, so it will give you three different results. As you can see, I think I already discussed this thing, like similarity search, how to perform. And now let's say if you want to get the actual results, okay, actual results with respect to your questions, so you can take the help from the LLM. So that's why you need to call this retrieval QA, and here you need to initialize the LLM chain type and retrieval. You need to give your vector store object here, okay, and as retriever, so it will, so basically it will refer your vector database, and it will also take the query, and it will understand the query with respect to that. It will also understand the question you have asked, okay, the documents response you got, then it will give you the authentic results. Okay, now let me initialize this one. Okay, yeah. Now I will ask the same query, like how good this Vicuna. Now if I ask this query to my LLM, see, it will give you the answer. So guys, as you can see, it has given me the answer. Vicuna is a chat bot that uses stable diffusion 2.1 generate the response while its quality is high. Okay, it is giving this response. Now I'll ask another question, like how does Llama 2 outperforms than other model? Let's see. Because if you see here, I have another website of Llama 2. So this is the Llama 2. Okay, so I'm asking uh, the question with respect to that. Okay, so this is the power of this LLM, and we can create these kinds of generative AI application with the help of this Llama 2, Pinecone, and LangChain. See guys, Llama 2 outperforms model benchmark. Okay, so it is giving like GPT-4 PAM2. Okay, basically, yeah, this is the response it is giving. Now let's ask another query, like what is stable LM. Okay, I think again, if you see, like I am also passing one question with respect to other website. See here, you can also add your custom website. You can ask any kinds of question with respect to that. See, this is the response I got. Now we can create one while loop, like ask the question repetitively one by one. So now it will ask for the user input. Now here I will ask one query, like what is MPT7B. So I think you remember we have one website of MPT7B. Okay, now let's ask one query on top of it. So yes guys, as you can see, I got the answer. MPT7B is a 7 billion parameter language model developed by LLM Foundry. Okay, it is giving all the answer. Now you can ask any kinds of question. You can give, see again, it is asking for the prompt. So I won't be asking, I'll just write exit. So it will exit my code. See, here I have written the logic. So yes guys, I hope you got it, like how we can implement these kinds of beautiful generative AI application with the help of Llama 2, Pinecone, and LangChain. Okay, so this project actually you can also convert to Streamlit app. In future, I will also show you how we can convert it to Streamlit app. Okay, and whenever I will show you like end-to-end project implementation, I will show you that part. So yes guys, I think you have liked this particular session, and you have learned everything about Llama 2, like open source large language model, how to run it, and how we can also implement this kinds of generative AI application. Hello everyone, welcome to this video. So guys, as of now we have seen the RAG demo. Like I already showed you what is RAG and what is the use of RAG and why we have to use the RAG. Okay, even I also showed you what is the difference between RAG and fine tuning. So in this video, we'll be implementing one RAG based project. So the project name is QA system. Okay, we'll be using here Gemini Pro model and LangChain. So if you don't know, Gemini is a large language model developed by Google. Okay, so we'll be using this model, and this model is actually free. So we can use actually Google API to use this model. Okay, I'll tell you how we can collect the API key, and with the help of that, how we can use this large language model. Now see, this is the entire diagram of our project. That means here we'll be creating this RAG application. So we are having some external documents. So in this case, actually, I'm going to use PDF documents. I'm having some PDF documents. Okay, we'll be using this data. So we'll be first of all extracting the documents. Then after that, we'll be perform the chunking operation. Then we'll be building one semantic index. Okay, that means we'll be creating one knowledge base. That means whatever, let's say, data we'll be getting, we'll be trying to using embedding model to generate the vector embedding. Then we'll be storing this vector embedding to the vector database. Then user will ask some query. This query will go to the knowledge base. Knowledge base will return some of the relevant answer. And with the help of large language model, we'll just try to process the answer as well as the question, and it will give you the correct answer. Okay, so this is what actually we'll be implementing here. So let me show you how we can develop this particular application. So I already prepared one example. So let's open up. So guys, as you can see, this is the demo. So for this, what you have to do, again, you have to create one virtual environment. I already showed you how to create the virtual environment. For this, you can use this command conda create -n, give the environment name, then specify the Python version, let's say 3.10, then -y. Okay, this is the command to create the virtual environment. After that, just try to activate with the conda activate command, then install the requirements. So pip install -r requirement.txt. So for me, it is already installed. See, that's why it is telling requirement is already satisfied. So let me show you the requirements. So these are the requirements you have to install, guys. So same requirements only as per our previous project. The only thing I have added this LangChain Google Gen AI. So with the help of this package, actually we'll be accessing the Gemini model. Okay. So here vector database wise, I'm going to use ChromaDB again. You can also use Fias, Pinecone, okay, Webbit, any kinds of vector DB you can use here. So let me open this first of all notebook and let me explain, okay, what are the things we'll be doing here. So guys, you can see I'm having one PDF document. Let me show you this PDF. So this is the PDF, guys. So this is my research paper actually. So I published this research paper. So you can see I'm the author here. So I'm the author here. And the research paper is about development of multiple combined regression method for rainfall measurement. Okay, now you can read the paper, like what are the things actually we have proposed here. So we'll be asking some question, okay, from this paper itself. That means this is my private data, this is my external data. On top of this data, actually, I'll be performing the chat operation. So here I'll be asking some questions related this particular data. Okay, now let me show you how we can do it. For this, first of all, we have to load the PDF. For this, we can use PyPDF loader from the LangChain. Now let me load the data. So you have to give the path of your, let's say, data. So here is my path, my pdf.pdf. Now see, it will give you enter extracted documents. That means you can see it is having around 15 pages. Okay, 15 pages in the research paper if you open it up. Then what you have to do, you have to perform the chunking, guys. I think you know what is chunking. So here chunk size is equal to, I have given 1000. That means 1000 what would be considered as my 1 chunks. Now see, if I execute, here I will get around 44 chunks. Okay, now if I want to show you, so this is my first document chunks. Now I have to get the Google API key. So for this, you can open this link. So this is available inside Google AI Studio. So just click here, Google AI Studio. Now from here, you have to collect one API key. Now see, it will give you this kinds of interface. Now you can create an API key. For me, I already created. I won't be creating again, but for you can create here. See, just select the project. If you don't have project, just try to create a project and try to create the API keys. Now see, if I click here, create API key in existing project, it will create the API key. Okay. Now after creating the API key, you will get this kinds of API key. Okay. This is your Google API key. Now just try to give the key Google_API key is equal to paste your key here. Make sure you are writing like that. Otherwise it won't be working. Fine. Now let me save. Now if I open up my notebook, now guys, what I have to do, I think remember we have to use one embedding model. Okay, embedding model just to convert my data to the vector embedding. Now for this, we'll be using one open source embedding model from the Google. So you can see this is the embedding model, embedding 001. And this is available inside this Google Generative AI embedding. Okay. Now apart from that, you are having so many embedding model. Let me show you. Let me open this link. So you can see you are having AI2, AI Labs, then Aleph Alpha. Okay, so these are the actually provider. So it is also having different embedding model. You can use them as well. So let me load this embedding. For this, I'm going to import this library. I'm going to load the API key. Then after that, I'm loading this embedding model. You can see. Then after loading the embedding, I'm just doing one test operation. I'm just writing hello world. So it should give me the vector representation. Let me show you. So this hello world is represented with this vector, and I'm only printing 5 actually vector. You can also print the complete vector. Okay. Now let me create the knowledge base. For this, I'm going to use ChromaDB. I already told you. Inside that, I'm going to pass my documents as well as the embedding model. You can see embedding model. Now it will give me the knowledge base. Then again, I can perform similarity search operation. That means semantic search operation. For this, you can execute this line of code. So it will give me actually 10 relevant answer. And this is the question I'm asking. What is the new in development of multiple combined regression methods in rainfall measurement paper? So this is my question. Now see, if I execute, it will give me 10 different response. Now if I want to show you, so 10 different relevant response actually it will give me. Now if you want to see the page content, you can also see that. See, this is the page content. Okay, now I will be integrating my large language model. So for this, let's initialize my Gemini model. You can see, so here you can see I'm initializing my Gemini model. For this, I'm using Chat Google Generative AI. Inside that, you have to give the model name Gemini 1.5 Pro. This is the model. So Gemini having different model. You can search Gemini model list, you will get different model lists. So from there, actually, I'm using 1.5 Pro model. And temperature max token parameter, I think you already know. Okay, I already explained this part. Now again, I have to create the chain. I think you remember the same chain actually we are creating. The same we have created our previous project as well. After that, we are preparing the prompt. Okay, this is the same prompt I'm using. This is my prompt template right now. So let me execute. Then here I'm creating the complete chain. I'm giving my LLM object as well as the prompt. And this one I'm passing to my create retrieval chain. Okay, you can see I'm giving my vector database as well as my this object. Now this will give me the complete chain. Now here I'm asking the question again, the same question, what is the new development of multiple combined regression methods for the rainfall measurement paper? Now see, if I ask the question, it should give me the answer from the paper. So guys, here you can see I got the response. The paper of development multiple combined regression methods for rainfall measurement introduced a novel approach to predicting rainfall quantity. The author utilized 10 supervised regression machine learning models to predict the rainfall based on the historical weather data. Their goal is to identify the most accurate regression techniques for the rainfall prediction. See, it is giving me the correct response. Now, if you see the paper, if you read the paper, you will see that we have proposed the same thing here. That means it is working fine. Okay, that's how also you can use different data sources. That means if you're having any private data, okay, if you're having any custom data, you can create the RAG based application like that. So guys, this was the notebook experiment. Now let me show you how we can create a user app. So for this, I'm going to again use Streamlit, and whatever code I have written here, I just copy pasted inside this app.py. You can see all the import operation. I'm loading then my secret key. That means my Google API key. Okay, here I'm loading it. Then I'm loading my documents, performing the chunking operation, creating the vector store, initializing the large language model. This is my prompt, and this is the chat input I'm taking. That means I'm creating one chat input box with the help of Streamlit. So this is my prompt. Then after that, if user has given any query, so it will do the generation and it will show the on top of my Streamlit application. Now let me show you how it will work. So for this, you can run this command: Streamlit run app.py. So guys, you can see this is the title, RAG application using Gemini Pro. You can also change it here. Okay, anything you can give here. Now here I got the input box. Now I can ask any question. Let's say I will ask the same question. You can ask any question from my paper. Just go to the paper and ask any kinds of question. So here we're using Gemini model through the API request, and it is like free API. Okay, you don't need to pay for anything. Now see guys, this is the answer I got. Now if you see the answer, it's pretty good. Okay, that means the correct information it has given me. So yes guys, this is the project, actually the QA project we have developed with the help of Gemini Pro, LangChain and vector database. Hello everyone, welcome back. My name is Bapi Ahmed and I'm your host. So guys, in this video I'll show you how we can implement end-to-end generative AI projects with the help of LlamaIndex. I think I already taken one session on LlamaIndex. Like we have seen like how we can use LlamaIndex and all, and what is the difference between LlamaIndex and your LangChain. Okay, both are similar, but like both are like different framework. You can use them to build your generative AI application. But like we saw the experiment on the like Google Colab notebook. So in this video, I'll show you like how we can use Streamlit package to create the web app and all. Okay, like how we can do it. And I will also provide some assignment. I will also give you some of the task in this video, so that actually you can, so whatever you have learned actually so far, you can utilize this one here. Okay, so I'm not going to implement these projects from scratch because I have already discussed the like process how we develop like one end-to-end projects. Okay, so that is why I already implemented one particular projects, as you can see here. So this is like a financial stock analysis project I have developed with the help of this LlamaIndex. So first of all, I will show you the demo of these projects. Okay, like what is the projects and all about. So those who are interested in the field of financial, or let's say in the domain of financial, so they will be loving this project because here you can do like stock analysis. Okay, so we have some stock data, we have some articles actually, as you can see. So these are the articles I have downloaded from the internet, and this is in the HTML format. So we'll be processing, these are the data, we'll be collecting the content. Okay, if you see, this is the completely HTML data. So here we have lots of like financial stock data, like we have Google data, then we have Nvidia, we have Meta. Okay, then we have MS here if you see MSFT. Okay, as you can see, so we have different like you can say companies stock data here. So I already given the link of the data in my GitHub, so you can download from here. I will show you like how to download the data. So that script I have already written. So first of all, let me execute the project. So I will first of all execute this projects and show you like how it will work. So see guys, this is the Streamlit app I have developed, and here you can do two kinds of analysis. One is like you can do a single stock analysis, another is a competitive analysis. Okay, like competitor analysis. I'll show you both of you. Okay, so here first of all, let's do the single stock analysis. So I'll just ask what is the stock of, here if you see, so they have given the short name for each and every company. If you come here, so I've already listed down. So let's ask for the Nvidia. So I'll copy the Nvidia, and here I will ask. So guys, as you can see, I have asked like what is the stock of Nvidia, so it is giving me the answer. Okay, you can see it is giving like 2023 to 2027. Okay, it's giving the stock, as you can see. Now, and you can ask for any kinds of stock. Let's ask for the Google. So I'll copy Google, and here if I paste and enter, So now it will give me the stock of the Google. So that's how actually you can ask different stock related question. Okay, if you're interested in these kinds of stock and all, so you can ask lots of question and you can get the response with respect to that. Okay, as you can see, this is the Google stock answer it is giving. Now you can also perform like competitive stock analysis. So just select the competitive one. Now it will give you the interface of the competitive analysis. So guys, as you can see, this is the competitive analysis one. So now here you need to provide stock one symbol and stock two symbol. So let's do like MSFT, and I will also do for my NVIDIA. Let's see the competitive analysis between them. So see guys, this is the competitive analysis between them. As you can see, you can read it out. Okay, so not only that, you can see like competitive analysis between all the company. Here is the listed. Okay, and this is the symbol of the stock. Like you can't directly pass the company name, so you need to give the symbol. Okay, because this is your custom data you have given like that. So yes guys, this is the projects actually I have developed with the help of this LlamaIndex, and this is very much interesting projects like in the field of financial domain. And you can see implement lots of thing with the help of this LlamaIndex. I think I already showed you like lots of like functionality and all, and I already showed you lots of things. Okay, with the help of open source model and all, you can implement anything. Okay, whatever you can think in your mind, you can implement anything. Just you need to try from your side. Okay, now guys, let me show you like how I have developed these projects. Okay, so this is the projects guys I have already developed, and let me show you. This is the code for the projects. Okay, so I'll explain each and everything, like whatever things actually I'm doing, and I've already given the idea about LlamaIndex and this Streamlit and all. So I think you are already familiar with these are the thing. Okay, I'm expecting, so that's why I'll be explaining the projects. Okay, instead of writing all the line from scratch. So first of all, let me stop the execution. Then I will remove this article folder because this is my generated folder. Then I will also remove this stories. Okay, stories, I think you remember stories is nothing but it's a vector store we created with the help of LlamaIndex, right? So both I have deleted. Now here is the readme file I have already shared, like what are the steps you need to perform. So here first of all you need to clone the repository. So this repository will find from the description section. So from there actually you can download the projects. Then you need to create one environment. Okay, Python environment using Python 3.8. Then you need to activate the environment. Then you need to install the requirements. So requirement wise, I mean using these are the requirements as you can see. So you are using LlamaIndex, then Streamlit, python.env. Okay, and apart from that, I'm also using OpenAI and some you can say dependency package I'm also installing here. So this thing you need to install. I already showed you how to install them and all, how to create the environment in my previous project implementation. Then after that, you need to execute this app.py. Okay, but before running the app.py, you should have your data and you should have your vector store presence. Okay, otherwise it won't be working. So for this actually in the src folder I have written some of the script. As you can see, first of all we need to fetch the data. So this is the link guys. So in this link actually this articles is available. I have already given this link and this is hosted on my GitHub. So from here you can download those data set. Okay, download those articles, and after that see I have written one function. With the help of this function I am downloading. So basically it will take this URL, data URL, and it will download that zip file, okay, from my GitHub, and it will unzip it. Okay, it will unzip it here, and that zip file it will remove. Okay, so this is the code I have written. Now let me show you how it is working. So I already created the environment. So now I'll execute this particular file. So I'll just write Python inside src. Inside src I have one file called 01 fetch data. Okay, I will execute this file. Now see guys, it will download that data from my URL. So see guys, it has downloaded all the HTML file, and now see if I open my articles, all the data are present. Now what I need to do, I need to create one vector state. I think you already know like what is vector state. I already explained these are the thing in my notebook experiment. Okay, what are the steps I perform, same thing I'm doing here also. Okay, so to create the vector store, I created another file called indexnews.py. So here I'm using this GPT vector store to create my vector embedding.
So here you can also use Google PAM embedding, you can also use Hugging Face embedding, anything you can use. Just try to use open source embedding, because if you don't want to use like OpenAI, so if you don't want to spend money, so you can go with like open source model. Otherwise, if you have like OpenAI account, you can also use OpenAI API key. So here if you see, I have already set my OpenAI API key. So by default, if you're not giving any embedding models, it will take that OpenAI embedding model. Okay. So this GPT vector store index already has like GPT based embedding model. It will take that model and it will convert your data to vector embedding. Okay. So guys, this should be your task. Just try to replace this code with your open source model. I think I showed you how we can use Hugging Face embedding model in this notebook. See guys, here Hugging Face embedding model I was using. So you also need to use Hugging Face embedding model here. Okay. In this case, I'm using OpenAI. So you need to replace with the Hugging Face embedding model. Okay. I think I already showed each and everything, so you can do it. Now let me first of all generate these are the embeddings. So I'll clear. Then I will run this second file. So it's 02. So it will take time because it will take all the articles. It will convert to chunks. Then it will like convert them to vector embedding. Okay. Then it will create the stories here. So here you can also integrate like vector database. So you can use Pinecone, Wave8, and you can also use ChromaDB. But I'm using this default like vector store index. So LlamaIndex provide this thing. So it will store your embedding local. Okay. It will create one storage folder and it will store here. So you can also use a vector database and you can store them in the cloud as well. Okay, I already showed you. Just try to integrate here. So guys, as you can see, my storage has been created. Now this is my vector. So see, these are my embedding. So these are my vector. Okay, so now we are successfully able to store our vector embedding. Now see, now this is the third script I have written. So if you want to test on top of your like storage, so here I'm loading the storage and I'm just asking one query like what is tell me about Google's new supercomputer. Okay, so this is the query I'm asking, so it will give you the response. So you can try out. Okay, so let me execute and show you how it is working. So I'll just write Python. Then inside src, I have this 03. Yeah. So see guys, this is the response I got. Okay. So yeah, that means my storage has been created successfully and we are also able to ask the query on top of it. Now we'll be converting, these are the thing, okay, as our app. So basically I will give some of the input. Okay, user will ask the query and they will also select like they want to perform like say single stock analysis or let's say multiple stock analysis. So this kind of functionality I'll also add. So for this I have already created one app.py. As you can see, this is the app.py. Here if you see, my index is already created, so that's why I'm importing the storage context and load index from the storage because I want to load it. Then I'm also importing like LLM wise OpenAI because I told you I'll be using OpenAI like model here instead of using open source. So here you just need to replace this OpenAI model with your open source model. You can also use PAM2, then you can also use Llama 2, anything you can use. I already showed you this thing in my this notebook experiment. Okay, in my LlamaIndex session, just try to replace that. These are the model here. Then model wise, see, I've initialized GPT 3.5 turbo. Then here I'm just defining my LLM predictor. And I think you remember we had created one service context. Okay, so in LlamaIndex we create something called service context, and this will take your LLM. So once it's done, I'm also loading my storage. That means this vector embedding. Okay, as you can see, I'm loading, I'm giving the path. Once it is done, I'm creating this query engine. Okay, so once query engine is ready, now we'll be creating the front end part. So here basically if you see here, we are creating this title and all, like this is the title financial stock analysis. So let me execute and show you how this thing will look like. So see guys, this is the title and this is the report subtitle. So these two I've created. Now here I'm creating one select box. So what type of like report you want to So this is the select box, guys. Let me show you. This is the select box. So if you want to create any kinds of select box, you need to select select box from Streamlit. And here is the message I've given. So what type of report you want to do, and a single and competitive. So here if you see these two things I'm giving here. So single and competitive. Then if user is selecting single one, okay, so first of all we'll be handling the single. So here is the prompt I have written. Let me show you. So I'm just using my engine query engine. So as you can see, query engine we have already created, and this is the like prompt I'm just giving. So write a report on like on the outlook for symbols. Okay, symbol user will give me that. Okay, user will give me that symbol, because as you can see we are receiving the symbol. So as a text, input text, basically here is the symbol as input text we are receiving, and that thing we are passing here, okay, as a string. Then once it is done, this is my prompt, stock from, I'm just mentioning the year, I need this stock from this year, and I'm also telling like be sure include the potential risk and the headwinds. Okay, so this is my prompt I have given to my LLM. So my LLM will give me some response, and that response actually I need to showcase. Okay, so I'm just using st.write, and I'm just passing my like this response, and it will show here. So once it is done, so I'm also handling the competitive analysis. So if user is selecting competitive analysis, so first of all I'm taking like two competitive. As you can see, if I select the competitive one, so here if you see I'm receiving the stock 1 and stock 2, and this thing actually I'm storing symbol 1, symbol 2, and this is the my second prompt. Okay, so I'm just write a report on the competitive between my symbol 1 and symbol 2 stock. Okay, then it will give me the response, and that's the response I'm showing in my front end. So this is the simple logic actually I have written behind these projects. Okay, and this is like very easy. Now you just need to like convert them to open source model, and if you have any idea on top of it, you can also create it. Okay, I think you got the overall idea, and all the resources actually will get from the description section, no worries about. Okay,
Hello guys, my name is Bapi Ahmed and welcome to my course. So guys, in this video, we'll be implementing one end-to-end generative AI project called end-to-end medical chatbot. So I think you already know what is medical chatbot. Let's say if you have any medical related query, let's say you got one disease. So you are asking for the diagnosis, you are asking for the medicine. So this bot will able to give the response with respect to that. That means it will give you the suggestion, it will give you the medicine suggestion, it will give you the diagnosis suggestion. So these kinds of information this bot will provide. So we'll be creating the complete system here. That means here first of all we'll be using our custom data. The entire, let's say, medical information custom data will be using. First of all, we'll be teaching our model, we'll be creating the entire knowledge base. Then I'm going to connect my large language model there. So that means whatever information you'll be asking related the medical, let's say any kinds of disease, any kinds of medicine, any kinds of, let's say, diagnosis. So everything your chatbot will be able to give you the response. Okay, so this is the system we'll be implementing. And this is not going to be, guys, like notebook implementation. So here we'll be creating the complete pipeline. That means we'll be creating the front end part of our application. That means we'll be creating the beautiful user interface so that user can put the query and they can get the response from the chatbot. Fine. And here we'll be using something called modular coding in Python. So it's not a like scripting programming we'll be writing. We'll be using modular concept here to implement the entire project. Fine. And also we'll be using the Git and GitHub to, let's say, do the version controlling. So that means we'll be following the entire development pipeline here. What are the things you need? Even I will also show you how we can deploy this project, okay, in a cloud platform. So everything, guys, will be implementing in this project. So make sure you're watching this video till the end. And if you have any question, you can feel free to ask me, okay, in the comment section. So first of all, what I will show you guys, I'll show you the entire project architecture, like what are the things we are going to develop. Then I will also show you the tools and technology we'll be using here. Then we'll start the implementation. Fine. So let's open up our Blackboard and try to understand the project architecture. So guys, as I already told you, we'll be using our custom data here. Okay, we'll be using custom data, custom medical data. I can write medical data. So let me show you, I'm having one entire actually medical book. So guys, you can see this is the book. The book name is the Gale Encyclopedia of Medicine. Okay, second edition. So this is the book. You can also search on Google, you will get this book. And it is having around 637 pages. It's like very big book, and it is having all kinds of information regarding the medical. So see, if you open this book, actually you will see all kinds of content. Let's say all kinds of disease, even with respect to that disease, what kinds of medicine actually you need, what kinds of diagnosis technique you need, everything this book has covered. Okay, so it is having different treatment, different actually medicine, different disease. Even the disease image is also visible here. All kinds of disease actually it is having. All kinds of disease actually it is having. Even with respect to that, they have also given a diagnosis, even the treatment. Okay, how, let's say, you can do the diagnosis, how you can do the treatment, what kinds of medicine you have to, let's say, take. Everything this book has given the information. So here we'll be using this book, actually the entire medical information, and we'll be creating the knowledge base. That means here we'll be using Pinecone vector database. Okay, I think you know Pinecone is a cloud-based vector database. That means there we can store the embedding, vector embedding. That means first of all, we will be extracting all the information from this book. Then we'll be creating the chunks, and that chunks actually with the help of embedding model will be creating the vector embedding, and that vector embedding will be storing to the Pinecone vector DB. And that Pinecone vector DB is going to be my knowledge base. That means the entire knowledge base. Why I'm not using the local vector database here? Because my data size is huge. If you see 637 pages information I'm having. So if you just create the chunks, just try to consider how many chunks you will get. And if you're storing in the local DB, it won't be efficient. So that's why we'll be using cloud-based vector DB here. Fine. And I'll show you how we can use the Pinecone properly. It's one of the amazing vector DB when I personally prefer. So there actually you can also see your vector visualization. Okay, everything you can see. See, this is another actually disease. See, this is the disease actually. Even with respect to that, they have also given the diagnosis as well as the medicine. Now I'll share this PDF with you guys. You can see the complete book if you want to see different medicine and different let's say diagnosis. Okay, you can check it out. So here what we'll be doing, guys, we'll be using this medical book. So let's say this is one PDF documents actually I'm having, or here I can write medical. Okay, medical book. So from the medical book, what we'll do, we'll just extract all the information. Extract all docs. Okay, then after that we'll be creating different chunks, and I think you know what is chunking is required, right? Because here we'll be using large language model, and large language model is having input actually size, one specific input size, and we have to follow that input size. I think previously we learned about llama is having 4096. Okay, this is the input length. That means this is the maximum input length it can take the data. If you're using OpenAI model also, let's say GPT. Okay, GPT is also having one specific input length. If you want to see that, just open the openai.com and go to the model section. You will see that GPT input length. So whatever actually large language model you are using, first of all, try to see the input length, okay, of that model. Like what would be the maximum token size? Based on that, try to perform the chunking operation. Okay, that should be my suggestion. Now it will give me different chunks. So let's say I will get chunk 1. Okay, chunk 1. We'll be getting chunk 2. We'll be getting chunk 3, and so on. Then after getting the chunks, what I have to do, guys, I'll be using one embedding model. Embedding model. Okay, with this embedding model, we'll generate the vector embedding. Okay, it will give me different vector embedding. So you'll be getting vector embedding. I can copy and I can paste it here. So we'll be getting different vector embedding. And with this vector embedding, guys, what we'll do, we'll just try to build one semantic index. That means the knowledge base, right? Build semantic index. So this is going to be my knowledge base. That means we'll be storing this vector to the vector database. So I can write knowledge base. Okay, knowledge base. And here we'll be using something called Pinecone vector store. Okay, so let me just write vector DB. Okay, DB vector DB. And guys, this is going to be my complete backend component. Okay, so here I can write this is going to be my backend component. Okay, component. Now I have to work on the front end component. That means user will give some query, and with respect to the query, actually, I have to give the proper response. Okay, let's say this is the user. This is the user. So user will send one query. Let's say this is the query user has asked. So first of all, it will convert to the query embedding. Okay, query embedding. That means this is going to be an English text, right? And that should also convert it to the vector embedding. This vector embedding will go to the knowledge base. Okay, it will go to the knowledge base, and knowledge base will return some rank results. Okay, rank result or similarity. Let's say result it will return. Okay, rank results. So then I'll be using one large language model. So here we'll be using one large language model, LLM. So here I'm going to use OpenAI large language model. You can use any kinds of large language model. You can use open source large language model. Okay. You can also use the Gemini. You can also use, let's say, Mistral, anything you can use here. So here I'm going to use OpenAI large language model because here I'm going to create a production ready application. So this application will be also deploying in the cloud platform. Okay. That's why I'll be using OpenAI model. Okay. Why OpenAI model? Because OpenAI model is already hosted in the OpenAI server. We can access this model through API request. But if I'm using any open source large language model, we have to download this model in our local machine. And local machine doesn't have like good configuration, let's say instance. Let's say you don't have good configuration GPU, you don't have good configuration actually RAM, CPU. That time actually you can't execute this model in your system. Okay, it will be very much difficult for you. And you will see that inference time would be also very high. That means this model will keep processing the input. It will take lots of time to give you the response. So that's why we'll be using OpenAI model. And going forward, I'll be discussing about LLM ops, and there I'll tell you how we can also use like different open source large language model. Let's say if I want to use Llama, okay, Llama. If I want to, let's say, use Mistral, Pinecone, okay, Cloudy, any kinds of model. If I want to use, how I can use it, even how we can use it as an efficient way, even how we can deploy these are the model in the cloud platform. So for this, we'll be using something called LLM ops. Okay, LLM ops will be using. That means we'll be using different platform. We'll be running about Bedrock, okay, AWS Bedrock. We'll be learning about, let's say, GCP Vertex AI. So these are the LLM ops platform. Okay, so we'll be using this LLM ops platform to access these are the model, and on top of that, we'll be creating the application. Fine. So this is what actually we'll be explaining later on, guys. So first of all, try to see how we can implement this production ready project with the help of OpenAI model. And there is another reason actually we are using OpenAI model, because if I let's say if I'm using open source large language model, you will see that open source large language model size would be very huge. Let's say around 10 GB, 20 GB. And this model you can't execute in your local machine. That means your low configuration machine. And if you're deploying this project to the cloud platform, there you have to take good instance. That means you have to take GPU based instance with higher RAM, higher CPU, higher GPU. And just try to consider about the cost, like how much cost actually it will take that cloud platform. You can go to any kinds of cloud platform. You can see their instance actually type. If you're taking GPU based instance type with higher RAM, higher, let's say, CPU, you'll see that per hour it will cost you like more amount of money. Okay, so again, you are increasing the cost here whenever you are using open source large language model. Okay, without any kinds of LLM ops tool, LLM ops platform, you will get the difficulty for sure, right? So that's why we'll be using here OpenAI model. Although it will charge you, but it will charge you less than the open source model actually will be hosting in future. Okay, this is the idea here. So now what will happen? This rank results will go to the LLM. Even this query also will go to the LLM, and LLM will process. LLM will try to understand the query as well as the rank results, whatever results actually your knowledge base is returning. Based on that, it will give you the correct response. Okay, correct response. Or you can talk about answer. Correct answer. Let's say you are asking one question. Let's say I got fever. What can I do? So it will first of all refer the knowledge base. It will try to find out the, let's say, fever diagnosis, fever medicine. Then with respect to that, it will give you the response. Got it? So this is the entire system actually will be implementing. And this is what actually our front end. So this is what actually our front end. Many people also ask me like, sir, just try to create some application with the help of good front-end development as well. So that's why I also kept this front-end development here. We'll be creating one beautiful user interface so that user can give the query here. I think you use the ChatGPT. ChatGPT is having one beautiful user interface. Okay, so we'll be also creating this kinds of chatbot kinds of interface so that user can give any kinds of query and they can get the response. Fine. So this is the entire architecture of our project, guys. Okay, I hope it is clear now. Now, technology-wise, I already told you. Here we'll be using a large language model, OpenAI. Okay, OpenAI, LLM will be using. Then here we'll be using LangChain as a generative AI framework to develop the entire project. Then here we'll be using vector database, wise Pinecone. Okay, Pinecone is a cloud-based vector database. Okay, so there actually you can create a instance and you can store your vector. And here to create the user interface, we'll be using something called Flask. Okay, Flask is a Python framework. You can create web application. Okay, with that. Got it. Yeah, so I hope these are the actually technology we'll be using as of now. And if I need it, anything, I'll tell you. Okay, later on. Now, guys, what I have to do, guys, first of all, let's create one. Yeah, so let me also write. We'll be also using GitHub. Okay, GitHub to do the version controlling of our entire application. Fine. And later on we'll be also deploying this project to the AWS cloud. Okay, AWS cloud. So we'll be learning about the simple deployment as well as the CI/CD deployment. Okay, both will be learning. So guys, this is the entire agenda. So now let's open up our GitHub and try to create one GitHub repository first of all with our project. Then we'll be starting with the implementation. Fine. So I'll go to my GitHub, guys. So this is my GitHub. You can also follow me here. I have created lots of repository that might help you a lot. So just go to the repository and here create one new repository and give the name. Let's say I want to create a medical. I'll just write end-to-end. Okay, medical chatbot generative AI. So this is my repo name. You can give any repo name as per your requirement. Now I'll be keeping it as a public repository because I want to share this code with you so everyone can see that. I will add the readme file as well as I will add the .gitignore file. So here I'll be using Python programming. I'll be selecting the Python. Let's take the license. You can take any license. I'll be taking AMIT license. Now everything is fine. Now let's create the repository. Okay, now let's clone the repository. I'll copy the link address. Make sure you selected HTTP1. Now open up your local folder. So let me open up my local folder and here I'll open up my terminal. You can open up your, let's say git bash. You can open up your anaconda, anything, and just write the command git clone and press the link here. So it will clone that repository in your local machine. Now see, it has cloned. Now let me go inside this folder. You can see currently I'm inside LangChain project. Okay, now I want to go inside this folder. So I'll just write cd. Cd means change directory. I want to go inside end-to-end medical chatbot generative AI, this folder. Okay, now if I hit enter, you will see that I'm inside this particular folder right now. Now I'm inside this folder. Now inside this folder, I'm going to open up my VS Code. So let's open up my VS Code. So this is my VS Code, guys. Okay. Now let me zoom. Now the first thing, guys, what I have to do, I have to create one virtual environment here, because I already told you if you are creating any kinds of end-to-end project, first of all create a virtual environment, then you have to set up all the requirements you need here. So here let me add all the step you need to perform. So here I have added all the step in the readme file. First of all, you have to clone the repository. If you are using my repository, first of all clone it, then try to create the environment with this command. So make sure you are using Python 3.10. Okay, so I'll copy the command. You can give any name. I have given LLM app. You can give any name here. Fine. So what I can do, I think use medibot. Okay, I can use medibot. You can use any name. Now let's create the environment. So guys, as you can see, my environment is created. Now let's activate. For this, you have to execute this command. All the command I have shared in the readme file, just try to copy paste. And I will also push this code in my GitHub so that you can see the changes. Now see, medical bot has been activated. Fine. Now the next thing, we'll be creating one file called requirement.txt file. And inside that, I'll be mentioning all the requirements I need. And we'll be installing all the requirements here. So guys, here are the requirement list. So these are the requirements actually I need to implement this project. We'll be using sentence transformer, because here we'll be using open source embedding model to generate the vector embedding. So that's why we'll be using sentence transformer, and sentence transformer uses actually transformer library. That means it will use HuggingFace platform, HuggingFace hub to download that model, open source model. And with the help of that model, actually we can generate the vector embedding. And here I'm installing one specific version. You can also install the latest version, but this is the stable version I'm installing so far. Then LangChain, I think you know LangChain. Then Flask we need for the user interface. Then PyPDF, here we'll be using PDF document, that's why. Then Python.env, why? Because here we'll be managing one .env file. Okay, .env file. So inside .env file, we'll be mentioning our OpenAI credential, as well as we'll be also mentioning our Pinecone credential, because Pinecone, you also need to use one API key to authenticate with your account. Fine. Then you can see I'm installing Pinecone, and if you want to install Pinecone, you need to install this tool library, Pinecone grpc. Okay. Then you need to also install a LangChain _Pinecone. Then LangChain community, LangChain OpenAI, and LangChain experimental. Okay, so these are the dependency package you also need to install. So let me install all of them. I'll just try to save. I'll open up my readme file. I'll copy the command, and here I can execute. Now see, it will install all the packages one by one. So it may take some time, guys. Let's wait. Once installation is completed, I will come back. So guys, as you can see, my installation is completed. There is no error. That means congratulations, you have installed successfully everything. Now let me minimize the screen. And now let me save everything. Yeah. Now see, whenever you are implementing any kinds of end-to-end projects, the first thing you have to create the project. Okay, project folder structure. Struct structure. Okay, this is very much important, guys. That means you have to create the entire project folder structure, like in which folder, in which file you have to write which function. Okay, that's how you have to create the entire project folder structure. And again, this is your actually, let's say, design pipeline. Okay, it's not like that you have to follow my pipeline always. You have to follow my project folder structure always. If you feel like, okay, this folder structure is good for you, you can use it. Just try to design with respect to your project requirement, with respect to your, let's say, choice. Okay, no need to follow my one. But if you want to follow my one, you can also follow. I usually prefer one project folder structure. Okay, so I'll be showing you how we can implement this particular project folder structure. That means automatically we'll be creating the project folder structure here. So here we'll be creating one file. So the file name is template.py. Okay, this is going to be a Python file. So this will create the entire project template for me. So here only I need to give my one-time effort. That means I'll be writing the entire logic to create the structure. Going forward, whenever you want to create any kinds of project folder structure, you can execute this file. It will automatically create. Otherwise, what will happen? You have to manually create it. Let's say you want to create a folder. You will be clicking here. You will give the folder name. Let's say test. Okay, then I want to create another file inside folder. Again, you will be opening this folder. Inside that, you'll be creating another file. Let's say test.py. Okay. So this is like very time-taking task. Let's say you want to create 100 of folders, 100 of files. Just try to consider how much time it will take. Even you have to manually check everything, whether this file is present inside this folder or not. So it's not a efficient way to create the folder structure. Okay, you can create it, but I won't be suggesting you because it will take lots of time. So what you can do, you can create one template file. And inside template file, you can write one very Python basic code, and this code will automatically create the project folder structure for me. Let me show you how we can create it. So for this, I'm going to use some package. I'll be using operating system package. Then I also need something called pathlib. Okay, so let me import. So from it is available pathlib import. Okay, path. I need the path. Why I need the path, I'll tell you later on. As of now, let me import all of them. Then I also need something called login. Okay, so login is an inbuilt package inside Python. So here I will also log the information in my terminal. Fine. So first of all, you have to create a logging string. Okay, so basic logging configuration you have to create. So that's how you can create a basic logging configuration. See, okay, this is the basic login configuration. So here you have to write logging.basic config. Inside that, you have to mention the log label first of all. So here I am to create an information label log, and this is the format of my log. That means first of all, it will save the ASCII time. That means the current timestamp. Like let's say whenever you are executing your code, it will save that timestamp. That means the time, date. So it will save everything. Then after that, it will also save the log message, like which message you want to show. Okay, it will also save that. So whenever I'll execute the code, you will get it. Okay, what I have written here. As of now, just try to consider. You have to mention this logging string here. Fine. Okay. Now you have to give a list of the file you want to create. So let's say left hand side, I want to create some list of the folders and file. So for this, I have created a Python list. You can see. So the name of the list is list of the files. Inside that, I've mentioned I want to create a folder. You can see folder name is src. Okay, so it will create a folder here called src. Inside src, I want to create a file called init.py. That means __init__.py. And this is nothing but my constructor file. If you already familiar with OOP concept, I think you know what is constructor. So constructor is nothing but it's a special method. It's a, let's say, the magic function. It can execute automatically inside OOP. But you can also create actually constructor as a Python file. Okay, so if you open up any kinds of end-to-end project, now let me show you. So if you go to any kinds of end-to-end repository, let's say if I open TensorFlow GitHub, it's an open source project, so I can also see their code implementation. See, they have also follow the modular approach. See, if I open any kinds of folder, let's say if I open Java folder or let's say Python folder. Now, if you just go below, you'll see this constructor file is present here. Okay, why? Because they have created so many folders. You can see so many folders, and inside that they have created different Python file. So this folder would be considered as their local package. That means they can also import some functionality from this folder. Let's say I want to import, let's say this particular function. Let's say this function, import a graph depth. What I need to do, I need to write. So what I have to write, from TensorFlow.python. Okay, then dot this file. And import, I want to import this function. Okay, that's how I need to import this file. That means instead of writing like all the function in just one file, what I'm doing, I'm creating a different folder. Okay, different let's say component. Inside that I'm keeping those functionality. Okay, and whenever I need it, I'll be using it later on inside my endpoint. Okay, this is called actually modular approach. And to whenever you are like following this modular approach, whenever you are creating this kinds of folder to keep your function, in a file, make sure you are creating this constructor file, because this folder would be considered as your local package. Okay, because later on you have to import it. Let's say from tensorflow.python import this function. So whenever you will be importing, make sure your Python interpreter will consider this is my local environment. Okay, that means I can import something from that folder. This is the idea. Okay, so that's why we are creating this constructor file, because src is my folder. Inside that I'll be creating one file called helper.py. Okay, and helper.py, inside helper.py I'll be writing all the functionality. Let's say I want to ingest the data, I want to, let's say, extract the information, I want to download the HuggingFace model. All the functionality I'll be writing inside helper.py. Okay, this is the idea. Now apart from helper.py, I need another file. So inside src I'll be creating another file called prompt. Okay, prompt.py. Inside that I'm going to write the prompt. Okay, prompt, whatever prompt actually I need. The prompt, let's say whatever system prompt I'll be using, inside that I can write it here. Now I want to create a env file. Then I want to create a requirement.txt file. Oh, sorry, requirement is already created. I can remove it. As of now, I don't need it. I want to create a setup.py file. Why setup.py file? Because I want to install these are the folder as my local package. For this, I need setup.py. Okay. Previously, I think I already explained this part. Then app.py. Then I want to create a folder called research. Inside that, I want to create a Jupyter notebook file. That means trials.ipynb. So inside that, first of all, we'll be doing the Jupyter notebook experiment. That means the entire project will be implementing through Jupyter notebook. Then we'll try to convert everything as our modular coding. Okay, this is the idea. So this is my list of the files and folder I need. Now I have written a simple Python logic. Let me show you guys. It's not a very fancy code. It's a simple Python code I have written. So this code, it will loop through this list one by one. That means it will loop through this list one by one. See, I'm looping through the list. It will give you the file path, the entire file path. Then you are giving this path to the path function. Why you are giving to the path function? Because see, here we're using Windows machine, and Windows by default use backward slash. I think you know. See, if I click here, see, Windows by default use backward slash. But which slash actually we are using here? We are using forward slash. Okay. But in Linux, Mac actually, they will be using this forward slash. But in Windows, you have to use backward slash. So that's why to I overcome this issue, we are using path, actually path library from pathlib. See how it will work. So let me show you one example. So first of all, I will open up my Python. Okay. Now here, let me first of all import. So from pathlib, okay, import path. Okay. Then let's define a path here. So I'll just write p is equal to test, let's say slash t.py. Okay, let's say this is my folder. Inside that I'm having one file. Now what I will do, okay, it has given me one error. Let me see the error. Okay, so test is not defined. That means I need to give inside a double quotation because it's a path, not so it should be a string type data. Now fine. Okay, now if I give this p to my path function, now see what will happen. It will automatically detect my operating system. Based on that, it will convert that part. See, it has given me Windows path. It has automatically detected my operating system. Based on that, it will convert this path to the Windows path. Let's say you are using Linux, you are using Mac. Automatically, this path would be converted to that operating system. Okay, so that's why instead of manually giving that path as a backward slash, what I can do, I can give to the path function. Path will automatically take care. That means we can execute this project in any kinds of operating system. Okay, otherwise, in some of the operating system, you might get some issue. Okay, that's why we have to always handle this kinds of scenario. Got it? So whenever you are designing your software, make sure you are handling these kinds of scenario and you are making your application more robust. That means in production, it won't be failing. Whenever it is failing in the production, this is not a robust application. Always you need to take care. Then after that, what I'm doing, I'm just splitting my folder name as well as the file name with the help of this actually function. So inside operating system dot path dot split. So what path dot split will do? It will split your folder name and your file name. That means inside this file directory, it will give the folder name. Inside the file name, it will give the file name only. Okay. So you can also execute and test. So let me show you. So let's say this is my path now. So this is my folder and this is my file. Now if I use, first of all, let me import operating system. So if I give os dot path dot split. Okay. Inside that, I'll give the p. Now see, if I hit enter, it will give me one tuple. See, so in the first item, it should be my folder and the second item, it should be my file. Okay. And this is what actually I'm storing inside two variable. Okay. Two variable. I'm doing the tuple unpacking here. Okay. I hope it is clear. Then first of all, I have to create the folder. Okay, I have to create the folder, and to create the folder I'm using was.make directories. So first of all, I'm checking whether this file directory, it is empty or not. If it is not empty, that means definitely I have some file folder name here. So I'm creating the folder, you can see. Then I'm performing the login operation. I'm just doing the login in my terminal. I'm telling creating a directory, file directory for the file of file name. Okay, this is the log message actually I'm printing in my terminal. Then after that, I'm also creating the file. That means folder creation is done. Then inside the folder, I also need to create the file. For this, I have written this code actually. First of all, I have to check whether this file path is exist or not. If it is not exist, that means if it is not created, I have to create it. Otherwise, it is already created. Now I don't need to create it. And I also check the size of the file path. That means the file, it is 0 or not. Let's see if it is not 0. That means inside that file, I have written some code. So I don't need to delete that file again. Let's say you want to create again. It won't be replacing that file. Instead of that, it will skip that file. So that's why I'm also checking the size. If size is empty, I'm creating this file, you can see, and I'm doing the login information. Otherwise, I'm telling this file is already exist. Okay, so this is the simple Python code I have written. Now see the power of this script. Okay, see the magic. Now left hand side, see there is nothing. There is no folder structure, no file. Now if I execute this script, now see what will happen. I'll clear. Now I'll simply execute this template.py file. See template.py. See automatically it will create the folder structure for me. Got it? So it's just a one-time effort, guys. You have to like write this code only one time, and later on you can use it every time. Let's say you want to create another project. Copy this file, try to execute. It will automatically create a folder structure for you. Let's say in future I need some more actually. Let's say folder, or let's say file. Let's say I need another file called test.py. I'll just add it here. Make sure you are giving inside a string, okay? And you are giving a comma here because it's a list. Okay. Now see, I'll execute it again. It will automatically create that for me. See, test.py is also created. That's how we can add as much as file and folder you need. Okay, it will automatically create. You don't need to manually create it here. Okay, this is the advanced ways to use this template.py file, guys. Okay, I hope it is clear. Now you can check it out. So inside resource, this trial.ip1b file is created. Now inside src, init created, helper created, prompt created. Okay, you can see init created, helper created, prompt created, .env also created, app created, setup.py is created. Okay, everything has created. So now let's set up our project as my local package. Okay. So for this, I'll be writing the setup.py code, and this is a simple code, guys. I think previously I also shared. So this is the setup.py code. First of all, give the project name. That means the package name you want to give. Let's say generative AI project. Because if I show you currently in my terminal, inside my environment, this package is not present. So I'll just write pip list. See, generative AI project is not there. Okay. So I have to install as a generative AI project. Okay. For this, we'll be using the setup.py. Now give the version, author name, email. Okay, and find package will try to find this __ init.py, and whenever this init.py is present, it will consider this folder as my local package. Okay, let me show you. Now to install this one, you need to give one command inside requirement.file called -e space dot. Okay, -e space dot. This is the command. Now let me say. Now let me again install the requirements. Now see, automatically it will install as my local package. Now see, one egg info file would be created here, and whenever this egg info file is created, that means this project has been set up as my local package. Let me show you. Now if I again do the pip list operation, now see, generative AI should be there. See, generative AI project is there. Now it is my local package. Okay, that means now I can import anything from this SRC itself. Got it? So this is the entire idea. Now let's commit the code in my GitHub, guys. So for this, I'm going to open up my git bash, and here I'm going to write one command called git add, then git commit -m. Now let's give one commit message. Let's say folder structure added. Then let's do the push operation. So git push origin main. Okay, now it has pushed. Now if I want to check, let's go back our GitHub. Now let's refresh. Now see, it is pushed in my GitHub, and readme is also updated. Now you can copy all the command and you can execute in your system. Okay, I hope it is clear. Great. Now the first thing, we'll be doing the notebook experiment. Okay, first of all, we'll be implementing the entire project in our Jupyter notebook. Then we'll be converting as our modular coding. And after implementing Jupyter notebook, only you just need to copy paste operation. Okay, that's it. Now, first of all, let me select the kernel. So I already created one environment called medibot. Okay, so let's select it. Now let's test whether this is working or not. So I'll give one print statement. Let's say print okay. So this notebook should work. Now it is telling just try to install some IP1B kernel package. So let me install, because I'm using Jupyter Notebook inside my VS Code. For this you need some additional package and it will automatically install for you. So it will take some time. After that you will see that execution would be completed. So let's wait. Okay guys, so as you can see, execution is completed and it is giving me okay message. Okay, it's fine. Now one thing I just wanted to show you, let's say if I show you my project working directory right now, let's say pwd. So I'm inside this resource folder. Okay, inside resource folder, but I want to load my data, and that my data would be present inside my data folder. Let's say I'll create a folder for data. Okay, inside that I'm going to move the PDF I'm having. Let me move quickly. So guys, as you can see, inside data folder I'm having the PDF. Okay, PDF document. Now see, whenever you are implementing any project, make sure you are working in the project directory. Okay, that means your root project directory. So this is my root project directory, but currently I'm inside this resource folder. But if I want to get back, okay, inside my project working directory, so what I have to do, I have to execute one more command. So let me import operating system package. Inside operating system, you are having something called change directory. Okay, let me show you. So os.chdr, that means change directory to hire one folder back. So for this, you can write // okay, // means, so // means it will get back one folder back. Okay, let me show you. Now if I execute, now if I again show you the pwd project working directory, now see I'm inside my root project folder itself. Okay, so that's how actually you can check the folder location first of all. Okay, otherwise what will happen, you will get like path issue. Sometimes you'll get, let's say, data not found and so on. Okay, so that to prevent this issue, actually make sure you are working in the project folder directory always. Okay, this is the suggestion I want to give you. So first of all, let's import some of the library here. So here I'm importing LangChain. From LangChain, actually I'm importing PyPDF loader and directory loader, because I have told you I will be using PDF documents, and to load the PDF documents I need this PyPDF loader, and it is present inside a directory. Okay, that's why I have given directory loader. Then I also need to perform chunking operation, and to perform the chunking operation I can use recursive character text splitter. Okay, I think you already familiar with these are the thing. Now let me import all of them. Now here to load the PDF, here I have written a function. Let me show you. So this is the function I have written, guys. Okay, extract the data from the PDF itself. So the function name is load PDF. It will take the actually data directory. Okay, data directory, and it will only load the PDF documents. Okay, it will only load the PDF document. Let's say you want to load the docs document, txt document. At that time you can give the extension here. Fine. So with the PyPDF loader, it will extract the information from the PDF itself. Okay, and whatever let's say information it will extract, it will give me as a documents. Okay, you can see. Now let me show you. Let me execute. So it will return me extracted data. So here I've given the path. Okay, so it should be data. Okay, data directory. Now let me show you. So if I execute, now see it is extracting all the information from the PDF itself, and it is having almost 700 actually pages. So it will take some time. So let's wait. So guys, as you can see, my extraction is done. Now if I show you the extracted data, see this is the entire extracted data actually you got. Okay, from all the pages it will show you the data. Now let me comment it as of now. Now what I have to do, I have to perform the chunking operation, because you remember, see the architecture, I have extracted the documents. Now I have to perform the chunking operation. Okay, and to perform the chunking operation I will be using recursive text splitter. So with that I have created another function here. So split the data into text chunks. So it will take the extracted data, it will perform the chunking operation, you can see. So here is the code. So chunk size is 500 and chunk overlay is 20 I have given, and it will perform the chunking operation and it will give you the chunk results. Okay, now let me show you. So now if I execute the function and if I show you the length of the text chunks, now see, you got 7020 chunks here, guys. 7020 chunks you got. Just try to see how much data actually you have in the PDF. Okay, and this is enough information to create one medical chatbot. I believe that. Fine. That's why I have taken this big data, guys. Now see, this is the entire chunks actually I got. Now what I have to do, I have to use one embedding model to like perform the vector embedding, and this embedding I'll be storing to the knowledge base, that means inside my Pinecone vector database. Okay, so now let's download one embedding model from the HuggingFace. Okay, so here is the function I have written, guys. Download HuggingFace embedding model. Now for this I need to import this package. First of all, let me import. So this is the package, guys, HuggingFace embedding. I'm importing from the LangChain embedding. Okay, now let me execute. Now this function will automatically download one embedding model. See, this is the embedding model I want to use. Let me show you this embedding model. So this is present inside HuggingFace. So the name of the model is All Mini LM L6 V2. So this is one actually embedding model and it will give you vector dimensional 384 dimensional vector. Actually it will return you, and this dimension you need because whenever you are using Pinecone vector database, you need to also mention the dimension of the vector, like what is your vector dimension. Whenever you are creating the cluster, now whenever you are creating the index, that time you have to mention this dimension. So that's why always try to remember, whenever you are using Pinecone vector database, try to see what kinds of, let's say, embedding model you are using, and that embedding model returns what kinds of dimensional vector. Just try to see the documentation, you will also already get it. Fine. Now let me download the embedding model. So let me execute this function. I'll download the embedding model. See, it is downloading from the HuggingFace hub, so it will take some time. Let's wait. So guys, you can see my model has downloaded. Okay, now let's test the model, whether it is able to convert my sentence to vector embedding or not. So for this, I've given one sentence here, hello world, and there is a function called embed query, so it will automatically give you the vector embedding. And I'm also checking the length, whether it is giving me 384 dimensional vector or not. Now see, if I execute the program, now see, length is 384, and if you want to see the vector, see, this is the complete vector actually you got. Okay, I hope it is clear. Now let me comment this line as of now. Got it. Now what I have to do, guys, I have to initialize my Pinecone. Inside Pinecone, actually I have to store, these are the vector. Okay, the complete vector actually I'll be generating from my text chunks. So for this, let's open up my Pinecone. So if you want to open up the Pinecone, just write pinecone.io. So this is the website, and make sure you created one account, guys. Just do the sign up operation with your email address. You can create an account. So for me, I already have one account. Let me log in. So guys, as you can see, this is my Pinecone website. Okay, this is the interface of the Pinecone, and this is one of the amazing vector database provider, guys. You will be loving a lot. Even I personally like it. So here, what I have to do, guys, I have to create a index. That means I have to create a cluster. In that cluster, actually, I'll be saving all of my vector. They have also given the quick start, like how we can set up the Pinecone, how we can, let's say, store the data. See, all the code example they have also given. Okay, so we'll be following the same approach to store our embeddings to the Pinecone. But before that, you have to collect one API key. So how to collect the API key? Left hand side, you can see one API key option is there. Just try to click here. For me, I already created one API key. If you don't have, just try to create an API key. Just give the name. Let's say I'll give test, or you can give any name. Let's create the API key. Okay, so this is the API key. Now just try to copy the API key, guys, and try to mention inside this .env file. So I'll open the .env file. So let me paste it here, and make sure you are giving one key name here. That means this is your Pinecone API key. Okay, that's it. And make sure you are writing this thing in a string. Got it? Now let me open up my trials.ipynb. Now what I will do, I'll just create a cluster here. So let me go back to the database, and don't share this key with anyone, guys. Otherwise they will be also able to access your account. Okay, I'll be removing it after this recording. So for you, no need to share with anyone. Now inside Pinecone, either you can manually create the index. Let's say you can click here, create index. Let's create one index. Let's say I want to create, let's say anything. You can give test. Now dimension, let's say 384. The same dimension I will give here. The dimension actually I'm getting. Cosine metrics, just keep it. You can also select different metrics, like what kinds of, let's say, similarity metrics it will apply whenever it will do the semantic search operation. I want to use cosine score. Now just keep it everything as default. You don't need to change the provider. See, AWS is the free one. If you're, let's say, sign up for the first time, you can create 1 to 2 cluster here with the help of AWS cloud provider. But if you want to take their premium subscription, that means if you want to create a multiple cluster, if you want to take some more space, you can see, if you're using free plan, you will get 2 GB storage here. But if you have more than 2 GB data, that time you have to take the premium subscription. Okay, that time actually what you have to do, you have to take their plan, subscription plan. Let's say if I take this one, Google Cloud. Now see the price plan. See, this is the price plan actually they have. So with respect to that, you can also purchase their let's say machine. Okay, but as of now, I'll be using the free services only. I don't need the, let's say, premium subscription of the Pinecone. But if you are creating the actual project, if you need more spaces, that time you can do it. So I'll be selecting the AWS cloud provider, and region, just keep it everything as default. Only just need to give the name. Okay, name and the dimension. That's it. 384. Okay, now let's create the index. So this is the manual approach to create the index, guys. Okay, this is the manual approach. See, this index is getting created. It is getting initialized. And once it is initialized, see, it would be connected. Okay, see, it is now connected. Okay, now if you want to connect it, you can execute this Python code and you can insert your data. All the code they have already given. Okay, but I don't want to create this index manually. I want to create through the Python code. So let me delete it. So if you want to delete it, just click here and try to delete the index. So you have to give the name. Okay, I'll be deleting because I will be creating through the Python code. And how to create through the Python code, guys? I think they have already given one starter code, remember? So here you can give the index name, like which index you want to create, and create index dimension you can give here, matrix, serverless, AWS region. Okay, everything you can pass here. So now let's use this approach to create the index. So what I'll do, I'll go back to my VS Code, and I already prepared this code for you. So let me show you. So this is the code. Only you just need to change the API key. So let me change the API key. The API key I have collected here. Let me copy and let me change it here. Or I think I can read it from the environment only. So what I can do, I can import the environment. Just a minute. So let's import. So from .env, import load env. Okay. Then I will load the env. Now simply I'll get this Pinecone API key from my environment, and here it will save inside this variable. Now this variable actually I'll pass here. Okay, so nobody won't be able to see my API key that time. So this is the best approach, guys. You can also follow. Now you can give the index name. Let's say I will give medical bot. Medical bot. Let's say this is my index name. And here you have to give the dimension. So make sure which embedding model you are using and what is the dimension size. 384. That means it's fine. 384. Keep everything as default cosine, serverless, AWS, US East 1. Okay, no need to change anything because we are using free cluster here. Fine. Now, once you will execute this code, okay, once you will execute this code, you will see that your index would be automatically created in the Pinecone. Let me show you. So if I execute this code now, see what will happen. So guys, execution is done. Now if I get back to my Pinecone and if I refresh it here, see, medical chatbot should be created here. Let me show you. See, medical chatbot is created. Automatically it has created. And now it is active and running. Okay. Now what I can do, I can convert our, let's say, chunks to the vector embedding, and I can store inside the Pinecone vector database. So for this, what I can do. So for this, first of all, set this Pinecone API key as your environment variable. Because whenever we'll be storing the, let's say, data to the Pinecone, so Pinecone internally looks for this API key inside the environment variable. Okay, so for this we are using operating system environ. Okay, environ, and this is the key name, guys, I've giving, and I'm setting my Pinecone API key. Okay, whatever API key I'm loading from my .env file, so it will set inside my environment variable right now. Okay, so whenever I'll execute my Pinecone code, I don't need to again and again pass it. Okay, again and again I don't need to pass it here. This is the advantage. Now see, to store the vector embedding, this is the code snippet you have to execute, guys. So you can see this is the code snippet. Let me comment here. Now I'm importing LangChain Pinecone import Pinecone vector store. Okay. Now inside Pinecone vector store, you have one function called from documents. So first of all, you have to give the documents. That means my text chunks. The text chunks I have created. Remember. So this is the text chunks I have created. Okay. So this text chunks you have to give. But then you have to give the index name. So what is the index name I have given, guys? I think remember this is the index name. That means this index name it is already created. That means inside this index it will store the data. Got it? So make sure you check this at the variable. Now I need to give the embedding model. So I think remember we downloaded one embedding model. Okay, from the HuggingFace app. Got it? So these three parameters you have to pass here. Now see, if I execute this line, it will convert all of my data to the vector embedding and will store to the Pinecone vector database. And how many chunks I got, guys? I think remember I got 7020 chunks. That means 7020 chunks vector would be stored inside my Pinecone. So it will take some time, guys. Let's wait. After executing this code, I'll pause the video, and once this vector will get stored in my Pinecone, I will come back again. See, let me show you. If I go to my Pinecone right now, and if you refresh the page here, see, all of the vector would be stored here. Even you can also see the count. Let me show you. See, as of now, 864, let's say, chunks has been added. Now see, 1000. Now see, you can also see the visualization of the vector. It's amazing, right? So whenever you used to use local vector DB, it was not possible to visualize our vector, but here it is possible. You can see. You can also see the score. That means semantic score. Like what is the score between this vector, and this vector? Got it? This is one amazing visualization, guys, you will get in the Pinecone. And see, this is the entire vector representation of this entire sentence. Okay, entire text. Okay, and even it is also showing the page number in which page it is extracting the data, and what is the PDF name as well. Okay, every information you can see here. Even you can also perform the query operation That means the way you perform the SQL query, you can also perform the query operation here manually. Everything is possible, but everything will be doing through the Python code. I'm not going to use the manual approach here. Now see the vector count, guys. So 4120 vector has been stored. Now let's wait. Once it has saved all of my vector, I'll come back and I'll show you. So guys, as you can see, my execution is completed. Now if I get back to my Pinecone and if I refresh, see all of the vector it has stored here, like more than 7,000 vector it has stored inside my Pinecone index. Okay, now what I can do, I can use this index as my knowledge base. That means we'll be connecting my large language model with this knowledge base, and we'll be asking the query and it will do the semantic search operation here. Okay, this is the idea. Now let's get back to my code editor. Now see, I already created the index and I already stored my vector there. Now I want to load my existing, okay, existing index. If you want to load the existing index, what you can do, you can use this code snippet. Okay, see, again I'm importing Pinecone vector store from LangChain Pinecone, and there is another function called from existing index. Okay, from existing index, you have to give the index name. So the index name, I've given the same index name, and you have to pass the embedding model. The embedding model you have downloaded. Now see, if you execute this line of code, it will load the index. That means whatever index you have created and all the vector, actually it will load and it will give you the doc source object. Okay, this is an object, doc source object. Now you can also perform the retrieve operation here. That means you can perform the similarity search operation here. Let me show you one example. There's a doc source as retriever, search type similarity, search keyword 3. That means it will give you 3 relevant answer. Let me show you. So if I initialize my retriever object, and now I will ask one question here. So this is my medical data. I will ask, let's say, what is acne? Okay, acne. So I think you know inside this PDF, I'm having acne related disease also. Let me show you. So if I press Ctrl F, acne. So guys, as you can see, this is the acne disease. What is acne and all? So you can see acne and acne related actually treatment, okay, medicine, they have suggested each and everything. So I'll asking one question here. So what is acne? So it should give me the relevant answer, okay, for the acne from my knowledge base. Now let me execute and let me show you. Now see, if I show you this retrieved docs, it will give you 3 results, actually 3 results. Even it is also showing the source, okay, from where it has referred. Now see, different actually acne related response it has given me, okay, because I have set search keyword is equal to 3, it will only give me 3 response, okay, but I don't need this kinds of output. I need a complete let's say definition, okay, what is acne. Got it? So for this, what I have to do, guys, I think you remember, I have to integrate my large language model. That means here we'll be working on, user will give the answer query, this query will go to knowledge base will give the rank results. I'll be using the large language model, so LLM will process this rank results as well as the query, and it will give me the correct response. Okay, so for this, let's initialize my model. So I already told you we'll be using OpenAI model. So OpenAI, so let's initialize my OpenAI model, and I think you already know what is temperature and max token. So it is giving me one error. Okay, it is giving me error because I haven't set my OpenAI API key. So let's set the OpenAI API key. I'll open up my environment. So here is my API key, guys. So make sure you create one API key and just try to paste here. And similar wise, I also need to set this API key as in my environment variable. Okay, so let me execute this code. So here what I can do, I can duplicate this line, and here I can write OpenAI API key. So it will also give me my OpenAI API key. Then here, whenever I'm setting as an environment, here I can also change OpenAI API key, OpenAI API key. Okay, now let's set this one. Okay, string expected none time. Okay, so I think I have to load it again, then I have to execute. Now it should work. Now it is working fine. Now if I get back here, now if I initialize it, it should work. See, successfully I have initialized my large language model. Now I have to create the complete chain. For this, let's import some library. Previously I showed you now how to create the RAG application. There I think you remember we were importing this library, create retrieval chain, create stub document chain, okay, create prompt chat prompt template, okay, everything I already showed you there. So we are importing the same code here. Now this is going to be my system prompt. So here I want to give this prompt in my language model. Okay, large language model. Now I'm going to create the complete prompt template. You can see this is the system prompt, and whatever input user will give, that means the input actually I have given, it will come here and it will give you the complete output. Now let me initialize. Now let's create my chain. So create stuff chain. Inside that you have to give the LLM as well as the prompt, and whatever object you will get inside create retrieval chain, you have to pass it as well as the retriever. That means your vector store. The vector store you created, okay, retriever object. Now let's initialize my chain. Now let's ask the question. So here I will give what is acne. Okay, what is acne? Sorry, acne. Now see the response, guys. See, acne is a common skin disease characterized by pimples on the face, chest, and back. It is caused by clogged pores and become inflamed due to the oil, dead skin cells, okay, and bacteria treatment and so on. See, that means it has given me the correct response. If you open the PDF now, this book right now, and if you read it here, you'll see that it has given me the correct response. Now see, if I giving any other question which is not relevant about the PDF, what will happen? See, now see, if I give any other, let's say question, let's say I have given what is stats, that means what is statistics, it is telling me I don't know, because here I have given the prompt now. See, if you're not getting the context, that means here this question I'm asking, this is out of context. That means the data I have given to my model, okay, the knowledge base I have given to my model, so this information is not available here. So that's why it is telling I don't know. Okay, so this is the complete custom system we have created, like custom chatbot we have created, which is only referring our custom data. Okay, I hope it is clear. So guys, this is the actually entire demo. Like that's how actually we'll be implementing the entire application. Now you can ask any kinds of question. Let me show you. So you can take any other disease. Let me show you. Or let's take any other disease. Okay, let's take this disease actually. This one. I'll copy and I'll come back here. Then I'll ask here. Now let's see. See, it is giving you the response. Growth hormones resulting the abnormal growth. Okay. See, that means this is the correct response actually I'm getting. Now if you see the image, so the same thing. Okay. So you can see this disease is a abnormal releases particular chemical from the so blah blah blah. Okay, so you can read it. So that means we are getting the correct response. Fine. Now let's try to convert this project as our end-to-end implementation right now. That means we'll be also implementing the UI, but before that I have to first of all create the modular coding. Okay, so what I'll do, guys, I will first of all open up my helper.py. Inside helper.py, whatever, let's say utility related code I have written, let's say loading the data, then creating the chunks, then loading the embedding model, all the function I will move inside this helper.py. So let me open. So inside that I'm going to import all of the library. See, I just copy pasted the code from my notebook only. If you open the notebook, the same code actually I'm copy pasting. And why it is giving the error? Because below you can see I have to select my environment, the correct environment. Let's say medical bot. Now this error will be disappeared. Now see, all the function I'll just copy paste here. All the three function I have written now. My load PDF, then this one text split, and this one my load embedding model. So here I kept all the function, you can see, because I want to import from here. So these are the function I don't want to create inside my endpoint. Otherwise my code base would be like messy, right? That's why I am creating inside this particular file. Now let me save, and inside prompt actually what I will do, I'll give the system prompt, whatever prompt actually I have written. So here is the prompt, guys. I think you remember. I'll copy the prompt, and inside prompt.py I'm going to mention it here. Okay, so from here I'm going to open the prompt. Let's say in future you want to change the prompt, you want to give any other prompt, you can open this prompt.py, you can change here, it will reflect in your code. Okay, no need to open your actual code implementation that time. Fine, so let me close this at the tab. As of now it's not required. Now yeah, so helper is fine. Now what I will do, I will create another file here and I will name it as store underscore index .py. Okay, .py. Why? Because let's say you want to update this book, let's say you want to add some more information. That time again you have to store all the embeddings to the knowledge base, that means inside your Pinecone, yes or no, right? And to store it, I again need to execute one like endpoint, that means store underscore index.py. Whenever you will execute it, it will load the new information and it will store to the vector database again. Fine. So for this, what I will do, I'll prepare this one. So see, whatever code I have written now here, that means I extracted my let's say documents, I created the chunks, downloaded the embedding model. After that, I pushed everything to my vector database. Okay, see all the let's say vector database code I have written, everything I need to write inside that one. So let me import all of the library. So you can see I'm importing from src helper, that means from src helper. So inside helper, I'm having three functions: load PDF, then text split, and download face embeddings. Okay, see I'm importing all of them. HuggingFace embedding. Okay, then I'm also importing Pinecone, then Pinecone vector store, then load env and operating system. First of all, I have to set my environment variable, that means my credential. Okay, OpenAI, sorry, Pinecone API credential. Then I will be loading my data, extracting the data, creating the chunks, then I'll be loading the embedding model. See, load file, that means I'm loading the data, so I have to give the data location. So this is my data location. Then text splitter will run, then download the embedding model. Okay, then after that I will initialize my Pinecone code base. The same code, guys, if you open the Jupyter notebook file, the same code. See, Pinecone initialization, it will create the medical chatbot. Okay, medical bot, that means this bot it will create. Okay, then it will actually create the index, then it will store the embeddings. Okay, so at the very first time you have to execute this line, guys. Okay, very first time you have to execute this file. Then whatever actually, let's say, data you are having, it will do the vector conversion, that means embedding conversion, then it will store to the vector database. Okay, now what I'll do, I'll just delete my previous embeddings, whatever I created. This cluster I want to delete it, because now I'm doing the modular coding now. So I'll be executing everything from my modular coding itself. Now let me remove it. Now see, it will delete it. After some time, you will see that it won't be visible here. Now see, make sure, guys, before launching your application, first of all, you need to execute this store index.py. Make sure this index should be created. Otherwise, you won't be able to do the query operation, right? So at the very first time, you have to execute this store index.py. Okay, then you will be launching your application, that means app.py. And this one you have to only execute one time, not multiple time. Multiple time when you will be executing, whenever you will update the data. Let's say you want to add any other data, one more PDF, that time you will be executing this file. Okay, otherwise just keep it as default. That's it. Now let me save. Now I think this is deleted. Now see, there is nothing. Now what I will do, let me show you how it will create everything. So I'll open up my terminal. Let me clear. Now let's execute this store index.py. Python store index.py. Now let's execute. See, again, it will perform all the operation, whatever things we have done in the Jupyter notebook. So let's wait. After some times, you will see that your index would be created, and inside index, all the vector would be stored. So guys, as you can see, my index is created. Now if I open it up, inside that, now it will store the embeddings. One by one, all the embeddings it will save. So guys, as you can see, my execution is completed and it has stored all of my vector. Now that means my this store index is working fine. I'm successfully able to store my vector. Now let's create the endpoint. Okay, that means my main application. So user will start this application right now. So here I already told you we will be using Flask. Okay, so here I already told you we'll be using Flask here. And if I'm using Flask, I need a HTML and CSS code to create the one beautiful user interface. So I already created one HTML and CSS code for you guys. If you don't, it's completely fine. Again, I'm telling you, there are so many templates you will get over the internet. There is a website called Bootstrap. Previously, I also told you, I think Bootstrap. Okay, Bootstrap website. So from here, you will get different example. Even you can also see different template it is having. Even if you search like Chatbot, HTML, CSS, free template. You will get different actually template. See, different template. You can also download the source code. Even see, code is also visible. You can also download. Even you will get some website. See, different chat template. Okay, different chat template. You can use it. Okay, it's up to you. Now, what I will do, I'll quickly just show you the HTML CSS code I have prepared for this. I think you know, if you are using Flask, you need to create one folder here called template. Okay, templates. So inside that, you have to create a file called index.html. Okay. Now let me show you my HTML code I have prepared. Or it's a chatbot. What I can do, I can name it as chat.html. Okay, chat.html. Now this is the entire HTML code, guys, I have prepared. Okay, save it. Now I need to create another folder for the CSS called static. So these are the requirement folder for the Flask. If you're using Flask inside Python, you need to create these other folder. Inside static, I'll be creating a file called style.css. Okay. Now let me also paste the CSS code I copied from the internet. Okay. So this is one basic template I created. Now, whenever I will show you my application, you will see the user interface, whatever the user interface I created. Now let me create my endpoint app.py. Now inside app.py, I'll be integrating all of the functionality I have prepared so far. So first of all, let me all the required package actually one by one. So here I'm using Flask. So I have imported Flask. From the Flask, I have imported all the required functionality, you can see. Then imported download HuggingFace embedding model. Okay, because I need the embedding object to load my vector store. I think you know that I need to load this, actually Pinecone index. So where is the Pinecone index? So here is the Pinecone index. So I need to load this index, and to load this index, what I need the, let's say this one, embedding object. I think remember at the last I showed you, loading existing index. Okay, I think you need it. Okay, I think remember. Fine. So that is why I have to import it. Then I'm importing, you can see Pinecone store, OpenAI, retrieval, QA. That means whatever, let's say I was loading here. These are the thing I'm loading everything. Fine. Then I also need to load my prompt. So prompt is available inside my prompt.py here. So I can import it. So simply I can import, just write prompt src dot prompt import start. That means I want to start everything inside that file. Okay, that's it. Then I also need something called operating system. So import OS. That's it. Now let me initialize my Flask. To initialize the Flask, you have to use this code. Go to the Flask documentation, you will get it. Now let's set all of my OpenAI and Pinecone environment. Okay. For this, I need to use the load in environment package. That's it. Then I will be downloading the embedding model. Then I will first of all initialize my embedding object. Then I will load my existing index from my Pinecone. So let me show you. See the same code from the notebook I copied. See, so I'm loading the existing index, medical bot. Make sure name is correct. Medical bot. Yeah, it's correct. Then it will give me the retriever object. Then I'm loading the OpenAI model. Then creating the prompt template. Then after that, I'm creating the chain. Okay. Now I have to create two routes exactly. First route would be my default route. That means user will get the interface of my application. Chat.html would be rendered. Got it? Now second route I'll be doing for the chat operation. That means user is giving any query to the chatbot. So that message actually I'll be accepting. And this message I will give to my LLM. Okay. That means you can see I'm doing the invoke operation. Okay. So same invoke operation I'm performing. Let me show you. So here is the invoke operation. Remember, okay, invoke. And whatever response I'm getting, I'm printing it as well as I'm showing in my that user interface. Okay, that's it. Now let me execute my application. So I'm running on my local host, port number 800, debug is equal to true. That means if you change anything, it will automatically update everything. So now let me show you my application. So let's open up my terminal. So I'll just execute Python app.py. Sorry, it should be Python. Spelling is not correct. Python. Okay, now it should be running. Now see, just give the allow permission. Now see, your application is running. Now let's open up our Google Chrome. Search for localhost port number 8080. See guys, this is the interface we have created. And this is one amazing interface, guys. You can see amazing chat template we have created. Because many people have requested me just try to create one front-end part of our application as well, beautiful front-end part, and that's how we can create a beautiful front-end part. Now here you can ask any kinds of question. Let's say I will ask the same question. I'll ask what is acne. The acne is a common skin disease by characteristic by pimples on the face. Fine. Then I will ask another question. Let's say I got fever. What should I do? See, now this is the response. If you are experiencing high fever, it is important to seek the medical attention. Okay, so tell me some medicine. Now see, it is also suggesting some medicine, okay, related fever. Now you can ask any kinds of question from the, let's say, PDF itself. Any kinds of disease you can ask. Let's say this is the disease I want to ask. I'll just copy, and here I'll just write what is this disease and all about. See, it has given me the response. Okay, now you can read this PDF, and you can see that you can ask the medicine, you can ask for the treatment, anything you can ask. So this is our chatbot, guys. This is our medical chatbot we have created, and see, it is also giving you the one beautiful user interface. Okay, it is also returning. Now what we'll do, we'll just try to also deploy this application, guys, but before that we'll be implementing some more end-to-end projects. Then after that I'll keep one dedicated end-to-end, let's say, deployment session. There I'll show you how we can deploy this at the project on the cloud platform. Okay, so yes guys, I hope you liked it, but before that what I will do, guys, I will commit this at the code in my GitHub. So you can also commit from the VS Code. Let's commit from here. I'll write updated. Let's commit. And .env file would be automatically ignored by the git ignore, okay, because inside git ignore you have already mentioned it. .git ignore would be ignored. See, .env would be ignored. Okay, so it won't be published inside my GitHub. Now if I open up my GitHub, now if I refresh, see, all the code has been updated. Now I can write the further code, let's say, step as well in the readme file. Okay, so I have added all the step. Like after that, what you have to do, after that you can set your environment key, then run store index, then app.py. Then you just need to open up your localhost. Okay, now let me commit the changes as well. So readme updated. And make sure, guys, you start this repository. All of you start this repository. You can also fork it so that you will have the reference. Okay, now if I refresh, now see, readme is updated, and you can see all this step I have also added. That's how you can also prepare your readme file, so that if other people is referring your, let's say, GitHub, they will be also able to set up this code, okay, in their system as well. Fine. So yes guys, this is the complete implementation. I hope you liked it. So that's how we can create any kinds of end-to-end generative AI bridge project. Fine. And no need to worry, I'll also show you the deployment. Even we will be also discussing about LLM ops. With the help of LLM ops also, we'll be learning how we can access any kinds of open source large language model. Okay, as a hosted open source large language model, we can use it. Hello everyone, welcome to the course. My name is Bapi Ahmed, and guys, in this video we'll be implementing another end-to-end project called source code analysis. So here we'll be using LangChain vector database large language model. Even I will also show you how we can create a front-end application of the entire projects. So this is going to be completely end-to-end implementation, guys. So I think in our previous video I already showed you one end-to-end implementation. We implemented one medical chatbot. So here we'll be following the same actually process to implement this project as well. Fine. And what is source code analysis? I'll tell you. I'll show you the entire architecture diagram of this project. Then I will start the implementation. So first of all, what I will show you, guys, I will show you the GitHub repository creation. After creating the GitHub repository, we'll be making all the setups. Then we'll start the implementation. So let's open up our GitHub and let's create one GitHub repository for this. So guys, as you can see, I'm inside my GitHub. So here I'm going to create a new repository, and I'm going to name it as end-to-end source code analysis generative AI. Fine. So let's keep it as public repository. I'll select the readme file, and I will also take the git ignore wise Python. Then let's take the license. I'll take MIT license. Now let's create the repository. So after that, I have to clone it. So I'll copy the link address. I will open up my local folder, and here I'm going to open up my git bash. Now let's write the command git clone and paste the link. That's it. See, it has cloned the repository. Okay, now I want to go inside this repository. I'll just write cd, that means change directory, to my end-to-end, okay, source code analysis. Now I'm inside this folder. Now inside this folder, let's open up our VS Code. So let me open up my VS Code. So here is my VS Code. So guys, I think you remember the first thing, we create a virtual environment, okay, for a new project. So let's create a virtual environment. For this, you need to follow some of the commands. So let me mention in the README file. So you can see these are the steps we have to follow. So first of all, if you're using my repository, first of all, clone it, then try to create an environment with the help of Python 3.10. So that environment name is LLM app. So for me, what I've done, guys, I already created the environment in my system. So I'll just activate the environment. But for you, if you don't have the environment, just try to create it. So let me show you my environment. I'll just write conda activate LLM app. See, it is already there for me. Okay. Now the next thing what I have to do, I have to set up the requirements of the projects. Okay. So for this, I'm going to create a file called requirement.txt. Inside that, I'm going to mention all the requirements actually I need. So you can see, guys, these are the requirement I need. I need OpenAI, TikTok, and ChromaDB. So vector DB wise, I'll be using ChromaDB. Previously, I used Pinecone. You can use any of the vector DB. It's up to you. Then LangChain, Flask. So the front end implementation wise, I'll be using Flask framework. Then Git Python. Why Git Python? I'll tell you. Whenever I'll show you the architecture diagram, this part would be clear. Then python.env just to manage my credential. Okay. And I'll be using OpenAI large language model. You can also use Gemini. You can also use open source large language model. But I told you, if you're using open source large language model, you should have good configuration machine. Okay, otherwise you won't be able to execute. And that part we'll be learning in the LLM ops, right? Now let me save everything and let me install all the requirements. So for this, you can execute this command. So let's copy the command and here I'm going to execute. See, for me, I already installed all the package. That's why it's telling requirement satisfied. But for you, it will take some time. Now, the next thing, what I do, guys, usually I create a template file. I think you remember project template file. So templates.py. Okay. And previously I shared one template code with you. I think you remember. So I'll just copy paste the same code. So if you missed out my previous implementation, guys, please try to check the end-to-end medical chatbot implementation. So there I already explained this code. Okay, this code, how we have written and all, everything I explain in detail. Okay, see, I'm using the same code, same actually template code. Now what will happen, this code will automatically create the template for me. So I already created requirement file. I don't need it. I'll remove it as of now. Okay, now everything is fine. So now if I execute this template.py file, see, it will create my folder structure. So let's see. See, it has created the folder structure. And whatever log actually you have written, it is showing in the terminal, you can see. Okay, so my folder structure is created. Now what I will do, I think you remember, first of all, we perform the notebook experiment. That means we'll be implementing the entire projects in our Jupyter notebook. Then we'll try to convert as our modular coding. Okay, so for this, I'm going to open the resource folder. Inside that, inside resource folder, I'm having one Jupyter notebook file called trials.ipynb. So here, first of all, let's select my kernel. So this is my environment. Okay. Now let's test whether it's working or not. So give okay message here. Yeah, so everything is working fine. Now, first of all, let me show you the project architecture diagram, like what we are gonna perform here. So guys, as you can see, this is the entire project architecture. So here we'll be basically performing question answer over the code base to understand how it works. See what happens actually whenever, let's say, we implement any kinds of project. Okay, let's say previously, I think you remember, we implemented one project called end-to-end medical chatbot. And this is the code base we have created, right? This is the entire repository of our project. Now, let's say if anyone new to this field, if actually he's not able to understand this project like how I have written, let's say this person will open this project. Let's say he will open this helper.py. And now he's not able to understand what is this function actually, download HuggingFace embedding. Or let's say, what is this function, load PDF file and all. Okay, let's say anything actually he's not able to understand about the project we have implemented. He's not able to understand the code we have created, right? So what actually this application can do, so if you give this GitHub repository link to our software, my software, what it will do, it will try to first of all extract all the code from the repository. Then it will create a knowledge base. Okay. And with the help of large language model, it will try to understand what you have written. Let's see, now if you're asking any kinds of question, let's say what is SRC? Inside SRC, let's say you are having helper.py. Now, let's say you are asking, let's say what is text split function, what it does. So this model will try to read this code and it will able to give the like answer. This function does this thing. And that is how actually it is working. Okay, that means it will give you the entire explanation of the code you have created. Okay, so this is called actually source code analysis. Okay, now I think you got it. What is the project actually we are implementing? So project name is source code analysis. So basically here we'll be performing question answer operation over the code base. Okay, to understand how this code works. Okay, And this is the entire diagram. You can see, guys, let's say you are having a source code. That means a complete GitHub repository. Okay, that means the complete, let's say, end-to-end implementation. So first of all, what you have to do, you have to first of all, let's say, extract all of the source code. Okay, then you will be creating actually chunk. Okay, different chunks. For this, actually, we'll be using something called context-aware splitting. Okay, now I think you can see here, we'll be using something called context-aware splitting. So here is the context-aware splitting, and how context-aware splitting works. So let's say this is your entire source code, and I think you know inside Python programming we use functional programming, OP programming concept, right? So let's say you have created different function. I think I told you I had created different function. Let's say this is one function. Let's say this is one example, def4. Let's say this is the function. Inside that you are having some code. Now after doing this context-aware splitting, what it will do, it will first of all extract all of the source code. Then it will create different chunks. Let's say inside this function you are having let's say 200 line of code. Okay, 200 line of code. Now let's see if your chunk size. Okay, chunk size. Let's say you have given or let's say I can write 20,000 lines of code. Okay, now let's see your chunk size you have defined 500. Okay, 500. That means what it will happen, 500. Okay, 500, let's say what that means 500 these kinds of actually tokens would be considered as your one chunks. Now just try to consider how many chunks it will create. It will create different chunks, obviously. Let's say this is the first chunks, this is the second chunks, this is the third chunks. Let's say it has created 3 chunks. Okay, 3 chunks it has created. Now how your model will try to understand whether these chunks, the entire chunks, so it is related to this particular function. Let's say there would be so many functions, there would be let's say thousands of functions, but how your model will understand these 3 chunks I got, this chunks is related this function, def4 function. So what context-aware splitting will do, it will automatically tag. So see, it is automatically tagging. So this is the chunks of def4 function. Okay, let's say you are having another function, let's say def test. Okay, this is the function. Inside that you have subcode. First of all, it will perform this splitting, that means chunking operation. You will get different chunk. Okay, then it will also perform the tagging operation. Let's say this is the tag of test function. That means your model will try to automatically understand now. Now your model will try to understand, okay, this chunks actually I'm getting, this is related to this particular function. Okay, so that's how actually it will understand the context. It will remember the context. Okay, this is called actually context-aware splitting. And this context-aware splitting we only perform whenever we are working with, let's say code. Okay, code data. Because previously we work with text data. Okay, text data is a different thing and code data is a different thing. That's why you have to follow this thing. Okay, now let me clear my screen. Now see what will happen. You have to create a vector store, yes or no. You can see after actually getting all the text, okay, all the chunks, you'll be using embedding model. With the embedding model, you'll be creating vector store, and here we'll be using something called ChromaDB. Okay, ChromaDB will be using. Okay, then this would be your knowledge base. Okay, and you'll be connecting your large language model. After that, whatever question actually user will ask. Okay, let's say this is the user. Whatever question user will ask, it will take this actually relevant answer as well as the question. It will try to understand. Based on that, actually it will give you the actual response. Okay, so this is the entire application we'll be creating. And again, you can see here we are implementing something called one RAG application, retrieval augmented generation. Okay, because here we are feeding our custom data wise we are using code data. Okay, our let's say source code we are using here. So I hope now it is clear. Now let's start the implementation, guys. So first of all, let's implement everything in our Jupyter notebook. Then we'll try to convert everything as our modular coding. Now let me clear my screen. Okay, so first of all, let's import all of the library I need. So here you can see I have imported all of the library actually I need in this implementation. Now the first library I'm importing called from Git import repo. So I think you remember we installed one package called Git Python. Okay, so what is Git Python? Git Python is nothing but this is the package like Git GitHub. Okay, this is the GitHub actually package inside Python. That means with the help of this package, you can clone any kinds of repository from the GitHub. Let's say the way actually cloned. I think you remember we open up our terminal, we just written one command git clone, then we pasted that link, right? We pasted our repository link. I think you remember. Okay, and it was able to clone this repository in my system. So now if I want to do with the help of Python programming, how we can do it? For this, we'll be using this package actually, Git Python. Okay, so with the help of that, we'll be easily cloning any kinds of repository from our GitHub. Because I told you now, user will upload one URL. Okay, that means GitHub URL, project URL, and from the URL actually it will automatically, let's say, clone the repository. Then it will extract the information, that means your code base. Then it will perform the chunking operation, embedding model, store the embedding in the knowledge base. Then it will connect the LLM. Okay, that's how we'll be performing the entire operation. Got it? And here I'm also importing another package called language, because here we'll be using programming language. So I'm going to use Python programming. So with the help of language, actually I'll try to use Python programming language here. Then generic loader, language parser, recursive character text splitter. Okay, so these are the actually additional package I'm also importing, and I'll tell you whenever I will be using them. I'll tell you each and everything. Okay, why I'm using it and what is the use of it. Now you can see I'm importing OpenAI embedding, because I'm going to use OpenAI embedding model. Then ChromaDB vector database, I already told you. Then we'll be creating our chain. Okay, the complete chain, and here we'll be using actually memory, conversation summary memory, because I think you remember in our LangChain series actually we learned how to create the memory. Okay, like it will remember your previous context. So with the help of this conversation summary memory, we can also create a memory buffer. Okay, so this thing actually we have imported so far. Now let me execute. Now see, it should work fine because we have installed everything. Now the next thing what I will do, guys, I'll just create a folder here. So mkdir. So this is the command to create a folder. I'll name it as test repo. Okay, test repo. Now see, if I show you my project working directory right now, so pwd project working directory, I'm inside resource folder. So inside resource folder, it will create a folder called, okay, mkdir is not recognized. Okay, so it should be mk. Okay, not mac. Now it should work. See, now in the test folder, it has created one folder called test repo. Inside test repo, I'm going to clone the repository. And to clone the repository, guys, you can use this code snippet. So here I'm using this one actually. I think you remember a repo. So the repo actually I have imported from Git. So inside that, you have one function called clone from. Now you have to mention the URL, like which repository you want to clone. Let's say I want to clone this medical chatbot repository. I've given the entire link. So this is the link I have given. Just copy the link and try to mention. Here you can give any kinds of URL, any kinds of GitHub URL you can mention here. That repository would be cloned. Then after that, you have to define the path. In which path you want to clone? I want to clone inside this particular path. Okay, this folder. Now see, if I execute, it will automatically clone this repository inside the test repo folder. Let me show you. Execution done. Now inside resource test repo, see, it has cloned all the source code. See, all the source code you can see it has already cloned. Okay, amazing. Now the next thing will be loading all the codes. Okay, all the, let's say, codes, all the data from this repository itself. Okay, all the Python file will be loading. That means we'll be extracting all the source code. For this, I'm going to use this code snippet. So here is the code snippet, guys. So here I'm using generic loader from file system. So I think remember we imported this generic loader from LangChain. Okay, generic. Now here I'm giving the repo path. That means where my repo is present. Then I'm giving the globe. That means it will open. That means it will extract all the Python file. Okay, .py file. Then parser. You have to mention the language. So here it is the Python language. Okay, that's why you have to give the Python language. And parser threshold, you just keep it this particular number 500. Okay, this is the default number. You can keep it. Now it will give me the loader object. Okay, now from the loader object, I will load the documents. Now see, it will give me the entire documents right now. If I show you, see, all the content is as extracted. Okay, now if you want to see them, now how many documents you got, you can check the length of documents. You'll see that 7 documents actually I got. Now if you want to see any kinds of specific, let's say, documents, you can print it. Now you can see this is the entire source code. You can see it as extracted, okay, from my repository itself. Now the next thing, guys, will be performing this context aware splitting. Okay, context aware splitting, I already told you, we'll be creating the chunks, and this particular chunks will tag with the function name. For this, we'll be using this this particular code snippet. Let me show you. This is the code snippet, guys. Recursive character text splitter you can use, and inside that you only need to mention one parameter called language is equal to language.python. So it will automatically perform the context aware splitting. That means it will tag the chunks with respect to the function. Got it? And chunk size and chunks overlap I have given. Now let me execute. Now I'll apply on top of my entire documents. Okay, document splitter, split documents. I'm passing my documents. Now it will give you the entire chunks. So let me show you. So this is the chunks I got. If you want to see the length, you can also see the length. Okay, see, this is the length of my chunks. Got it? Then next thing what I have to do, guys, I have to actually use the embedding model. Okay, to convert all my source code to the embedding representation, and I will be storing to my knowledge base, that means ChromaDB. For this, I will be using OpenAI embedding model, I think, remember. So let's set our OpenAI environment API key here. So this is my OpenAI API key. So I already created and I already set here. Now let me save. I'll go back to my notebook. Now, first of all, let's load this API key with the help of .env package. So here you can see I'm loading it. Then I will set this API key as an environment variable. Then I'm going to initialize my embedding model. Okay, OpenAI embedding model. That's it. Now let's initialize my ChromaDB. So I think you remember we imported already Chroma. from LangChain here. So Chroma we already imported. You can see vector store Chroma we imported. Now inside Chroma DB, we are passing our text. That means the chunks actually I created, and the embedding model as well as the parses directory. That means it will create a directory. That means database. Okay, so instead of data, you can give database. Okay, DB. Okay, DB. So it will create a database, like local database. Inside that, it will save all of your embeddings. And Chroma DB session I have already taken in the YouTube channel. You can check it out how Chroma DB works. Okay. Now let me create the vector store. Now see, DB has created. Okay, inside resource, and it is converting all the code to the embedding representation. And it is saving inside DB. Now see, it has created the local database. Okay, see. Okay. Now what I'll do, I'll just make it as, now to activate this vector DB, you have to execute this line, vector db.persist. Okay. Now I'll be initializing my large language model. So here you can use any kinds of large language model. You can also use GPT-4. I'll be using the default model like GPT 3.5 Turbo. So let's initialize my LLM. Then I'll be creating the memory. That means that history memory, conversation summary memory. You can see I'm importing this library. And inside that I'm passing my large language model. Then memory key is equal to chat history. That means it will remember my previous context. Okay. Then return message is equal to true. So this is going to be my memory object right now. Then I'll be creating my final chain. So for this you'll be using a conversation retrieval chain. Okay. Now inside that give the LLM retriever vector database. Okay. And as retriever, so search type I'm giving MMR. Keyword, it will give me 8 relevant answer. And here I've given the memory. Okay. Now this is going to be my key object right now. Now let's ask one question. So I'll prepare one question here. Question is equal to, let's say, I'll go to the test repo. Inside that I'm having src folder. Inside helper, I'm having one function. Let's say download HuggingFace embedding. I'll copy this function name. And here I will ask what is download HuggingFace embedding function. Okay. Let's see whether my model is able to explain or not. So this is my question. So this question I'm going to pass inside my keyword, that means my chain. Okay, and it will give me results, and I'm going to only extract the answer, okay, from the result itself. Now let's see. So guys, you can see I got the answer. The download HuggingFace embedding function downloads the embedding from the HuggingFace model. So this is the model actually. Okay, now see if I open it up, see it is correctly identified this model actually we are trying to download, and which returns embedding of 304 dimensions. These embeddings are used for the processing and analyze text data into context of the application. That means correct information. Okay, amazingly it has explained this function. Now you can give any other question. So what I will do, I'll copy this question and let's ask about this function right now. Let's say I'll ask about load PDF file. Okay, this function right now. Let's see what it will give me. So I'll copy the same code. And here I can mention, I think. Now let's see. So ignore this line. Okay, this line is not required. So this is your actual response. The load PDF function loads the PDF file from a specified directory using directory loader class, which is a filter of PDF files. And then it extracts the documents and return the items. Amazing, guys. So that's how you can perform the QA operation with your code base right now. If you don't understand any kinds of code, if you don't understand any kinds of function, just try to, give it here and try to ask it. So it will give you the entire explanation of your code base. Okay, this is called actually source code analysis. And this is one of the amazing project, guys. Amazing project. Got it? Now, this is the actually notebook experiment. Now let's try to convert this project out as our end-to-end implementation. Okay, so I'll just do the copy paste operation from my notebook only, because I think I showed you in my previous implementation, I did the same thing. So now what I will do, guys, I'll open up my src folder inside helper. So whatever, let's say, code I have written, okay, then let's say individually, I was loading the, I was cloning the GitHub, I was extracting the data, I was performing the embedding model operation. Okay, so everything I'll just write as a function inside helper.py. Okay, so now let's do it. This is how actually I implemented, guys. So I'm importing all of the necessary library. Then first of all, I created one function called repo ingestion. It will take the repo URL and it will do the ingestion operation. That means clone operation. The same thing we are doing in our notebook only. Got it? Then second function I have written called load repo. The same code, guys. That loader, generic loader I'm using here. See, it will take the repo path and it will load the, let's say, code, and it will give you the documents after extracting. Then the third function I've written called text splitter. That means it will perform the context aware splitting. Okay, the same thing. Then it will give you the embedding model. Okay, it will first of all get the embedding model from the OpenAI. It will return you. So instead of actually writing the scripting, I've just written as a function. That's it. Now the next thing what I will do, I'll add everything inside my endpoint, which is nothing but my app.py, because app.py user will execute and they will get one user interface, and from there actually they will upload, let's say they will give the URL, they will do the QA operation. Okay, so for this actually I already told you we'll be using Flask, and for the Flask actually you need one template and a static file, I think you remember. So let me show you. I already prepared one HTML and CSS code for you. So guys, as you can see, this is the template file, and inside that I'm having my index.html, and this is the HTML code. And again, I refer the internet bootstrap website to implement this actually HTML and CSS code. If you're not ever about, it's completely fine. You can use my template as it is. Okay. Now inside the static folder, I'm having the CSS, that means CSS code. Okay. That means style of our web interface and all. And to execute this style.css, I am using some JavaScript actually code. You can see this is the JavaScript code. Again, I got it from the bootstrap website. Now see how your application will look like. I'll tell you. Before that, let me write this app.py code. So inside app.py, I'm going to import all of the library I need. So you can see I'm imported all of the library like ChromaDB, load embeddings, okay, from the SRC helper, because I need the embedding model, right? Then repo ingestion, I'm also importing from the SRC. Then my chat OpenAI, okay, function, then conversation summary, okay, conversation retrieval chain. So everything you can see in the notebook, I'm importing all of them here. Now, first of all, what I have to do, I have to initialize my Flask, and I will set the OpenAI environment key as my environment variable here. That's it. Okay, see. Now, first of all, I will load my embeddings, okay, from my vector database. You can see I'm loading the embedding from my vector database. So for this, before that, what I have to do, I have to first of all generate the vector embedding. Let's say if user has given the URL, so it will generate the embedding, right? It will create the embeddings and it will save inside my vector database, yes or no. So for this, I'm going to create another file called store_index.py. So previously in the medical chatbot implementation, I written the same file, I think remember. Inside that, I was doing the actually embedding storing operation. See, so you can see repo ingestion, load URL. So I'm importing everything. I'm setting my OpenAPI key. Then load repo. That means see, user will give the URL. So this URL actually repo ingestion will load, and it will load the, let's say, documents. It will perform the text splitter embedding. Then this embedding will store inside my like ChromaDB. ChromaDB will create an like local database. Inside that it will save everything. Okay, I think you remember. Now here I've commented this two line because I will be doing this thing with the help of user interface. That means UI. Okay, not manually actually. So that means from the app.py user will give the URL. Okay, from the user interface web application user will give the URL. This URL I will receive here. Okay, I'll receive here. Then I will execute this line of code. Okay, so that's why I've commented this line. But if you want to test what you can do, you can uncomment it and you can execute this line. You will see that it will work fine. Okay, so as of now, I've just commented out. Now let me save it. Now I'll go back to my app.py. Now let's create the LLM chain. So this is the chain. The same code I've copy pasted from my notebook, guys. I'm creating the LLM, creating the memory. After that, I'm creating the QA chain. That's it. Then I'll be creating two route. Then I'm going to create a route actually from my Flask. So this is the default route. First of all, it will render the index.html whenever user will open the application. Okay. Then the second route I'll be creating for the repo ingestion. So whenever user will pass the URL of the GitHub and they will submit. So what will happen? It will execute this store index.py. You can see I'm executing this command python store index.py. And if you want to execute any Python file, that means if you want to execute any command, you have to use system voice.system. You can see I've imported operating system. So voice.system, and inside that just give the command, it will execute this file. That means what will happen? Whatever URL user will give. Okay. So first of all, it will perform the repo ingestion. I think you remember we created the repo ingestion function. Repo would be ingested in the repo folder. And if I go it back, now see. Now it will execute this store index.py file. That means this file. Now this code will be executed. That means it will load the repo, extract the documents, create the chunks, load the embedding model, then store all the embeddings to the knowledge base. That means inside my ChromaDB vector database. Okay. Now I think you got it. Now see, this is my second route. Now I'll be creating another last route. This is for the chat operation. That means after ingesting the data, creating the knowledge base, it will perform the chat operation. User will give the message. Okay. And if message is equal to clear, it will remove your let's say enter repository. That let's say you want to clone another repository, so your previous repository should be deleted. Okay, otherwise what will happen, it will take all I'm in this space, okay, in my system. That's why I'm removing it. I'm doing the you can say rm.rf operation. That means it will remove it. So this is a Linux command. That's why I'm executing inside was.system. Okay, then after that, whatever input user is giving, I'm getting the results, I'm rendering the answer. Okay, that's it. Now let's open up my application and let me show you. Now I think this part would be clear. So I'll open up my terminal. Now let's execute my app.py. So app.py will open. It's running now. Let's go back. Now just search for localhost port number 8080. Now see, this is the interface of your application. Okay, now here you have to give the URL. So let's say I will give this URL. I'll just give it here. Now see, I'll just send it. Now see, in the backend what will happen, it will ingest, that means it will clone this repository first of all. After that, it will create the embeddings and it will save this embedding in the vector database. Now see, internally everything is executing. If you go here, now see, repo, it is cloning, as well as DB would be also created. Now let's wait and let's try to see. So guys, as you can see, my execution is done. So if execution is done, you will see this message actually, response. Okay, response. So now if I open it up, now see, my repo has ingested and also my DB object is created. That means my embeddings has already stored here. Now I can perform the QA operation. For this, I'll be using this template right now. And this is the same actually chatbot template I'm using from my medical chatbot. Okay, now here you can give any kinds of question. Let's say I'll give what is. I'll ask the same question again. So I'll open the repo src helper. Let's say we'll ask this one, download HuggingFace. Like what is this function and all about? Function. Let's see. See, this is the answer I got. The download HuggingFace embedding function responsible for downloading the embedding model from the HuggingFace called sentence this model and specify return the 384 dimensional vector. Great. Now I'll ask another question. What is this function? Let's say text split. See, text split function. See, text split function purpose is to split the extracted data into smaller text chunks. These text chunks are useful for the processing and analyzing the text in a smaller, more manageable section. Great. That means it is giving you the correct response. Now you can ask any kinds of question regarding your source code. Okay. So this is the entire implementation, guys, of our project. Yeah. So I think you liked it, guys. And in the next video, we'll see the deployment, like how we can deploy these kinds of projects, okay, to the like cloud platform. So for this, actually, we'll be using AWS. So in AWS, I'll show you the deployment part. So before ending the session, first of all, let me commit the changes in my GitHub. So I don't want to push the repo. Let's say this repo I don't want to push. So what I can do, see, let me show you another thing. Let's say if I give clear message here, it will remove the repo folder automatically. See, repo folder would be deleted because you have written the code here. I think, remember, inside helper, not helper, I think inside app.py. See here, if you give the clear, it will remove the repo folder. Okay. Now if I click here, now see, then I also don't want to push this DB objects. What I can do in the git ignore, I can mention this DB. Let's say DB would be ignored. Inside everything, just try to ignore. Now let's try to see. DB is also. Okay, another actually repo I'm having inside resource. So let me also mention resource also. Inside resource, I'm having test repo. So everything I want to ignore, as well as I want to ignore the DB as well. Now I think, okay, research spelling is not correct, so it should be like that. Okay, research. Now let me save. Now see, it is ignoring everything. Okay, now let me push the changes. So I'll just write updated, commit, and seeing the changes. Now if I get back and refresh here, see, all the source code has been updated. Now let me write the further step you can perform. So here I have added the next step, like you have to create the environment file. Inside that, just set your OpenAI API key and just run app.py. and you can execute your project. Okay, that's it. Now let me also update this readme file. Readme updated. Now let's refresh here. Now see, everything is mentioned. Okay, all of the command I have shared with you.
Hello everyone, welcome back. My name is Bapi Hamed and I'm your host. So guys, in this video, we'll be exploring one new Python package called Chainlit. So before starting with our Chainlit discussion, first of all, I just wanted to tell you something like why we should use this Chainlit. And as a data scientist, actually, what are the difficulties actually we face whenever we try to develop any kinds of application, right? So I think you have used something called Streamlit to create your this kinds of web application. Even I have already showed you how we can create end-to-end like these kinds of generative AI projects with the help of Streamlit and all. See, whenever we are using Streamlit, it's a initial interface, right? Initial demo of your application. But nowadays actually this LLM comes and people are creating lots of application on top of these kinds of LLMs. And also like there are lots of application, there are lots of product in the market right now, like ChatGPT is there, Google Bard is there, right? Then Microsoft Bing Chat is also there. So if you have seen these kinds of product, these kinds of application, so you will see like this application has like very beautiful user interface, right? So whenever, let's say I'm creating any kinds of conversational agents, okay, let's say I'm creating any kind of chatbot, so we should have one like very beautiful user interface. Otherwise user might not get interest, okay, with your application. So that is the main thing actually. And Chainlit provides actually this kinds of beautiful user interface whenever you are trying to create any kinds of conversational agents and all. So we can use this Chainlit to build this kinds of LLM app super fast. Okay, I will tell you like why it is super fast, because you will see using very short line of code will be creating this kinds of application very easily, right? But if you're using Streamlit, I think you saw we need to write some more code there. Okay, but if you're using Chainlit, so like more code doesn't required here. So only using some line of code actually will be able to complete our entire projects. Okay, so this is a like very amazing package I was exploring, and I thought let's also show you this one. So that actually whenever you are learning these kinds of large language model, generative AI, so at the end you need to build some application, right? So you can use this kinds of Chainlit package with your application. And there is another reason actually you should use this Chainlit, you should explore this Chainlit. Let's say you are building some projects for your client, so you need to submit that projects to your client. So you need to submit some good you can say output from your side, otherwise your client might not get interest. So at that time, if you're using this kinds of Chainlit interface, okay, Chainlit package to create your apps and all, so it would be very much realistic and it would be very much amazing to your client whenever they will look into your application. So that is why actually whenever you are trying to build something, you have implemented any kinds of POC and all, so at that time just try to use this kinds of Chainlit package to create your apps, so that actually you can submit some good application to your client, okay, and they will be very much happy with you, right, with your work. So guys, this is the video agenda. So first of all, I will take you through the Chainlit documentation. Then I will show you like how we can use this Chainlit, and we'll be building one basic chatbot here. So I'm going to implement one food delivery chatbot. So basically it will asks for the order, okay, it will suggest you the food, then it will ask for the location, and it will take your order and all. So this kinds of chatbot actually will be implementing. I think you have seen like Zomato, right? So we'll be building some something like Zomato. You can build anything, but this is the project actually I prepared for you, so that actually you can learn something, right? So I just wanted to like make you this thing as realistic, so that whenever you are building your own projects, okay, you will get interest. So yes guys, this is all about. Now let's start with our Chainlit discussion. So guys, as you can see, this is the Chainlit documentation, and Chainlit is nothing but Chainlit is an open source Python package that makes incredibly fast to build ChatGPT like application with your own business logic and data. As you can see, if I open ChatGPT, so here you will see it has one beautiful user interface. Okay, that's why user are more interested to use this kinds of ChatGPT kinds of application. Now let's see, if you give any kinds of message, so it will take your message, even it will reply like that. Okay, so we'll be building something like that, so it would be like ChatGPT like interface, right? Then if you see here, it has also official tutorial, so you can also visit the tutorial they have given. So from there actually you can also learn. but I will make this video very simple so that actually you can understand each and everything. Like you don't need to go through even the documentation. I will discuss everything, whatever things actually you need to explore. Okay, and apart from that, anything is left and anything you want to explore from your side, you can visit the documentation and learn. Okay, yes guys, this is the documentation as you can see, and it has also integration with this kinds of LangChain, then AutoGen, LlamaIndex. Okay, you can either use OpenAI, either use LangChain, either use LlamaIndex, anything you can use. Okay, all the things has been integrated with that. So in this video, actually, I'm going to use OpenAI API. That means I'm going to use GPT 3.5 turbo model to create this application, because I just want to show you quickly. That's why I will be using this OpenAI model, because there actually I will get one API key and everything would be done for me, right? But you can also use open source large language model. I think I already taken some of the session, like how we can use Google PaLM to Llama, then we have Llama 2, then we have Falcon, we have Mistral 7B, anything you can use here. You can also integrate LangChain with that. I have already showed you like lots of things with the help of LangChain and all, so you can explore this thing, right? So yes guys, this is the documentation. Now here they have already given some starter code, like how we can start with this Chainlit and all. So I'll show you like how we can launch this Chainlit app and all. Okay, but before that, what I need to do, I'll be creating one GitHub repository. So here's my GitHub. So let me create one GitHub repository. I'll name it as LLM app with Chainlit. You can give any kinds of name. So let's keep it as public. I'll add readme file. Then git ignore wise, I'll be using Python, and license, you can take any kinds of license. So let's take MIT license. Then I will be creating my repository. Now let's clone this repository in my local machine. So I'll copy this link address and I will open my local machine, and here I'll open my terminal and just write git clone and paste this link and clone it. Okay, now I'll redirect to this folder, LLM apps with Chainlit. Now I am inside this folder. Now here I will launch my VS Code. So you can use any kinds of code editor. It's completely fine. So I already opened my VS Code. Now here I'll be creating some of the like folders and file. Then we'll be doing the environment setup, because I need to install some of the libraries, like let's say Chainlit I need to install, then I need to also install OpenAI and all. Okay, so let's do it and see like how we can use this kind of Chainlit. So here I'm going to create one folder called src, and then inside src I'm going to create one file called __init __dot.py. I think you already know why this constructor is needed, because I'm going to consider this src as my local package, because here I'm going to writing some of the Python file, and from that file I'll be importing some of the function and all. Okay, that's why I need to create it. I think I showed you in my end-to-end process, okay, what is the use of this. Then inside that actually I'm going to create two more file. One file I will keep my LLM model, and another file I will keep my system related configuration, or you can also talk about this prompt. Okay, you can also tell it as prompt. So prompt.py. Yeah, now outside I will create another file called app.py. Then I also need something called requirement.txt. So requirements.txt. Then I also need something called setup.py, because of this local package installation. Yeah, so this thing is required. Now let me just write down all the requirements actually I'm going to use. So the first requirement, actually I need something called Chainlit. So Chainlit, so this is the package you need to install. Then I need something called OpenAI. Then I need something called python.env. I think you know why we need this .env, because I'll be keeping my like OpenAI credential inside this .env file, and using this python.env I will read that. Yeah, then I also need something called -e space dot, because of this setup.py. Now let me create that file also, .env. So here I'm going to paste my OpenAI API key. So I already created this API key, so you can also create your own API key. Okay, don't use my one, I will just remove it after this recording. Then I need to install, these are the requirements. So for this I need to create one virtual environment. So I'll open my terminal, and here I'll just write conda create -n. Let's name it as chain, or I can give yeah, chainlit demo. This is the environment name. And Python version wise, I'll be using Python 3.9 and -y. Now let's activate my environment. Now I'll be installing the requirements. So just write pip install -r requirement.txt. Okay, it's giving error because we haven't added like setup.py code here. That is why it's throwing error. So I think you remember. So this code actually we usually add inside our setup.py. So this code is responsible to find this constructor file, and it will set up that folder as my local package. Okay, and here you can check the project name, version, author name, email address, and anything, right? Now let me install them. So now I'll again execute my requirement.txt. So it may take some time. Let's wait. I'll come back when it is done. So guys, as you can see, my installation is done now. Yeah, so everything is done. Now let me select the environment I created here. So it was chainlit demo. Yeah, that's it. Now first of all, let's test it whether everything is fine or not. So I'll close these are the file first of all. Yeah, so I'll visit this documentation again, this chainlit documentation, and if you click on in pure Python, so they have given one like code here. So let me just copy. So this code actually, this is the echo bot. Like if you send anything, so it will respond the same message, okay, as echo. So it's just for the testing purpose, like whether we are able to launch our chainlit app or not, and it is working fine or not. Okay, so first of all let me check it, everything is fine or not. Then I'll add my logic. I'll add my chatbot logic here. And here if you see, this code will remain same, and here you just need to write your logic. Okay, here we'll be writing our custom logic, and this code will remain same. Okay, and this is the echo bot currently. Now here what I need to do, I'll open my terminal, and if you visit the documentation, so they're telling first of all you need to write one command called chainlit init. Okay, first of all you need to initialize the chainlit here. So it will create one folder here called .chainlit, and inside that it will contain all the configuration. See, it has created this chainlit. Inside that it has created another toml file. This is the configuration file, and it has all the configuration. Okay, so here is the configuration. So you can change this GitHub URL and all. Okay, you can also change the project name here. So here is the project name, you can also change it. So these kinds of configuration you can change. So I'll just keep it as default, no issue with that. Then I'll again open my terminal. Again I will run one command called chainlit run app.py. Okay, now if I execute this command, so you will see it will launch one server for me, and this it is running on localhost port number 8000. So I'll give allow access, and this is the default user interface. Okay, so why this message is coming here, welcome to chainlit and all. So if you see here, it has created one md file here. Automatically it has created one .md file, like markdown file, and these are the content actually it has automatically generated. Okay, now let's see if I change anything here. So let's say I will change welcome to my bot. Okay, if I change anything here, now if I go to my app and refresh, see it has changed. That means if you want to, let's say, print any kinds of message, okay, whenever user will launch your application, okay, so you can customize here. So I already created this md file. I already made some customization there, because I told you I'm going to implement something called this one, Zomato bot. Okay, so for this actually I created some of the content related Zomato, and again I generated these are the content with the help of ChatGPT. Okay, so let me show you like what are things I have done. So here I'll just copy paste. See, this is the content I prepared. Hello, welcome to Zomato bot, and here I'm just showing some of the item like we have pizzas, then pasta, noodles, then Asian cuisines. Okay, so these are the thing actually I have generated with the help of ChatGPT. So here you can give anything, any message, whatever you feel good, you can give it here, and whatever application you are building with respect to that, just add the content here. Now if I go back to my application and refresh it, see guys, now it has changed to this content. Okay, now let's see if I give any kinds of message here, hi, so it will give me the same response like hi. Okay, now if I open my ChatGPT, and if you just compare with the ChatGPT, okay, now see it's looking like ChatGPT only, right? So that's why they're telling Chalice is nothing but it's a like a open source Python package, and with the help of that you can create ChatGPT like interface. Okay, ChatGPT like application. So I love this Chalice a lot because see, only using this line of code, okay, only using this line of code, like this only using just one function, we are able to launch this kinds of user interface. Now let's see if you're building any kinds of product for your client, so if you submit like that, so they will be pretty much impressed by your work. Okay, so that is why actually we should always use some good user interface whenever we are delivering our application, right? Now here you can give any message like I am Bappy, so it will give you the same response. Okay, because we have created the EcoBot. How it is working, so let me show you. So they have created one function, and this is the decorator they are using, this chain lead decorator. So this decorator is handling everything, and again they're using Async and await, because Async and await is helping us to read this message, okay, real time. So it is always sensing our input, and whenever we are giving something, it is receiving, and it is also sending the message to the front end, right? So this is the like code, simple code. Now here we'll be writing our custom logic. So basically we'll be building one Zomato bot with the help of this large language model. I'll be using like OpenAI GPT 3.5 Turbo, and here we'll be chatting with our bot, okay, with the help of this channel lead. And here if you see, your app name is Chatbot currently, so you can also change this name. So I told you there is a configuration it has generated. Now if you go below, so here is the option to change the name. So by default it is Chatbot, so you can also give something called Chatbot for Zomato. Okay, now if I refresh and again refresh here, I need to, I think, stop the execution. So I'll open my code. Now guys, see, this name has been changed, Chatbot for Zomato. Okay, now I can close the previous one, and again it's the EcoBot. Now guys, let's add our custom logic. So for this, first of all, I will prepare my LLM, that means large language model. So this is the file. So here, first of all, I'm going to import OpenAI. So I think you know OpenAI has been updated. Now it is latest version. So they have upgraded lots of things, and if you visit that documentation currently, so if I go to this OpenAI, openai.com, and if I log in, so this is the documentation. Now let's go to any kinds of task, and let's see how we need to import. See, this is the import, and we need to initialize this client object. Okay, but initially we just need to install import OpenAI. Okay, that's how we can do it. But now actually you need to import like that, from OpenAI import OpenAI. Okay, so this is the updated version of OpenAI, and if you see here, we need to upgrade it also. Okay, if you are using previous one, so you need to upgrade also. Okay, so this is the requirement you always need to follow. You always need to upgrade with the documentation, otherwise you might get some issue. Okay, so let's import OpenAI. So from OpenAI, import OpenAI. Okay, so I need to make one client object here, client OpenAI. Then here I will be initializing one function. I'll create one function, so I'll name this function as ask order. Okay, ask order. So this function will this is going to be like main function. So basically this function will give me the response whatever question actually user will ask. So it will take the masses. First of all, it will take the masses, then it will also take the model. So model wise I'll be using something called GPT 3.5 turbo, 3.5 turbo. So this is the model I'm going to use. You can use any kinds of model. You can use GPT-4, anything you can use here. I'll be using this model because this model charge would be a little bit less for me, so that's why. Then I will also take this temperature value. What is temperature? I think you know in LLM. Temperature is like how much randomness you want from your model. Okay, if you're giving it to 0, so that means it won't be giving any randomness. It won't be like more creative. It will give you auto, like always stick output. But if your setting is too close to 1, that means you're telling your model to take risk, and it will also generate some random output. Okay, so that's why this temperature parameter is important also. Now this is my function. Now here they have already given like how to initialize this one. If you see here, so we need to use something called client.chat completion.create. So let me copy this line. I'll copy this line. Then I will open my code, and here I will add it. Now inside that, I think you saw, first of all, it will take the model. Model is equal to model. Then it will also take something called masses. Okay, masses. So what is masses here? So let me show you. See, masses is nothing but it's kinds of prompt actually you are giving. Basically you are giving some like zero shot or few shot prompt here. Like you are telling this is the role. Okay, role means system means like you are the role. Okay, like you as a chatbot, this is your role system, and this is the content. So you are a helpful assistant. Okay, basically it is I'm telling to my bot you are a helpful assistant, and whenever user is giving some content, okay, let's say this is the content user has given, so you also need to reply as an assistant. Okay, as you can see, this should be your answer. So that means we are giving some prompt here. Okay, we are just giving some zero shot or few shot prompt here to my LLM, so that my LLM can understand what kinds of job actually I want to perform. Okay, so I think you already learned this prompt engineering and all. Okay, so this is very much important here. So let's also define this one. So I already prepared one prompt here, so let me show you. So you can also create your custom prompt. There is no issue with that. So in this prompt.py, I'll paste it out. So this is going to be like very creative. The more good prompt you actually will give to your LLM, the more good results actually will get. Okay, so this is the prompt actually I've developed. So system instruction, as you can see, you are a Zomato bot, and automated service to collect other orders from online restaurant. Okay, if you see here, so many like content I have written here. Like, so here I'm just trying to making my bot understand like what it is going to do exactly. And these are the actually item I also like pasted here. So if anyone is asking like for the menu, so it should return something, right? So these are the actually prompt I have developed from my side. Okay, so this prompt actually I'm going to use. Now I think you remember you need to create one format. As you can see, role as system assistant. So that's kinds of format actually you need. So for this actually I already prepared. So this is going to be the format. As you can see, message, role, system, content, and system instruction I need to import from my prompt. So here I'll just write from src dot I have LLMs. Oh no, sorry, src dot prompt. Then I need to import something called system instruction. Okay, so here is my system instruction. I'm importing this one. Now here I'm just telling role, system, and content. Okay, so here I'm giving the prompt to my LLM. As you can see, now this message actually I will give it here. Okay, yes. Now I also need to set the temperature. So temperature is equal to temperature. Okay, now this will also return something. As you can see, if you go below, so this is the response format. It will give you this kinds of format as a response. It's a JSON format response. So from here actually I will need to collect this content. Okay, if you see here, I need to collect this content. Okay, content is the response. Okay, actual response, and these are some parameter it will also give you. So if you want to like extract the content, so you can copy this. Either you can also copy this one. You can also copy this one. Okay, this one also you can copy. So let me copy this one and I'll open my bot again, and here I'll just write return response.choice message.content. I only need the content. Okay. So this is my function I have developed. So it should be messages instead of messages. Yeah, now it's fine. So now I will write my final logic. So I'll open my app.py. So here, first of all, I need to import my this function ask order. So let me import. So from src.llm import ask order. Then I also need to import something called messages. Okay. Because here, if you see, we have also created this messages. I also need this one here. Let me save it. Then if I show you now here, if you see here, whenever I was discussing this thing, so you need to prepare this message. Okay, we have created for the system. Okay, system, that means we have given the prompt. Now I also need to create for the user. Okay, like whatever input user will give. Okay, so for this, in this list, actually, if I show you, we have a message. Okay, this is the list actually, and inside that we have a dictionary. So I need to add some more, like you can say I mean messages, as you can see, one by one. So this is for the system. Then I also need to add for the user as well. Okay, so I need to just append it. So for this, what I need to do, so I'll open my app.py, and here you can append like that. So I'll just write message.append, and here I'm just initializing my user right now, role. This is user, and this is the content. What is the content user will give? The message. Okay, the message actually will send. Okay, the message actually will send from here. So this is going to be the content. So it will store here. Okay, it will store it here. That means in this list, because we are doing the append operation, right? So once it is done, I also need to give this message. Okay, I also need to give this message to my bot. So I'll just write ask order. Inside that, it will take the messages. Okay, then it will also give me something called response. It will give it will give me something called response. Okay, now if you see here, I also need to provide the response here. If I show you, I also need to give the assistant response as well. Okay, as you can see, assistant response as well. So again, I will append. So whenever I will receive the response, okay, I will extract the content. So as an assistant, actually, it will give me some response. So this response actually I am appending, because if I show you here, this response should be my content. Okay, as you can see, it is returning the content, and that content actually I am storing. Now once it is done, now I also need to send the response to my this chainlit user interface, right? So to do it, actually, if you see, by default it is sending the like echo command only. The message user is giving the same message actually it is sending. So instead of that, actually, I just need to send my response. Okay, this is the response. Actually, I need to send to my front end. Done. Yes, so this is the logic only. So this is a like very easy code we have written. Now here you can also integrate your open source LLM. You can use PAM2, you can use Llama. Okay, you can also use Falcon, anything you can use. I think I already showed you how to use them. And you can also integrate LangChain with that. Okay, so if you're using open source LLM, so you can also use LangChain. Okay, with the help of LangChain, you can also do it. And the same thing, you can do the return here. Okay, as a response. Now let's test it whether it's working or not. So I'll go back to my chain lead. Then I will refresh. Yeah. Now let's say if I give any message, let's say hi. So it is received hi, because I need to, I think, restart it. So I'll open my terminal, and I will close the execution. If you press Ctrl C, it will close. Now let's restart again. So I have restarted. Now here is my new one. Now let's see if I give any message hi. See, it's giving hello, welcome to Zomato, how I can assist you. So here I can give my name is Bappi, uh, and I am looking for something. I'm looking something for dinner. I'm looking something for dinner. Okay, now it is telling, hi Bappy, I'm here to help you find something delicious for dinner. What type of cuisines you are in mood for? We have options like pizza, pasta, then Asian cuisines, then beverages and Indian cuisines. Let me know your preferred. So I will go for Indian food. Okay, now see, it is giving great choice, Bappy. Indian cuisine is always a treat, and here is some option for the Indian menu. Now it is telling butter chicken we have with naan, and even it is also giving the cost because we have added the prompt here. I think you remember. Then tikka masala rice, then palak paneer, then chana masala, vegetable biryani, samosa, lachi. So I'll give. I need this one, chicken tikka masala with rice. Okay, so I'll just write add chicken tikka masala rice in the cart. Yeah. So I have added chicken tikka masala in the cart. Is there anything else would you like to order, or this is all for you? Uh, no, it's fine. Okay, all right. Here is the summary of your order. So chicken tikka masala. Now, if you see, this is the price. Now it is telling, is that correct? And would you like to pick up your order or have it delivered? So I'll tell have it delivered. Delivered. Great. We have will deliver your order to you. Could you please provide me your delivery address? So I'll give some address here. So I'll tell my address. My address is this is my address. Let's give this address. Okay. So thanks for providing your address, Bappy. Your order will be delivered to 17th floor, Brigade Signature Tower. The total amount for your order $10.99. How would you like to make the payment? We accept cash on delivery or online payment. I'll go for cash on delivery. Cash on delivery. Perfect. You can pay in cash when the delivery. Thank for the placing your order. Bappy, your chicken tikka masala with rice will be delivered shortly. If you have any other questions or need further assistance, feel free to ask. Enjoy your meal. Uh, Great. Thank you. Okay. See guys, we have implemented one amazing food delivery bot with the help of this chain lead, and now see the interface guys. It's like very professional, very amazing, right? Very amazing. Now if you deliver this project to someone else, they will be going mad, right? Like whatever things actually you have developed, right? Now what I will do quickly, I will just quickly commit the changes to my GitHub so that else you can get the code. So I'll just write completed commit. Done. Now if I go back to my GitHub and refresh, yeah, so you have committed. So yes guys, this was the demo of the Chainlit. I think you enjoyed this package a lot, and even I'm also enjoying this package a lot. Okay, I'm just trying to use this Chainlit package to build my LLM apps and all. And see guys, like by using some like very less line of code, actually we are able to build this kinds of awesome application, and it's like very fast, right?
Hi everyone, welcome back with another video of our generative AI series. So guys, in this video we'll be doing the deployment. That means whatever project actually we have implemented so far. Now we'll try to see the deployment part, like how we can deploy these kinds of projects on the cloud platform. So I think you already know we implemented so many end-to-end projects, right? So implemented medical chatbot, then source code analysis. Then we also implemented something called Zomato chatbot, right? So different application we implemented so far. Now in this video, I'll show you how we can deploy these kinds of application on the cloud platform. That means here we'll be deploying our application on the AWS cloud. If you want to learn any other cloud deployment, it is also fine. See, the process will remain same, only the cloud functionality would be different. So I'll try to create some more video on the deployment. Like I'll also show you how we can deploy these kinds of project on the GCP cloud, on the, let's say, the Azure cloud. But first of all, let's try to see how we can deploy this project on the AWS cloud. And see, this is not going to be a simple deployment. So here we'll be doing continuous integration and continuous delivery or deployment. That means CI/CD. So I think you have heard of this particular term called CI/CD, right? So we'll be learning how we can deploy this project as a CI/CD. I think you already know how to deploy any machine learning project, deep learning project as CI/CD, but we haven't seen how we can deploy any kinds of generative AI based project as a CI/CD, right? So that's why make sure you are watching this video till the end. So here I'm going to show you each and every step you have to follow. And trust me, if you follow this step, guys, you can use this step to deploy any kinds of, let's say, generative AI based project. Okay, and this is going to be production grade deployment. Okay, so here I'm going to use different kinds of service from the AWS. Even I'll be also using Docker. That means first of all, we'll be Dockerizing the entire source code. Then we'll be deploying this application on the cloud platform. Okay, so make sure you are watching this video till the end. So before starting the deployment, guys, first of all, let me show you what exactly we're gonna perform here. What is CI/CD exactly? Then I will also discuss, let's say, what are the tools and technology we'll be using here, what are the services we'll be using here. Then I will start with the deployment, and make sure you have the AWS account. If you don't have the AWS account, guys, so you won't be able to deploy this project. So first of all, try to create one account. If you're creating for the first time, you will get $300 free credit. Okay, and this is enough for you. So try to create an account, guys. Then you can start with the deployment with me. So let's open up our Blackboard and try to see the architecture overview. So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery, or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. Let's say local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this is actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud manually. You just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user can access your application. Now let's say after 4 months, or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. The medical chatbot we implemented, I think you remember, right? Let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application. Then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again, you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time. Then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application. Then you will be uploading your updated code. Then this code will reflect to the endpoint. Then user will be able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours. It took 3 hours to change the entire source code. That means change the entire features, okay, of your application. So what will happen? 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application. Yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other, let's say, software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they're able to make the changes in their application. How? Because they are following something called CI/CD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they're pushing their source code, they're pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is collected CI/CD. That means you are not going to deploy this application manual. Instead of that, what you have to do, you have to follow the CI/CD. That means what will happen? Let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically let's say deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue actually they won't be feeling. Got it? So this is what actually we have to do. That means we'll be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we'll be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing. Now whenever we'll let's say push our code to the GitHub, GitHub will automatically trigger. How it will trigger? For this you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually 3 famous tools actually we are having in the market right now. So people are using more this GitHub Action, because GitHub Action you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay, so here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can let's say use Jenkins, Circle CI. These are the services as well. Fine. So yes guys, this is the complete high level architecture of our deployment. Now let's discuss what are the services actually we'll be using for the deployment. See, here the first services actually I'm going to use called Docker. So I think you already know Docker. So Docker is a containerization service. So with the help of that, you can containerize your code. That means, let's say you are having a source code, you can perform the containerization. That means it will create a Docker image for you. Okay, so this image you can let's say keep anywhere. Let's say you can keep in the Docker Hub, you can keep, let's say, in the ECR, that means Elastic Container Registry. From there you can pull the image and you can execute this image. Okay, so if you are using Docker, so you won't be getting any kinds of setup issue. This is the main advantage here. Then we'll be using something called ECR here. ECR means Elastic Container Registry. So this is the service from the AWS. Okay, AWS giving the service. So here you can store any kinds of Docker image. It is the same like your Docker Hub. Okay, but it is the service from the AWS. You can store the private image there, but in Docker Hub actually all the image would be public. This is the difference only. Now we'll be using another service called EC2. Okay, EC2 is a virtual machine service from the AWS. Again, it is from the AWS. Okay, so this will give you virtual machine. There you can buy, let's say, CPU based machine, GPU based machine. Okay, so all kinds of configuration would be there. So here we are using a local computer. So there we'll be getting a cloud computer. Okay, this is the difference only. Then as a CI/CD tool, I'll be using something called GitHub Action, as I already told you. Okay, we'll be using GitHub Action for the CI/CD management. Fine. So yes guys, these are the services as of now I'm going to use. So let me show you the deployment step we'll be following. For this, what I have done guys, I think you remember we implemented one medical chatbot. This is the code, and this code would be also available in your resources section. Even you will also get this code in my GitHub. So guys, this is my GitHub profile. Just search ENT-Bappi in the Google, you will see my GitHub, and here I have created one repository called end-to-end medical chatbot. So I'm going to commit this code here, so you will get all the source code from this repository itself. Okay, and even I will also add the deployment step in the README file. So that is what actually I have written. You can see the entire deployment step I have written here. Now this is the CI/CD deployment we'll be following. So first of all, what I have to do, we have to let's say create a IAM user. Then we'll be creating the EC2 machine ECR. Okay, then we'll be, see, this is the deployment step as of now. Just try to follow the step I'm going to show you. First of all, we'll be building our So here, first of all, we'll be building the Docker image of our source code. That means Docker image will be implementing. Then we'll be pushing this Docker image to the ECR. That means Elastic Container Registry to store my Docker image. Then we'll be pulling this image from ECR in the EC2. That means we'll be pulling that image in the EC2 machine in our virtual computer. Then we'll be launching this Docker image in my EC2 machine. And from there, we'll be creating an endpoint. And that endpoint user will be able to access. Okay. And these are the policy I have to give whenever I will be creating the IAM user. Fine. So this is the entire step, guys, I have written. Even I've also given all the command you need to execute here. Now let's start the deployment, guys. But before that, you just need to prepare some of the files. The first file you have to prepare the Docker file. So this file will help you to containerize entire your application. That means it will perform the Dockerization. And these are the Docker command you have to write. So I think you remember we are using Python 3.10. Okay, this Python version. That's why I have taken Python 3.10 Slim Bastard image. Then working directory, it will create a working directory called app. Inside that, it will copy all the source code. Then it will install the requirements. Okay, whatever requirements actually we are having here. Got it? Then it will execute this Python 3 app.py command. So that means my endpoint would be executed. Okay, my application would be running. And make sure before actually deployment, you just store your index. Okay, in the Pinecone. So this is the Pinecone, guys. It is running, and all the vector is already stored here. You can see 7020 actually record is already stored here. So I already executed this file. I think remember store index. So it will create all the, let's say, vector embedding, and it will store in the Pinecone. Okay, Pinecone vector database. So in this project, I was using Pinecone. I think remember. Okay, so this should be available here. Got it? So once it is available, now what I have to do, guys, then you can create another file called Docker ignore. Inside Docker ignore, you can mention like some of the file which is not required. Let's say here this file is not required. Let's say I think this file is not required. Generative AI project.egginfo. Okay, so whenever it will perform the, let's say, containerization, that means Dockerization. So I don't need this folder. That time what you can do, you can mention this folder name in the Docker ignore file. It is the same thing as your git ignore. So it is already mentioned inside my git ignore. That's why I haven't mentioned inside my Docker ignore. Docker ignore is completely empty. As of now, I need all the file. That's why I haven't keep anything here. Now let's see, if you want to ignore any kinds of file which is not required, that time you can store these other file inside Docker ignore. Okay, that's the thing. Now the next things you have to create. You have to create one folder called .github. Okay, inside that you have to create one folder called workflows. Inside that you have to create one YAML file. You can give any name. Here I have given cic.yaml. Okay, now see, this is the complete YAML file. So this YAML file will help me to do the CI/CD deployment. Okay, that means here it will be using something called GitHub action. Okay, and GitHub action need this YAML file. So here all the command is already written. So first of all, you will see that it will perform continuous integration. Inside continuous integration, it will authenticate with my AWS account. Okay, then it will log in with my ECR. Then whatever, let's say, Docker image actually will be building, you will push that image to the ECR. Okay, that means Elastic Container Registry. Then your continuous deployment will start. Again, it will authenticate with AWS account. Then it will pull that, let's say, image from your ECR to EC2 machine. Then it will execute it here. And here all the environment variable I have set. You can see -e means this is the environment variable. See, AWS access key, AWS secret key. I'll tell you how to generate. These are the key. Then a Pinecone API key, OpenAI API key, everything I have set here. Okay, so these are the thing we'll be reading from the secret. Okay, GitHub secret. I'll tell you how to create the GitHub secret as well. So as of now, just try to remember this is the YAML file you have to use for the CI/CD. And this YAML file you can use as it is. No need to change anything in your other project as well. Okay, that's the thing. Now let's open up our AWS account. So guys, this is my AWS account. I already logged in with my AWS account. So here, so first of all, what you have to do, you have to create a IAM user. So let's create a IAM user. So IAM. So the first thing, we'll be creating one user here. So let's create one user. I'll create a user. So let's say username is, I'll give medical bot. You can give any name, it's up to you. So let's click on next. Now you have to give policies. Okay, like what are the policy you want to give in this user? I don't want to give my entire policy. That means all the services I don't want to give the access. So I'll be giving some specific access. So access wise, I already written in the readme file. Let me show you. So these are the access I'll be providing. My EC2 container registry full access and EC2 full access. Okay, these are the thing we'll be giving. So here just search it. So this is the ECR. Okay, ECR Elastic Container Registry full service here I'm giving. So let's select. And after that, again, I can delete it. Then I'll try to copy the next service. This is the service. Okay, this is the EC2 machine service. So again, search here and select the EC2 machine and click on the next. Now you'll see that I have given this two service. Okay. Next thing, just create the user. So right hand side, you can see one button is there, create user. Just click on create user. So guys, as you can see, my user has created. Now I'll click on the user. Then here you will get one option, security credential. Just click here. Then you have to create a access key. So click on create access key, select command line interface, and I understand this above recommendation, and click on the next. So there is a next button, just click on the next. Now create the access key here. Now see guys, this is your access key and secret access key. Try to download as a CSV file. So let's download. So and just keep it with you. Okay, this thing I need later on. Okay, and no need to share this key with anyone, otherwise they will also access your AWS account. Okay, so here I'm showing because after the recording I'll delete everything. Got it? So my IAM creation is done. Now I'll go back to the home page. Now the next thing what I have to do, guys, I have to create a ECR repository to store my Docker image. So let's search for ECR. So just search for ECR, that means Elastic Container Registry. Just open it up and make sure you check your region, in which region you are working. See, I'm working in Mumbai, AP South 1. If you're in other region, just try to note it down. Okay, you have to note it down, this syntax actually, AP South 1, then CS Central 1. If you're, let's say, in North Virginia, you have to give US East 1. So just try to remember these are the tag. Okay, so I'm inside Mumbai, that means AP South 1. Now I'll be creating a Elastic Container Registry. So let's create, so let's click there. Now you have to give the name. Let's say I'll give medical chatbot. You can give any name, it's up to you. Everything keep it as default. Now click on next. Now see, my repo is created. Now what you have to do, just copy the URI and just try to paste it as of now here, because this thing I need later on. Just for reference, I'm saving it here. Okay. That's it. Now what I will do, I will go back again. Now the next thing I have to do, I have to create my EC2 machine. Then I have to set up, these are the requirements. Okay, that means I have to set up the Docker there. Then I will be also updating that machine. So let's create my EC2 machine right now. So search for EC2 here. EC2 instance. So this is the EC2 service. Now launch the instance. Now select the Ubuntu machine. And what you have to do, give the name of the machine. Let's say medical bot machine. You can give anything. Then see, instance type, you have to take at least 8 GB RAM. 8 GB RAM, just take 8 GB RAM. I'll be taking T2 large. Okay, this machine. And then select the key value pair. If you don't have the key value pair, you can also create it. So let's say I'll give medical. So it will create one RSA file. So guys, you can see after creating and download, it will give you one PEM file. So this PEM file you can use. Let's say if you're using any third-party tool to connect with your EC2 machine, let's say PuTTY or Mobile Extreme, that time you can use this PEM file. But I'm going to launch my, let's say, machine in my second tab with the help of AWS only. I don't need this PEM file. Okay. So now I'll select these two options, HTTPS and HTTP. Keep it everything as default. Configuration storage at least take, let's say, 30 GB. And launch the instance right now. So here you can see, click on view all instance. Then see, my machine is running. So if status is running, now click on the machine ID. Now here you have to connect this machine. So click on the connect button. Now I'll be selecting the EC2 connector and let's connect the machine. So it will create a new tab for me. So here I will get one terminal, black terminal. So we have to use this terminal to set up everything here. And this is the production server, guys. Okay, that's how your production server looks like. See, this is the production server. Let me zoom. Now let me clear. See, here you won't be getting any kinds of UI interface. Okay, that means the way we are using our computer, it is having UI. But in the production server, you won't be getting any kinds of UI. You have to work with the terminal always. And this is the Linux terminal I got. This is the Linux machine, guys. So that's why if you know any kinds of Linux command, it will help you a lot. Got it? So here, first of all, I have to update this machine. For this, you have to execute these at the command one by one. So let's copy all the command one by one. Okay, so this is done. Now I'll copy the next command and just try to paste here. Now give yes permission and press enter. Okay, so execution is completed. Now I have to set up the Docker in the EC2 machine. So this is the command you have to run. Copy the next one and execute. Then I will execute this one, then the last command. So we have to add the Docker in the sudo group. Okay. Now if it is running or not, so what you can do, you can execute one command, docker ---- version. So if it is showing the version, that means Docker is installed successfully. Now we have to set up our self-hosted runner. EC2 as our self-hosted runner. That means we have to connect our GitHub. Okay, you can see this is the GitHub. Now this is our project GitHub. So this GitHub I have to connect with my AWS. That means whenever user will, whenever let's say developer will push the code in the GitHub, it will automatically get updated to the AWS. Okay, AWS cloud. So for this, what I have to do, I have to go to my project. Make sure you committed your repository in your GitHub and go to the settings. Okay, go to the settings. Now here, left hand side, you will see one option called action. Just click on the action, click on the runners. Now create a new self-hosted runner. Now select the Linux machine and you have to execute. These are the commands. So let's copy this command one by one and let me execute here. So it will automatically make the connection with your GitHub. Let me show you. Then the third command. Then fourth command. Now you have to go to the configuration section and copy this command and execute it here. Now see GitHub action, it will automatically connect. Now it will see it has connected to the GitHub. Now it is asking for enter the name of the runner group. I don't want to give anything, press enter. Now it is asking enter the name of the runner. So here you have to give self-hosted. Okay, self-hosted. This is the thing you have to give. If you're giving another thing, it won't be working. Okay, make sure you're giving self-hosted. Now let's press enter. Now keep it everything default, just press enter again. Then again press enter. Now see, it is done. Now the last command we have to execute this one. And you can ignore this one, it is not required. Now see, it would be connected with my GitHub. See, connected to the GitHub, listening for the jobs. Okay. Now if I show you, if I come back and now if I go to the runners, let's say, I'll go to the runners. Now see, status should be idle. You can see it is connected. Okay. Now the next thing what I have to do, I have to set up all the GitHub secrets. Okay. Now let's go back to the secret. So secret variable, click on the action. Now new repository secret. Now give the secret ID. Okay. So for the first ID I have to give AWS access key ID. Just copy and give the key name here. And why we will get the value? I think remember we downloaded one CSV file. So let me open this CSV file. I will open in a Notepad++, and this is my AWS access key ID. I'll copy, and here let me paste it. Then the next one I have to give secret access key ID, copy, and create another new repository secret and give it here. And in the CSV file, you will get the next one. See, it is comma separated. So before the comma, this is the AWS key ID, access key ID, and after the comma, this is the secret access key ID. So let me copy the secret access key ID and I will paste it here. Okay, now the next thing you have to give AWS default region. So region, I already told you I'm inside Mumbai. That means AP South 1. So I think remember I'm inside AP South 1. See, AP South 1, you have to write it. So let's write AP-South. Okay, -1, AP South 1. Let's try to check AP South 1. AP South 1. Okay, fine. Now let me add it. Now the next thing I have to add my ECR repo. So ECR repo wise, I think you remember we copied one URL. So just try to get this name only. Okay, after .com, just try to get the name and try to mention here. Then the next thing I have to set my Pinecone API key. So let's copy and add it here. And I think you remember in my .env file, I had my Pinecone API key. Let's copy. And this is not available inside my GitHub. That's why I'm reading from the GitHub secret. Okay, this is the idea. Now I also need to add my OpenAI secret. Okay, that means OpenAI API key. The last one you can see OpenAI API key. Let's add it. So let's copy the OpenAI API. Here I'm going to paste it. Now let's add the secret. Okay, now see everything is added. Now let me see anything is left. No, everything I have added. Now what I have to do, I have to push the changes. Okay, but before that, let me get back to my project. Now I'll push the changes. So just try to commit. To commit, just open up your git bash and try to write this command: git add space dot, then git commit -m, let's say ci cd edit, then git push origin main. Now if I go back to my GitHub, now see, if I refresh here, so it will start running my action. Now just go to the action. Now see, my action is running. See, first of all, it is running the continuous integration. So inside continuous integration, first of all, it will authenticate with my AWS ECR, build the Docker image, push it to the ECR. Okay, everything will happen. See, automatically. It's just a one-time setup, guys. Next time, you don't need to set up it. You just need to write the code and push it to the GitHub. Automatically, it will push to the let's say AWS server. Okay, now see. So let's wait. Once this execution is completed, I will come back. So guys, as you can see, my continuous integration is completed. Now it is running the continuous deployment. Now what it will do, it will again authenticate with my AWS cloud, and it will pull that image from the ECR to EC2 machine. And if you go to the Elastic Container Registry right now, and if you refresh here, you will see the image. Okay, see, Docker image is been uploaded here. Now see, it is running the deployment. Now see, it is pulling the image. So once it is full, then we'll doing the port mapping. We'll create the endpoint, and we can access our application. Let me show you. So guys, as you can see, my execution is completed. That means both integration and deployment is executed. If you're not getting added, that means congratulations, it's done. Now I will go back to my EC2 machine. Okay. Now here in the EC2 machine, you will get one public IP address. Just let me show you. So this is the public IP address. Just try to copy and just try to open it. Okay. Now see, if I open it up, so it won't be opening because see, my application is running on port number 8080. I think you remember. Okay, so by default port number 8080 is not set. So I have to do the port mapping. So what I have to do, I'll go back, go to the instance. This is my instance. Then I'll go to the security. Okay. Now here you will see one option called security group. Just click here. Now on top you will see edit inbound rules. Okay, just try to click here. Now I'll just add the rules. Custom TCP port number, just give 8080. Just select 000. Okay. And here you will see save rules. Okay, just click on the save rules. That's it. Okay, so rules has been added. Now I'll go to the instance again. I'll open it up. Now I'll copy the public IP address again, and here let me paste. Now you have to give clone port number 8080. Now see, if I hit enter, my application should be running. See guys, this is my chatbot is running. Now if I give any message, let's say what is acne. See guys, it is giving me the response. Now see, my application is live right now. So it is already deployed. Now user can use my applications. Now what you can do, you can buy a domain, okay, your custom domain, and you can publish this application to the audience. Okay. Now for the second time, let's say you changed anything in the code. Let's say you added some more function. What do you have to do? Only just need to commit the changes. It will automatically get updated here. Fine. So no need to set up anything from scratch. It's just a one-time setup. Once setup is completed, just try to commit the changes. It will automatically running. Okay. Now you can ask me, if I close this terminal, will it work? Yes, definitely we can close it. Let's say I will close this terminal. Now if I again go to the chatbot, if I refresh, see, still my bot is running. Okay. So that's how guys we can do the CI/CD deployment. Now let me show you how we can terminate all the instance, like whatever instance we created. If you don't want to keep it running, otherwise it will charge you, right? So what I can do, first of all, I will stop the EC2 machine I've created. So select the machine, click on the instance state and terminate. So terminate will delete it. Okay. So it will terminate and delete the instance. Then after that, I also need to delete my ECR. So let's go to the ECR. So first of all, delete the image inside that. Just write the delete command. Now try to select and delete. Okay, then what I have to do, I have to delete the then I will also delete my I'm user. Okay, the I'm user I created. User. Let's select and try to delete it. Medical chatbot I have to write here. So let me copy. And let me delete it. See, everything is deleted. Now nothing will charge you. Okay. So guys, that's how we can perform the deployment. And this is the code. You can use this code as it is. Okay. The code actually have shared. So yes, guys, this is all about, and I hope you liked it. So thanks for watching, guys. And what you need to do, guys, the next project I showed you now that this one, source code analysis, you can deploy this project with the same process. Okay. Whatever project we have created so far, you can deploy with the same process. Hi everyone. So guys, in this video, we'll be learning about how we can implement RAG application with the help of Vertex AI. So as of now, we saw how we can use model garden. That means how we can access different kinds of model. On top of that, how we can perform the inference. But let's say if you have some custom data, and with the help of that custom data, you want to create a knowledge base and you want to connect your large language model there. Okay, and you want to perform the query operation on top of it. So how we can perform it. And this is called actually RAG. I think I already explained, okay, in my previous video. So if you're not sure about the RAG, guys, first of all, check those videos. Then you will be able to understand, okay, what I'm trying to implement here. So that means, let's say here I'll be using my custom data. And with that custom data, what I will do, I will create a knowledge base. Okay. And I'll just try to connect my large language model there. Then I'll be performing the query operation on top of my data. The data actually I have uploaded. This is the thing we'll be implementing. And here technology wise actually we'll be using the Vertex AI, entire Vertex AI platform. That means here everything will be using Google Cloud services. Okay, we are not going to use any third-party services. That means to store our data we'll be using Google Cloud bucket, and to store our embedding we'll be using vector store. Okay, vector store service from the Vertex AI. This is one of the vector database they have created. Okay, this is called actually vector store. So we'll be using all the Google Cloud service only, not any other service. Okay, in this video. So for this, guys, you can see I prepared one notebook in the Collab Enterprise. So first of all, try to connect the notebook. After that, you can check with the help of OK command. And if it is giving the OK message, that means notebook is running. Then the first thing what you have to do, we have to install. These are the library. As I have told you, we'll be using some custom data. I'm going to use PDF document. That's why I'm installing this PyPDF2. Okay, this library. Then Google Cloud AI platform, because if I want to use the Vertex AI, I need to install this package. Then I already told you we'll be using custom data. That means custom document. And to store this custom document, I'll be using Google Cloud bucket. I think you know Google Cloud also provides bucket service. Let me show you. So if you just open Google Cloud and search for bucket, so this is the bucket. So here you can create different bucket, and inside a bucket you can store the data. See, I already created one bucket called start content 2024. Inside that I'm having one documents. I'll tell you how to upload this document here. As of now, just try to consider we'll be using this bucket services to store my content. Okay, and no need to create manually, it will automatically create. I've already written the code for it. So these are the packages you have to install. For me, I already installed everything, so I'm not going to install again. Now see, you have to import. These are the library right now. So here I'm importing storage from google.cloud, because I told you we'll be using bucket, and to install bucket I need this actually function. Then I'm also importing text embedding model from the Vertex AI language model, because here we have to perform the embedding generation, and to generate the embedding I need some embedding model, and here I'm going to use Google embedding model. Okay, from the Vertex AI, from the model garden. That's why I have imported this text embedding model function. Then I also imported AI platform PyPDF, and these are the library I also imported here. And here I'm using UIID. Okay, why I'm using UIID? Let me tell you. See, there is a reason actually I'm using UIID. See, if you're using Vertex AI, this RAG would be slightly different. Okay, slightly different. That means, let's say whatever documents you will be publishing. Let's say I will be publishing one statistics PDF I'm having. Let me show you the statistics PDF. So guys, as you can see, this is the statistics PDF actually I'm having. So this particular data actually I'll be using as my custom data. Now what will happen? First of all, I have to extract the documents from the PDF, yes or no. So after extracting, what I will get different documents. I think you know, I'll get different documents. That means doc1, okay, then doc2, and so on. Now what will happen? This document I have to convert to embeddings as well. That means it would be converted to embeddings. So let's say you will get some vector here. Let's say 0.29, 0.55, 0.88, and so on. Let's say this is the vector representation of this doc1 and doc2, and so on. Let's say I'll just create some dummy vector here. Now here what I want to do, with the help of this UIID, I want to assign some unique ID. Let's say the document one it has extracted, I will assign one unique ID. Let's say this is the unique ID. Let's say 1210. Let's say this is the unique ID. Okay, it has assigned to the doc1. Then in the doc2 it will assign another unique ID. Let's say 1211. Okay, Now what will happen? This unique ID also would be assigned in the vector, because this vector is representing this documentation, yes or no. Okay, that's why this ID would be there, 1210. Then this ID would be also there because this vector is representing this document, so 1211. Now what will happen? Let's say whenever you will perform the similarity search operation, that time what happens, actually it will return the relevant answer, yes or no. I think you know, whenever you implement any kinds of RAG, whenever you perform similarity operation, it will give you some relevant answer. Okay, relevant answer you will get. Okay, and from where you will get the relevant answer? From the documents only you will get the relevant answer, the documents you are having. Okay, now let's say it will give you this relevant answer, let's say doc1. Whenever it will give you doc1 relevant answer, that means it will return the vector, because your model will only return the numbers, not the text. Okay, and this particular number will map where? In this document. That means this document is representing this vector. That means whenever your model is generating this vector, that means it will map this documents, that means the text. Okay, how? With the help of this UI ID. Okay, with the help of this UI ID. So it will look for where this UI ID is present, that documents actually it will show you as a relevant answer. Okay, now I think it is clear why I'm using this UI ID to give to assign actually unique ID in front of my documents and in front of my vector embeddings. Okay, now I think it is clear. Now let me clear my board. Now the next thing what you have to do, guys, you have to initialize some of the variable. Now see, if you are doing this project from the Google Colab, first of all you have to authenticate with your G Cloud. And how to authenticate, I already shared you two code, I think you remember, two configuration code I shared with you in my Vertex AI demo session. So you can refer the notebook and you can first of all authenticate with your Google Cloud. Okay, until you are not doing the authentication, it won't be working. I'm running from my Colab enterprise, that's why I don't need to do the authentication. So if you're running from the Colab, Google Colab, so you have to activate this line actually, project. So you have to give the project ID here. How to collect the project ID? This is the project ID. Got it? So here I'm running from the Colab enterprise, so I don't need this variable. I'll just try to comment it out. So here what I need the location, and this is my location. Then PDF path. So where you have to upload the PDF. So in the files actually you have to upload the PDF. Let me show you. So here you can right click and upload and try to select the PDF. Whatever PDF you are having, just try to open it here. It will automatically upload here. See, for me, I've already uploaded, and these two files would be generated as of now. See, I already executed this project. Okay, that's why all the artifacts you can see. Okay, but for you, it would be empty initially. So this two file would be created. How it will be created, I'll tell you. As of now, just try to consider we have uploaded the statistics.pdf file. Got it? Then you have to give the bucket name. So you can give any kinds of bucket name and make sure this bucket name should be unique. So this bucket would be created automatically in the bucket section. See, it is already created for me. Again, this would be created automatically. You don't need to create it manually. Then here you have to give embed file path. What is embed file path? Because see, I already told you, first of all, we have to extract the documents from my PDF. Then what we have to do, we have to generate the embedding as well with respect to the documents. And these documents and this embedding, I'm going to save in a JSON file. Okay, that's why I'm just creating some JSON file. You can see these two JSON file I'm creating. Okay, starts embedding .json and starts sentence.json. Inside sentence.json, it will store all the documents, that is the English text, and inside embedding, it will store all the your embedding. Okay, embedding of the sentence. That means whatever, let's say, documents you are having. That means whatever documents you have, okay, with respect to that, it will store the embeddings as well. Okay, with the unique ID. So that is the thing. Then you have to give the index name. Index name means, let's say here we'll be using vector search, and inside vector search, we just create an index. The way actually we used to create the Pinecone index, I think remember, we create an index here. So this is the index name. It will automatically create that index. Now here I've written a function. This function will extract the sentence from the PDF. So it will take the PDF path and it will give you the sentences. That means all the documents it will give you. Then I have written some of the helper function, guys. You can see generate text embedding. That means this function will generate the text embedding. It will take the sentence and it will generate a text embedding with the help of text embedding model. You can see I'm using text embedding gecko model. So this is the model, guys, text embedding gecko 001. So this model is available in the model garden in Vertex AI. Got it? Then I have written another function, generate and save embedding. That means this function will actually add the unique ID in front of your sentence. That means documents, and in front of your embeddings. That means vector embeddings. Okay. That means it will generate this both file. Okay, and it will save as a JSON file. You can see here I'm doing it. I'm first of all actually creating my embedding. Okay, and I'm adding the unique ID. I'm also creating the sentence. I'm adding the unique ID. Then I'm saving in a JSON file. Okay, this is the thing actually we are doing. That means this function is responsible for creating these two files, and it will store your sentences, and it will store your documents as well as the embedding with the unique ID. Okay, that's it. Then there is another function I created called upload file. That means after let's say generating this file, I have to upload this start sentence.json in the bucket. And how I will push to the bucket, we'll be using this function upload file. I can see if you go to the bucket section, so this file is already present. Okay, so if you want to push any kinds of file, you can use this function. That means we created some helper function. This helper function will help me to do certain operation. This is the thing. Now here another function I have written called create vector index. So this function will create the vector index in the vector source. Okay, in the vector source vector database, and each of the dimension would be 784. I think you remember previously we used sentence transformer actually embedding model, and we used to create I think 384 vector representation. I think you remember, right? But if you are using this text gecko model from the model guidance, your vector dimension would be 780. 768. This is the dimension, and you can see with the help of AI platform actually library, we are creating the index. So this function will automatically create the index for you. Got it? Then after that, I'm calling these are the function. You can see first of all, I'm calling generate and save the vector. I'm giving my PDF path, sentence file path, as well as the embedding file path. Then I'm also uploading this file to my bucket. That means if I execute this line, what will happen? It will create this two file. First of all, let me open it. So this is my sentence. That means this is my document, and you can see first of all, it will show you the unique ID. Then it will show you the sentence. Okay, that means this is the document it has extracted from the PDF. With respect to that, it has also saved the embeddings as well. Let me show you. So this is the embedding, and here you'll see the unique ID. That means the same ID, and now this is the embedding representation. Okay, I hope now it is clear. Now, so once it is executed, then upload file will execute, and it will upload this sentence.json to my bucket. Now if I show you, see bucket would be created, and inside bucket actually you will see this start sentence.json would be present. Okay, because later on, whenever I'll perform the, let's say, similarity search operation, I need that file. I need to download that file. With that, I'll do the search operation. Okay, similarity search operation. That is the thing. Now, the next thing, what we'll be doing, we'll be creating the vector index. That means we'll be creating the index, and inside index actually will be storing all of my vector. Okay, so here you can see I'm giving the bucket name. That means from the bucket name, it will load this file. Okay, it will load this file. That means the sentence file. So sentence file it will load. Then it will also take the index name. And with the help of actually that embedding model, it will generate the embeddings of that documents. The documents actually we are having, and it will store to the vector database. That means inside my vector source. Now, if I execute this line, okay, if I execute this line, it will take some time. It will, that means it will process all the data and it will store to the vector embedding. After that, if you open it up, let me show you. So if you open it up, so you'll see that it will create an index. The name actually you have given start index. Okay. Now you can see both places you are getting this green tick icon. That means everything is executed successfully. If you are getting any red icon, it's not completed. Okay, that means there are some issue. Now if I click on the deployed index, you'll see one ID here. So we need this ID later on. So guys, you can see this is the ID. The last number you can see, this is the ID. So we need this ID later on. Okay, see, this is the ID. This ID actually we need later on. So now let's get back to my Colab. Now again, just import some of the necessary library. Then again, set these are the actually variable like your location, sentence file path, and index name. That means the same index name. Okay, same index name you have to give. Start index. Okay, that's it. Then just load the model, large language model here. So here I'm using Gemini Pro. You can also load any other model. Then just try to load the index. That means index endpoint you have to load. And to load the index endpoint, you just need to give this ID. And how you'll get the ID, guys, I already told you. So this is the ID. Just try to copy this ID and just try to paste it here. Now if you execute, it will load the index ID. Got it? That means this is going to be your knowledge base right now. And this is going to be your model. Now again, I have written some of the helper functions, generate text embedding. That means whatever user will give the prompt. Now let's say I have given one prompt. This prompt should be also converted to the embedding. Okay, then this function will help me to do that. Then I've written another function, generate context and load file. That means it will load that documents file and it will generate the context. Okay, that means if you are performing similarity search operation, it will give you some rank results, and how it will give the rank results with the help of these two function, it will give the rank results. Now here I've loaded the file. Then you can see. Then this is my query. Let's say what is correlation. First of all, I'm generating the query embedding with the help of that embedding model. And if you want to see the query embedding, see this is the vector representation, guys. This is the entire query embedding. Now let me comment it. Now this query embedding I will pass to my vector source. Okay, now you can see find neighbor. It will give me 10 rank results. Okay, 10 rank results actually it will give me. Then this response actually I'm giving to my model. Okay, this is the code snippet. My model will try to analyze this response, even the query I have given. Based on that, it will give me one response. Now if I execute, see, if I execute this last line of code, see, here you will get the response. Correlation is a statistical measure that indicates see blah blah, I'm getting the output. And here you can also give the prompt based on the context delimited in the brackets, answer the query. Okay, that's how you can give any kinds of prompt. And that's how actually we can build retrieval augmented generation kinds of application, okay, with the help of Vertex AI platform. And all these steps, guys, I have mentioned here. So if you are implementing any kinds of RAG based actually application, you can follow the same step. Okay, even you can also perform in your local machine. That means I told you how we can connect our local machine. That means how we can connect our VS Code. So with the help of VS Code also, you can create this kinds of RAG application, and you can create a user interface. Let's say you want to create a Flask interface, you want to create a Streamlit interface, you can also create. So this task actually I want to assign you. Just try to create one user interface. So you have to use the same logic, only you just need to integrate one user interface. That is the idea. Okay, I hope it is clear. Now see, once it is done, now if you want to terminate all the instance, what you can do. So first of all, just try to delete this. So first of all, just try to delete the bucket. To delete the bucket, just try to select the bucket, and there is a delete button you will see. Just try to click on delete, and delete confirmation you have to give. So it will delete the bucket. Then you also need to delete the index. So to delete the index, just go to the index, vector search. So first of all, you have to do the on deploy. Then you can delete it right now, I think. Now there is a delete button. Just try to click on delete. So it would be deleted. Okay, so that's how you can remove all the instance you will be creating. Okay, so I think, guys, this is helpful. I showed you the entire like process how we can implement RAG. So in the next video, we'll be creating some LLM powered application with the help of this Vertex AI platform. Thank you. Hello everyone, welcome back. So guys, in this video, we'll see how we can implement LLM powered chatbot with the help of Vertex AI. See, I think you already saw how we can set up everything in our local machine. That means if I want to connect with my Vertex AI, so what are the setup actually I can perform. So setup wise, I already covered in my previous video, so you can check it out. So here actually I've already prepared everything, because see, most of the code are similar, whatever things we implemented previously. So make sure first of all you configured everything, your account, then your, let's say, configuration, everything you just prepared. After that, in the env file, just try to change this project ID and region. So let me copy my project ID. So just try to click here. So this is my project ID, guys. Just try to copy, and let's mention it here. Okay, and region, I'm inside US Central 1 only, and you don't need to change it. Now the next thing, you have to create an environment. How to create the environment, I already told you. Okay, I'm using the same environment, Vertex AI demo. Now you have to install the requirements. So one more requirement I've added called Flask. So let me install the Flask, because in this project I'm going to use Flask. Okay, Flask framework to create the front-end application. So for this, just write this command, pip install -add requirement.txt. Now it should install the requirements. So guys, many people were asking me how to install actually GPU, NVIDIA GPU in our local system. For this, what I did actually, I created one video in my YouTube channel. Let me show you. So if you go to my YouTube channel, guys, this is my YouTube channel. You can also subscribe me here. Now, if I go to the video section, so here I already created one video. Here you can see the video, set up NVIDIA GPU. Okay, so here I showed you all these steps you can follow to set up your NVIDIA GPU for the deep learning task. Got it? So let's say if you're having good GPU and if you want to, let's say, execute open source large language model in your local machine instead of using Colab, you can refer this video that time. And make sure, guys, you subscribe to this channel, because here also I create lots of content related generative AI, MLOps, then end-to-end project implementation, okay, computer vision, everything. Now let's get back. So I think installation is completed. Yeah. Now see what I have done. I created one template file, and inside that, this is my HTML code, because you already know if I want to use Flask, I need a HTML, okay, HTML code to create my front-end part. And again, I used the Bootstrap website to prepare this front-end. I'll tell you whenever I'll execute how it will look like. Now, this is my endpoint app.py, and here I've imported all the necessary library. And these code are common. I think you know we are doing the authentication with my Vertex AI. Now, this is the route I created. This route is my default route. It will launch my index.html page, and this is my prediction route. That means whenever user will give any query, okay, user input, I'm getting the user input, and this input actually I'm passing to my model, and whatever response actually I'm getting, I'm showing in my Flask server. That's it. Now let me execute the application. So what I will do, I'll run this application in the port number 8080. Save it. Now I'll open up my terminal and let's execute Python app.py. Okay, so it is running. Now let's get back. Localhost. Now see, this is how your user interface will look like. Now you can give any command. Now here you can give any query. So I'll ask what is Python. Now send a request. You can also see the log in the terminal. See, I got the response. So this is the complete response I got, guys. Got it? This is the complete response I got. Now if you want to ask another query, just try to refresh. Again, you can pass that query. Okay. Now that's actually what you can do. The previous RAG application we implemented with the help of Vertex AI, you can create your custom RAG. That means you can use your custom documents, like we did one project, like I think remember medical chatbot. So that's how you can use your custom documents and you can create these kinds of application. And this is the front end you can use as it is. Got it? All the HTML code I will share with you. So yes, guys, that's how we can also create LLM powered application with the help of Vertex AI. Hi everyone, welcome back. So guys, in this video we'll be learning how we can, let's say, access this kinds of foundation model with our Python code. That means we'll be setting everything in our local machine. I will be writing everything from our VS code. Okay, so what I will do, guys, I'll open up my local folder, and here I've already created one empty folder. Let me open up my VS code. Okay, so I'm also going to open up my terminal here, and make sure you create one environment. So for me, I already created one environment. So let me activate. So conda activate LLM app. I think you remember this environment we created previously. So I'm using the same environment here, and you can see the Python version I'm using. It's 3.10. So you can use 3.9, 3.8. It's up to you. Okay, here the first thing you have to set up the requirements. So let me create a file called requirements.txt. Inside that, let me mention all the requirements actually I need. So I need the LangChain. Then I also need Streamlit, because I'm going to create a small, let's say, user interface here. And I need two more library, Boto3 and python.env. Python.env, I think you know why we need it, because we're going to create one .env file. Okay, .env file. So inside that, you have to mention the, your secret credential. That means we'll be generating access key, AWS access key, and AWS secret access key. With the help of that, we'll be authenticating with our AWS account. Got it? So we'll be keeping these at the key inside this .env file, and to load it, I need this python.env. And what is Boto3? See, with the help of Boto3 Python package, we'll be making the connection with our AWS. Okay, so this library will give you the functionality. You can connect with your AWS. Now let me set up everything in my environment. So I'll open it up and just write pip install requirement.txt. Okay, for me it is already installed. For you it will take some time. Now the next thing what I have to do, guys, I have to create a IAM user. So let's go to my AWS. I'll go to the home page, and here you will see, or you can also search IAM. Okay, identity access management, because I have to create a user, and there actually I will only give the permission related my Bedrock. Now click on the user. Now just create a user here. I'll give, let's say, Bedrock test attach policy. Now search for Bedrock. I want to give the Bedrock, Amazon Bedrock full access. Now click on the next and create the user. Then after that, I will click on Bedrock test and go to the security credential. And here you will get one option, create access key. Just try to click here. Select command line interface, I understand, and click on the next. Now create the access key. Now, so guys, this is your access key and this is your secret access key. Now you can also download as a CSV file. Let me download. Now I have to configure it. So for this, you have to install one tool actually. So just search for AWS CLI. Okay, AWS CLI. This is the first website you can open. So for all the operating system, they have mentioned, okay, how we can install it. For Linux, Mac OS, okay, see, Linux, you have to execute some of the command. These are the command you have to execute. For Mac OS also, you have to execute some of the command. And for Windows, you are having one MSI file. So you can directly download this MSI file, and you can install, okay, as a software. That means the way you usually install any software. Now next, install, you have to do the same thing. After doing it, let me cancel it because I already have. After doing it, just try to open up your terminal, okay, and execute this command, AWS configure. AWS configure. Now see, if I execute, it should give you this kinds of window. If you are getting this kinds of window, that means your installation is fine. Now what I have to do, guys, I have to set this at the access key. Now let's try to copy the access key. open the terminal, and it is asking for the access key. Just try to paste. Just right click, it will paste, and press enter. Then you have to give the secret access key. Just try to copy. This is my secret access key, and I will paste it here. And don't share, guys, this key with anyone, otherwise they will be also accessing your account. I will delete it after the recording. And now it is asking for the region. Now you can see which region you are in. I'm inside Mumbai, that means AP South 1, so I have to give the region. So you just check which region you are working on. Based on that, you can decide. So AP South 1. Now default output format, just keep it empty, press enter. That's it. See, my credential has been set. So this was the first method. And the second method, what you can do, you can I think you remember we created this .env file. So here inside .env file also you can mention. So let me show you. So inside that you can mention AWS access key ID, secret key ID, and region name. So let me replace all of the secret key again. This is my access key ID. And this is my secret access key. And AP South 1, it's fine. Now let me save. Now here I'm going to create a file. I'll name it as main.py. Inside that I'm going to do the coding. So here, first of all, let's import some libraries. So these are the library I need. Let me select my environment. LLM app I'm using. Now here you can see, guys, I'm importing Bedrock from LangChain. LangChain.llm's Bedrock. I'm importing Bedrock. Then LLM chain, then prompt template, Boto3, and Streamlit. Okay. Then I need another package, this one actually, .env, because I want to load these at the credential. And how to load, guys, I think we remembered. So you have to use this code snippet. So load env, and you also need operating system. With the help of operating system, we'll be loading these at the key, okay, from the environment variable. Now here it will store everything. Now, if I want to initialize Bedrock client, so I have to use Boto3. So this is the syntax. If you go to the documentation, you will see that they're using this syntax. Bedrock client, you have to make a Bedrock client. The Boto3 client, you have to mention the service name. I want to use Bedrock. Okay, Bedrock services. That's why I've given Bedrock runtime. You have to give the region, AWS access key ID, and secret key ID. So with the help of that, it will authenticate with your account. Okay, I hope it is clear. Now, the next thing, you have to give the model ID, like which model you want to access. I'll give the model ID is equal to, let's say I want to use one foundation model. Let's say I want to use this Mistral model. I'll click on Mistral. Now you can see Mistral having different variants, 7B, 8X, 7B, then Mistral large. Now let's say I want to use 7B instruct. So what I will do, I'll copy this model ID. So that's how, just try to open any kinds of model and copy the model ID. And here you just need to mention it. That's it. Okay, so it will automatically load this model. Now let's create our LLM wrapper. So inside Bedrock, you have to give the model ID. Okay, and here you have to give the Bedrock client. Okay, client is equal to Bedrock. Fine. And this is the temperature parameter. That means the creativity parameter. I think you already know. Now here I'm going to create a function. So this function will take the input from the user, like in which language they want to, let's say, get the output, and what is the input prompt. Okay, so this function will take this input, you can see language as well as the user text. Then it is create. Then inside that I'm creating a prompt template. I think you know what is prompt template, right? So this is the input variable, language and user text, and I'm creating a prompt template. You are a chatbot and you are in this language and this user text. Now based on that, you have to give me the response. Now here I'm creating a LLM chain and I'm passing my LLM as well as the prompt. And finally, I'm passing my language as well as the user input to my Bedrock chain. That means the chain I have created. Okay, because inside that I'm having my large language model as well as the prompt. And whatever response I'm getting, I'm just returning. That's it. Now let me create a Streamlit title. Streamlit, let's say user interface, Bedrock chatbot demo. Now user will also able to give the language. So let's say here I'll take a language input from the user. Whether he want to get English response, Spanish response, or Hindi response, you can. So here you can also pass any other language. It will also work, because I think you know these kinds of large language model can also support multi-language. Then this is my final logic. So if language is there, so they will give the input. That means what kinds of question they want to ask. Then once they have, let's say, given the prompt, this particular prompt I'm checking, first of all, this they have given the prompt or not. If they have given, I'm passing it to my chatbot. You can see this function. So it will take the language as well as the user input. Language and user input, and whatever response actually I'm getting, I'm writing in my Streamlit application. Now let me execute and let me show you. I'll save it. Now simply I'll just open up my terminal, and this is the command streamlit run main.py. So this is the interface, guys. Now you can select the language. Let's say I want to select the English. Now here I can ask any query. Let's say, what is Python? Now you just need to press you just need to press Ctrl and Enter. So guys, as you can see, if you give any kinds of prompt, now here is the response. So here I've given what is Python, and here is the response I got. Now I can ask any kinds of query. Let's say I will ask, give me a Python code to add 2 numbers. See, here I got the Python code to add the 2 numbers. Okay, so that's how you can pass any kinds of prompt and you can get the response. It's amazing, guys. And here we're using Mistral model. Okay, Mistral model we are using. Okay, and it is present inside Bedrock platform. That's why this inference time is very low. You will see that I'm getting very fast response. But whenever I was using Mistral model, I think you remember in HuggingFace, okay, HuggingFace Hub. So there I had to download this model in my system, and the execution time was like very slow there. Yes or no, right? So that's why we have to use this kinds of LLMOps platform if I'm implementing any kinds of project, efficient project, okay, in the industry. So yes, guys, now you can explore different kinds of model, different kinds of like foundation model. You can also explore coherent model, meta model, anything you can explore. Only just need to keep the model ID and everything you can access. Got it? So yes, guys, I hope it is clear now how we can use this Bedrock platform. And if you want to get this kinds of content more, so please try to support our channel. So please try to subscribe to the channel, try to share these kinds of content with your friends and family so that they can also get to know, okay, this kinds of session is going on. So please try to support the channel, guys. Try to like the video, try to subscribe to the channel. You can subscribe to the Code Commander channel. Even you can also subscribe to my channel, DS with Bappy. Okay, both channel actually I'm operating. You will see that in both channel I'm creating lots of content related data science, machine learning, generative AI, ML ops, okay, end-to-end project implementation, okay, everything I'm creating the content. So yes, guys, this is all about. I hope you liked it. So thank you so much, guys, for watching this video, and I will see you next time.